Hello guys, so welcome to my channel. So this series we will discuss about with the SQL bootcamp. So I'm planning to record all the sessions of SQL. So this is the introduction SQL introduction, this video. So later we'll continue this series all the way. I will upload all the videos. Thank you for watching for this my channel. Let's continue SQL bootcamp. So first of all, what are the prerequisites are required for this SQL? So you are a beginner or you are a non-coder or you are a non-technical background also, you can practice with the SQL from the fresh. Like just install with the any one of the RDBMS. Like any one of the RDBMS called as install like PostgreSQL, MySQL, Oracle or SQL Server. So I seen in last couple of days from I heard the news PostgreSQL the pre-installation is perfectly not working. So better you can install with SQL Server. I'm also doing the SQL Server only. But the syntax of the every database like PostgreSQL, MySQL, Oracle, or SQL Server, the syntax is to be same. Just a little bit minor, 5 to 10% is to be changing. At the time, I will discuss with that one. Install an IDE such as pgadmin. If you install with the PostgreSQL, you can install with pgadmin. If you're installing MySQL, you can install with IDE, MySQL Workbench. If you're installed with Oracle, SQL Developer. If you're installed with SQL Server, install with SQL Server Management Studio, SSMS, so you can install. Okay, so these are the prerequisites. So which role can you target after learning SQL from this bootcamp? So the roles are in different ways. If you are opting as any role, SQL is to be mandatory. If you're opting as a data analyst, data engineer, data scientist, SQL developer, business analyst, software engineer, quality analyst, etc. If you're opting any role, the database, any one of the database is to be mandatory. But right now, most of the positions are data engineer and data scientist. So this basic SQL, a little bit advanced is mandatory. If you are opting as SQL developer, you need to understand with the advanced SQL also. Okay, so why are you learning SQL? Just now we discussed for the positions of roles, how much SQL should you learn? So basic SQL is first mandatory. If you're interesting, then you can go with the advanced SQL also. The right approach to learn SQL is so basically, so once you learn with the SQL, you need to practice. So practice is much better. So when you practice only, then you can uh, good commanding in the to write the queries. Basic terminologies. So these topics we'll discuss in this video. So data, database, relational database, RDBMS, SQL, SQL, table, column, rows. Okay. So first, what is the data? So generally, the data called as so anything and everything can be considered as a data. So anything called as, so if you consider as any information or any data, any kind of data is called as data. So anything and everything can be considered as data. Any information or fact can be considered as also data. For an insurance company, example, details related to its employees. For example, insurance company details. So its employees data, customers data, product data, or even any address can be a data. So data can be in any form, such as a text message or an image or a video or a document or a single character itself. So anything is a data, but here the data will classified as two types again, structured data and unstructured data. So in this data we are using in SQL Server or in PostgreSQL, MySQL, we are using with the relational data. So and again the data types are data will classified as two types, relational data and non-relational data. So relational data we are using. So relational data called as that is structured data. Next, database. So database is a container. So container which is filled with data or information which is electronically stored in a computer system. So electronically stored in a computer system called as, if you are selecting any data, that data we will store using the tables by our views. So we will store the data in a database. For example, if you're considering with the chocolates, so a bunch of chocolates will take, so those bunch of chocolates we will store in a box. Or if we consider as a milk, so the milk will store it 1 liter of milk will store it in a packet, or 1 liter of milk, we'll store it in a 1 liter container. Like that, if you consider as a data, so the data which is stored in a container, that is called as database. So data in any form can be stored in the database. So in any form can be stored. So the data we have to store in any format. All companies use some sort of database to store their data. So all companies use some sort of databases called as, so for example, one company using with XSQL database, one company using with SQL Server, one company using with Oracle, one company using with MySQL. So like that, so different companies are using with their own databases. Depends on their criteria and their situation. The purpose of storing data in the database is so easily accessed the data, easily to modify the data, protect the data, analyze the data. So for why we are storing the data, call as we had to analyze the data for future purpose. So we had to take the decision making purpose. We had to store the data. Next, how the data, the simple architecture called as how the data is to be stored as like RDBMS versus database. So first database is to store the data like in the container. RDBMS is, so it's one of the application called as, so for example, SQL Server you are using. So in RDBMS you are using with SQL Server. Based on SQL Server, will retrieve the data from the database and application end user. For example, if you consider with the Facebook example, in the Facebook, if you enter with your user ID and password, so what happened? The end user is enters with the user ID and password. So the RDBMS will go and check with the database. So in the database, the data is to be stored. So your user ID and password and will get back. So that is the process about with to connect with the any database. Next, SQL is so what is the SQL? So SQL stands for Structured Query Language, also referred to as a SQL. So the previous name, we call it as a SQL. So SQL is a programming language used to interact with relational database management system and mainly primarily used in RDBMS. So all major RDBMS like Oracle, MySQL, MS SQL, PostgreSQL, etc. use SQL. So using SQL, you can read a data, write the data, create, modify or delete the data, analyze the data, and build the reports. So these process will look into the further videos. So how we'll read the data, how we'll write the data, how to create the database, how to modify the database, how to delete the database, how to analyze the data, and build the reports. So these we'll see later. How is data stored in RDBMS? So generally, in any RDBMS, the data is to be stored as in tables. So table called as is a set of rows and columns. So the point is in RDBMS, data is stored in multiple tables. Each table can have a set of rows and columns. Different tables will be related to each other through certain columns, forming relationship between these tables. So for example, if you are storing with the customer table and order table, so how will give the relation? So customer, how many number of orders placed? So that will check in the orders table. So customer information is stored as within customer table. Orders data is stored in orders table. So we'll give the relationship between customer table to orders table. Okay. So next table. So this is the one sample structure of the sample data in the table. So table 1, row 2, etc. So column 1, column 2, column 3, and so on. The data is to be stored. So this is the one sample format of rows and columns. The SQL will store the data in using tables. Next, relational database. So in the left side diagram, you see with the tables. So for example, here, if you are looking with, for example, this is the customer table and this is the order table. So this customer table, orders table will give the relationship and product table. So product table to customer will give the relation like this. So for example, relation database. So this is the customer table, customer ID, name, age. Second one, orders table, order ID, date, customer ID, product ID. And last one, product table. So product table, product ID, price, currency. So in this, how we'll give the relationship called as, so for example, if you look into customer table to orders table, how the relation. So in customer table, customer ID we are giving. In orders table, in customer ID we are giving. So this customer ID to based on customer ID, we will give the relationship and to join. So this how we can join and the relationship on what basis we'll give the relationship later we'll discuss. Product ID table. So product table. So this product table to order table, how we'll give the relationship based on product ID. Okay. So this is the some sample database. Next, is SQL different in is SQL different in different RDBMS? So yeah, basically RDBMS are these are all the different types: Oracle, MySQL, Microsoft SQL Server, PostgreSQL, etc. So all these are all the relational databases only, but slight difference of syntax. If you know the SQL Server, and you will write the queries about with Oracle, MySQL, PostgreSQL also. So 90% of the queries are same. Only 5 to 10% of the queries are little syntax is to be different. Okay. So later we'll continue with the discussion about with how we'll create the table, how we'll insert the data, how we'll delete the data, how to update the data, etc. Later we'll see. Thank you for watching. Hello guys, welcome to my channel. So today we will discuss about with the SQL series, SQL commands. So first in this first we'll discuss about with the basic SQL commands. Then we'll look into the SQL Server practice. So basically SQL commands are these DDL, DML, DCL, TCL. So some of them are calling as DQL, or the select command also is part of DML. Okay. So let's find the what is DDL, data definition language. So what is DDL called as? Mainly basically DDL is the structure of the data. So we'll deal with the structure of the data. So like the structure of the data called as how we'll create the table, creating the table, dropping the table, alter. So to modify the table name, to modify the table structure by using alter, truncate. So to delete the table, so permanently we have to delete the table, truncate called as. Then DML. So DML is deal with the data. So deal with the data called as, so you can insert the data, you can update the data, you can delete the data, you can merge the data. So these operations by using DML. So basically DDL is the structure of the, it can deal with the structure of the data. DML is, it can deal with the data. So directly we can operate with the data. Then DCL. DCL is the data control language. It can provide the permission, it can revoke the permission. So like grant and revoke. So granting is to provide the permission. Revoke is again taking back the permission. TCL, transaction control language. So transaction control language is the commit, rollback, and save point. So in commit code as permanently to save the data. Rollback is if you have any data we want to roll back, you can roll back to the data. So by using rollback command. Then save point. So we had to save the complete the script we had to save in one save point. Then DQL. So DQL is also part of DML. Some of them are calling as DQL, data query language. So once we have to DDL and DML commands are executed, then we will execute as the selector. So that is DQL, data query language. So select is to retrieve the data. So whatever the tables, whatever the data we are storing into the table, based on the select command, we will retrieve the data based on our requirement. We will write the queries. Let's look into the DDL commands. So DDL commands are data definition language, used to define the structure of a database object, such as table. So using to define the structure. The structure is mainly the commands include create, alter, drop, truncate. So create called as to create the table, to create the database. Alter is to modify the data, to modify the table structure, to modify the table naming or database name. Drop, so to drop the table. Truncate, so permanently to delete the drop the table. So here one difference is a drop and truncate. So drop is completely the table is to be dropped. Truncate is also to execute the, to truncate the table, means to delete the table, but permanently. There is no structure also once we execute the truncate. Then how we'll create the table? So here we'll execute the table using create command. So let's take one example here. The this one called as create table if not exists. Student. So student is the table name. So to create table if not exists called as, not exist is if any student table is existed, then again we can't create with the table. So if not exists, then we can create the table. ID, so varchar. So varchar called as the data type. Primary key. So these keywords I will explain later in the coming sessions. Primary key called as basically uniquely identify the values and not null. That is the primary key. First name varchar, last name varchar, gender varchar, check constraint. So we are checking with the constraint. Check gender in male or female. Age int, DOP, date, grade, float, is active, boolean, constraint. So constraint we are executing. So these conditions will execute later stages. Just in this one, we are what we say, just will high level look into the DDL and data types. So these are the data types we are following: int, number, varchar, string, date, float, decimal, boolean. So some example table. So we'll create the table using SQL Server. So here I'm creating one table called as hospitals. So create table hospitals, hospital code as int, hospital name as varchar of 50, location as varchar 200, contact number big int. If we execute this hospital table is to be, the structure is to be created. Okay, commands complete successfully. If we want to check with the table, select a star from table name, table name called as the hospitals. Select a star from hospitals, execute. You see this one, hospital code, hospital name, location, contact information. So what we are giving the column names: hospital code, hospital name, location, contact number. So these 4 columns created using the table name as the hospital. That is create. Select is this one. So select called as a DQL, data query language. Then data definition language on part of create. Then drop also part of DDL. So what is the DDL? So if I execute the drop table hospitals, so table is dropped. If we check with the select star from hospitals, so there is no table. Okay, the structure is to be deleted. Then we'll create one more table as create table hospitals tab. So again, it will create the table. Okay, so this way we will execute with create, select, drop. Okay, so later we'll see the other part scenarios in the next video. Thank you for watching. Hello guys, today we will discuss about with the DML statements, DML commands. So last video I posted as the DDL, data definition language commands: create, drop, alter I have covered. So this video will cover as the insert and some commands called as the create and primary key, not null, unique. So these will cover as in this video. So basically DML statements are insert, right? So we'll jump into the SQL Server. So last video I have given us the select a star from hospitals. So this table we created and we need to insert some records. Okay. Here, for example, first I will create as one table like hospitals. Okay. Hospitals table is creating. So for right time being, just comment with the primary key. We'll execute this. Okay, so table is created. What table I have created? Drop table if exists hospitals. So if any hospital table is there, drop, then create the table hospitals. So hospital code int, hospital name, varchar, location, varchar, contact number. So table created. Now I will insert some values into hospitals. So this is the insert command. So insert into table name as the hospitals values of. So this one hospital, better I will move this code into above hospital table. Yeah. So here, if I copy here, so hospital code was 1, hospital name as Fortis Hospital, hospital name Bangalore, and location. Sorry, location is Bangalore, contact number is this one. So if I execute this, by default, it will execute. Okay, there is no issue. Why I am mentioning the issue code as here I am taking the one more record as 4. So duplicate record I am inserting. So it will insert the all records. Okay, so all records are affected. And if you see the select a star from hospitals, so all the records are available. Okay, so here what we have to mention here mainly to create the table is this one, create table, table name, and inserting the records as insert into table name values of, and to provide the values this way. Okay. So if we display the table name, select a star from table name. So by using this, we can display the table. Okay. Now, we will discuss about some constraints. So we know right now create, insert, and drop also we know. Now we will know with some constraints. So first, what are the constraints are available? So constraints are basically primary key, foreign key, not null, check, unique, and identity column. So these are the constraints basically we are using in the SQL. So let's go with first primary key. What is the primary key? So primary key is make sure that the column does not have null values and is always having unique records. So here we can observe with two conditions. First is uniquely identify all the records. Second one is not null values. So it does not have a null value. Okay, so it is not accepting the null value. That is the primary key. And one more condition is, so within the table, how many number of primary keys we can create? Only one primary key only it will allow to create the primary key in the within the table. So in one particular table, how many number of primary keys will create? Only one primary key. That is clear. Now, within the table, one primary key is allowing, but is that condition is one column or multiple column? Yes, multiple columns we can create as primary key. That is constraint we can use. So primary key of example, like hospital code, hospital name, student code, student ID, student name. Like that, you can give as multiple columns to give as the primary key. Okay, that is clear. Now we'll create with the primary key. For example, here I'm taking as the example only hospitals. If I take as the hospital code int primary key, okay. So this primary key will create as by using in the within the table. If I again execute this one, I'm creating again the table. Same table I'm creating again by using primary key. Now I'm inserting the records, first 4 records only. Okay. First 4 records are inserted. Now, can I insert this the last row like 4 again? If I execute this, is that error or done? So obviously we will get the error because of I am giving the primary key is hospital code. So again, it will not allow the duplicate value. Let's see. So violation of primary key constraint PK hospital. So by using primary key, it will not allow the duplicate values, like uniquely identify all the records. And if you are entering with any null values also, it can't accept. Let's try with one null value. Null. Okay. Null is just give, okay, it is taking. If I execute this, yeah, cannot insert the value null into column hospital code. Okay. So this is the condition we'll see. Now, one more condition I will give here. I am removing this primary key here. I will give as in the constraint. So what constraint will give? So constraint name as PK hospitals, primary key of. Here I am considering as multiple columns. So multiple columns as hospital code, hospital name. So by using this constraint, we can give as primary key to multiple columns. That is the benefit of constraint. Again, I am executing this. Okay. So command successfully created means table is created. Now, if I execute the first 4 records, done. By default, it will allow all the records. Now, if I execute the last record, that is null, whether it is accepting or not, yes, it will accept because of it is the combination of yeah. So I think null value is not accepting. Yes, yes. So null value not accepted. So if I execute here, so cannot insert the null value. Okay, got it. So again, if I give you here 4, for example, 4, same record. So whether it is accept or not, 4. Okay, but constraint is here primary key of hospital code, hospital name. So this value is insert or not? Yes, it is accepting because of hospital code and hospital name based on the combination. So that is 4 Duke Hospital. That is not a duplicate record. Let's execute. One row affected. Okay. Now, if we check with the total number of records in select star from hospitals, 5 records are available. Okay. Okay. Right. So this is the hospitals by using primary key. Next, not null. So what is the use of not null? So define a column as not null if you never want to have null values in it. So once you not null means once you declare as the particular column as not null, it can't accept with the null values, but it will allow as the duplicate values. Okay, so primary key is different, not null is different. Primary key is it will not allow the null values and it will not allow the duplicate values. But not null is only it will not accept the null values. Right. Same example, if you look into, okay, so this time I will create as the doctors table. Okay, so this table I'm creating, okay, with the primary key of not null. So ID as primary key, first name as not null, last name as not null. If I execute, okay, command is successfully completed. Let's see the doctors values. So insert doctors. So these values I will copy into the doctors table. Okay. So here I am inserting the values of doctors table as first doctor ID, doctor first name, last name, specialization, gender, and date of birth. So here I'm using with the date of birth. Actually, date of birth I have given as date. Okay, but here I'm converting this to varchar. Okay, column type I'm converting to, sorry, not this one, gender. Okay, so gender I have given as big int. Gender I have given as big int. So big int I'm converting to by using column type varchar. Okay, so that is this one. Next to date is I'm converting this to date format. So DDMMYYYY. Next to salary and hospital ID. Now, if I create with the first table, I'm executing with the alter command including also. Done. Okay. Next, if I insert with the these values like insert, I'm inserting these many records like 6 records D1, D2, D3, D4, D5, D6. So these 6 records I'm inserting. If I execute, 6 records are inserted. Okay, fine. Now, if I insert the last record, like again D6 and a null value, is it accepting or not? No, because of the null. So this null as first name and last name. So first name I declared as not null, last name declared as not null. Because of it is not accepting the this record. See, cannot insert the null values. Okay. So this way we'll execute not null. Next, check constraint. Okay, so check constraint is validates with the given list of values and unique. Unique also avoid duplicate values, but it allows null values. Okay, so before explaining the check constraint, I will conclude with the unique. So unique is mainly avoid the duplicate values, but it allows null values like primary key. So primary key is not accepting the duplicate values, not accepting the null values, but unique is accepting the null values, but not accepting duplicate values. That is the difference. Let's see one unique example here I have mentioned. Yes. So let's keep gender sometime or else. Okay, let's keep it unique. And at the same check constraint also given here in this one. So let's see the check constraint. So check constraint is validates with the given list of values. So we'll give the check constraint like, oh, for example, if here see here in the table patients, check gender in MF. So if it is accepting only MF and male, female. So these values only it will accept. Other than that, those values it can't accept. So let's create the table first. Patients table. So table is created. So what conditions I have given here? Patient ID, patient first name, patient last name, gender, date of birth, phone number, blood group. Okay. Now we'll execute the this one. Let's copy into above patients table. Okay. So let's see the first row. Patient ID, patient first name, patient last name, gender. So gender as given as male, and date of birth converting to the date format, and phone number, blood group. Let's execute these values. First, I will execute the P1 to P6. 6 records I'm inserting. First, done. P1, P2, P3, P4, P5, P6. Till P6 is fine. Select a star from patients. See, 6 records are inserted. Now, I want to insert the again this value like patient's values P5. So whether it is accept or not, because of why I'm considering P5 called as mentioned as unique. So unique records are, again, I'm giving the P5 example. So whether it is accept or not, no, it's not accept because of it. Unique, if you mention the unique, it is not accepting the duplicate values. Okay, so violation of unique key constraint. Okay, right. One more example for a check constraint. Yeah, so check constraint here only, I will do this P7 fix. I'm giving as the another name called as the fix, whether it is accept or not, check constraint. Okay, what is the error? The insert statement conflicted with the check constraint CK. So check constraint, what I have given as check gender in M, F, male, female. So if you enter M or F or male or female, then only it will accept the check constraint. Otherwise, it will throw the error. That is the check constraint. So let's summarize the constraints. So first of all, primary key called as, it will not allow duplication values. It will not allow null values. Okay. Then not null. Not null means not allowing the null values. Simply check constraints. So validates the given list of values within the check. Unique. It not allow. It will not allow duplicate values. It will allow null values. That is the unique constraint. And primary key, within the table, we can create only one primary key. Within the primary key, you can mention one or more columns, like multiple columns you can create. That is the primary key. So this is the summary of all the constraints. Okay, thank you. Hello guys, today we will discuss about with the foreign key for our continuation of SQL series. So first of all, what is the foreign key? Foreign key is a relation between two tables like parent and child. So build the parent and child relationship. That is the foreign key. So relationship called as, from one table to another table, we are providing the relationship. Okay, connection between the two tables, that is called as foreign key. So let's try to build the foreign key. First, I'm building with the parent table, like a master table. So in master table called as doctors. So in this, I will build this one. First, I will create the this what we say master table created. Now I will insert some records into master table. So 6 records I have inserted. Now I will create as the child table, like slave table. So drop table if exists medical records. So medical records ID in problem as the varchar. Here what I mentioned as doctor ID, varchar of 15 references to doctor's ID. So this will go references doctor's ID called as, directly it will refer to above this one, doctor's ID. So this ID will touch. So doctors of ID. So doctor's table as this one, doctor's table, and ID as this one, primary key. Now you got this one, right? So in child table, what I mentioned as, I created as doctor ID column, varchar of 15, references doctor's table name. This is the doctor's called as the table name, ID as the above doctor's table column name. Okay. Now first I will create this column, this table, child table. So table is created. Now carefully observe. Now I will insert one by one record. So medical records, first record inserted. Second record inserted. Third record inserted. Now carefully observe fourth record, what happened. Okay. So we get the error. What is the error? The insert statement conflicted with the foreign key constraint. So the foreign key condition is violated. So because of, what is the error of this one called as, if you observe with the select star from doctor's table, now select star from if I execute. So if you carefully observe with the doctor's table, 6 records is there. So those 6 records are D1 to D6. But if you see the medical records, the last column, doctor's ID as D7. So D7 is not available in parent table. So If parent table, the record is available, then only the child table will allow to insert the record. Otherwise, it will violate it. So that is the parent and child relationship. Now what we will do? We will insert the record into doctor's table, then we'll try. So now I'm trying the inserting the record into doctor's table, like the D7. So if I insert this one, record is inserted. Check the doctor's table, D7 is there. Now I will try to insert this medical records table in the child table. Okay, record is inserted. Now we will check the record. Select star from medical records, semicolon, execute. So 4 records is there. So this is the way we will try to build the relationship between one table to another table or parent to child relationship. This is called as the foreign key. For example, if I try to remove the parent table, so is it remove or not? No, it can't remove. For example, if I am trying executing this one, so could not drop object doctors because it is referenced by foreign key constraint. Okay, so directly if you are removing with the parent table means no, it is not directly removing. First you can drop with the medical records, that is the child table. If you drop with the child table, so child table dropped, so there is no table. If you execute select star from medical records, there is no information. Now if you drop with the main table, parent table, then done. So this is the process about with the foreign key build parent and child relationship. So I will share this code in the description. Please try. Thank you for watching.
Hello guys, today we will discuss about with the identity column in part of our SQL series. If you like the content, please like and subscribe. Previously, I have done the videos, all the basic introduction and primary key, foreign key, unique key, check constraint, not null, and DDL commands. All these commands covered. So in this video, I will cover as the identity column. So first of all, what is the identity in SQL we are using? So basically, identity is the auto generate of column values. So auto generate called as, so for example, if we taken as the medical records, so medical ID, in medical records, so we are giving as the ID number. So per day, medical records will receive as thousands or lakhs. So at the time, day by day, the records are increasing. So we are not giving any ID number, but specifically. So by default, ID number will take. So that is identity column. So we'll take as one example here. So first of all, basically identity column is auto generate column values. Here I'm taking the example as first I will remove the medical records existing table. So the table is to be dropped. Now I'm creating with the table, create table medical records. So ID as I'm giving as int identity primary key. So this automatically to create the unique value of every record. So remaining the table is giving as the same. So now I'm creating the table. So table is created. Now if we check with the records, okay, so table created, ID, problem, date of examination, parent ID, doctor ID. Now I will try to insert one record. So insert into medical records values, ID as the one. Then remaining records are same as usual. I am taking. If I execute, what happened? If you see the error, an explicit value for the identity column in the table medical records. So by default here, I have given the value 1. So actually that is not required. When we declare as the identity, this value is not required to mention here. By default, it will take. So now I'm trying to remove this value and insert. Okay, one record is inserted. If we check the records, so one record is, so by default ID number as 1. So 1, food poisoning, date, patient ID, and doctor ID. Similarly, I will try to insert the other records. So I'm inserting 3 records. 3 records inserted. Now I will check with the medical records table. Total 4 records are available. So this is the example of identity column. So in this is I'm using with SQL Server. If you are using with any other what we say PostgreSQL or MySQL. So similar example, it's just a small variation. Check with the syntax if you are using with the any other database. Thank you for watching. Please like and subscribe. Hello guys. Today we will discuss about with some basic SQL queries. Previous we seen the DDL commands and DML commands, and now we'll see with some basic SQL queries how we'll write the SQL queries like select from and where condition like. So first I'm creating the one table here. The table is looks like this one. IMDb top movies. So I'm creating this entire what we say the table. So poster link, series title, release year, certificate, runtime, genre, IMDb rating, overview, metascore, director, star 1 and star 2, 3, 4, number of votes and gross. So just I taken with uh, the structure of the table, and I am pulling the records from the chart GPT to insert the records. So because of multiple records we need to enter, so the for time waste process. So the same example I have pulled with these all the records I am pulling from the chart GPT. Let's see one of the syntax. So how we'll see insert into IMDb top movies poster link. So title poster link as this one example.com poster1.jpg. Series title, this one, released year 1994, certificate R, and runtime as 142 minutes, genre drama, IMDb rating 9.3, and overview, this one, two imprisoned men bound over a number of years. Next to Metascore is 80, and star next Metascore director. So director as Frank Darabont. Similarly, star 1, 2, 3, 4 number of votes. So star 1, 2, 3, 4 number of votes and this number of votes and grass. Okay, I'll share this code entire thing in the description. Please look into that. Direct, I'm executing with select a star from IMDb movies. Control C. I'll paste this before the script. Let's execute this. So here total around 26 records is there. I'm not pull much more records. Just I taken 26 records from ChatGPT. I have taken this script and within fraction of seconds I have loaded this data. And now we'll look into the basic SQL queries. Okay. So first basic SQL query. So the first the query name is fetch all data from IMDb table. Fetch all data from IMDb table. So first I will write the query as basically, first I will write mention as select from where. So if you write any basic SQL query, we'll write 3 rows, select from where. First we'll discuss about with these 3 statements. What is the select statement? Select statement is so whatever the columns in the table, that columns we are mentioning in the select statement. So that is mention the columns to be fetched. So whatever the columns we are fetching, for example, if you take as student data, student name, student ID. So we'll write as student name, student ID. If you are not mentioned any specifically column names, just we'll put as the star. Star means within the particular table, all the columns we will have to fetch. That is the select statement. Next, from. So from is from where we are getting the data. So which table? That is the table name. So that is mention the table or tables. So multiple tables also we have to mention here. From where the data needs to be fetched. So we'll mention as table name, from table name. Next, where can. So where is just condition. So condition called as we have to filter the data. So within the particular table, I want only student name as Vijay. So where student name equals to Vijay, or I want within the student table roll number 59. So where student ID equals to or student roll number equals to 59. So that is a simple way we have to write as the where condition. Where condition is simply we have to filter the data, whatever the column. Okay. Next. So fetch first query is fetch all the data from IMDb table. So I'm writing as so select a star from IMDb top movies. So select here why I have mentioned as star called as all the data. Here question is all the data from IMDb table. So star from the table name. So which table we have to fetch the records. So IMDb top movies. So if I execute this, so all the records. So if you see 26 records we are getting here. Okay. So this is the first query, basic as query. Then second query, fetch only the name and release year for all movies. Okay, first we'll write a select from and where. Okay, so fetch only the name. So name called as which name? So movie name. So movie name called as title name. So we will understand as series title. So series title. First we will write as series title. Next release year. So year called as. So we have the column is released year. Series title comma released year from which table name? IMDb top movies. So fetch only the name and release year for all movies. So there is no filter condition here. So I'll remove with where. So there is no where condition in this one. So execute. Only I get the series title release year. So I want only the name and release year. So title and release year getting. Next, third query, fetch the name. So we have to get the name. So name already we know, series title as the name. Release year. So already above query we know, release year also. And IMDb rating. So if I execute entire table, so we'll look into IMDb rating. So this column has the IMDb rating. Okay. So what we can do, select series title, comma, release year, comma, IMDb rating. Next, of movies which are R credit certified. So certified as the R. So certificate column, I want to filter the records as R. So which are R certified. So here in the certificate column, different certifications is there. Okay. So in this one, I want to filter is R. So how we can filter? First, three column names are done. Fetch the name, release year, IMDb rating is done. From which table? IMDb top movies. Then where condition, filter the data. Where, which column name, that is certificate. So where certificate equals to, within the double quotes or single quotes, we have to mention as R. So then simply we can filter the records of only R. Okay. So whatever the certificates are getting, so 17 rows are certified as the R. Okay. So this is the third query. Next, fourth query, fetch the name and genre of movies. Okay, up to I am stopping here. Fetch the name and genre of movies. So first title and genre I have given. Next, which are R certified. R certified called as above we have given as certificate equals to R. So from this one is common from table name and where certificate equals to R. This one is common. And have a IMDb rating of over 8. So we have IMDb rating also mentioned. So in the select part, we'll add as IMDb rating. But here the condition is which are R certified is one condition, one filter, and have IMDb rating of over 8. So over 8 called as, if you look into the table, okay. So IMDb rating of over 8. So this is the IMDb rating. So in this over 8 means greater than 8. So IMDb rating, I want greater than 8 movies. So what I can do here in the question only mentioned as AND. So one AND means that is the operator. So we had to use the operator where certificate equals to R and IMDb rating greater than 8. So that is we will get as the greater than 8. So if you look into this column, IMDb rating, all the values are greater than 8. So total how many rows? 14 rows we are getting. So how I know? Here in this case, I have to use only AND. So in the question only we have to understand. So question is which are R certified and is mentioned here. Okay. And have a IMDb rating of over 8. So how I know the operators and examples, etc. Just Google it, W3 schools SQL operators. So if you see the SQL operators, so what are all the operators I have? So operator and description also given. So these symbols we have to use in the SQL query. For example, I want to add addition. So plus, add, minus, subtract, multiply, star, slash, divide, percent, modulo. Next, bitwise operator, and bitwise and bitwise R, bitwise exclusive R. Similarly, comparison operators. So equal to, greater than, less than, greater than or equal to. So here you have to understand greater than and greater than or equal to. For example, in this case, I will use with greater than 8 right now. If I use greater than or equals to 8, what happens? If I use greater than or equals to 8, previous there is no 8 in this column. Now we'll see. So now I will get the 8 also. So that is the difference. So greater than or equals to 8 means, so including 8 also. If I remove equal, greater than 8, so not 8. So above 8, 8.1 onwards. Okay. So similarly here, we need main, the important operators are these three. So operators in SQL called as arithmetic operator, logical operator, comparison operator. So arithmetic operators just now we seen addition, subtraction, multiplication, division, and modulo. Logical operators are and are like in, not in, etc. So main in SQL we basic need three types of operators are arithmetic, logical, and comparison. So a lot of operators is there here. If you see SQL compound operators and SQL logical operators. So logical all and any between exists in, like, not, or, some. So many operators is there. Okay. So but main important these three, these symbols, these one regularly we will use. Okay. Next query is find out how many movies are of drama genre. So here a question is some little bit not much, little bit difficult, like find out how many movies. How many means we had to how like we'll ask the question how many movies we have seen in the last week. So we'll say count like 3 or 4, 5. Okay. So find out how many movies are like count. So how many movies means here we are finding the count. Movies are of drama genre. So in the particular table, this is the table, right? So in this drama genre, so genre called as the drama category is there. So in this category, we have to find out how many number of movies of drama, the count only, not in detailed way. Okay. So we'll write as select. Here we are not taking any column names. By default, direct we need only count. So write function name. So come function called as the count function. Count of star. So here why we had to star? Star means if you mention any column name or else you can mention as star. So if without mentioning the column names, it will take as by default star, or else you can mention as 1 or XYZ, etc. Okay, we'll see that later. Select count of star from table name. Okay, and we have to filter as drama genre, right? So where genre like. So why I have to write as like. So previous we are using as filters like and condition. So here I'm using is the logical operator like. So within the category we have to find. So this syntax is genre like. I will write as here within the single quotes. I will write as percent and particular keyword what we are searching. So it will search as wherever the keyword this one drama. So it will search in the entire column. For example, I will give as drama percent. So starting letter drama, it will search. If I give like starting percent this way, and so ending letter, ending word. So ending word it will search as drama. So like, but I want wherever within the column wherever it is. So that is percent drama percent. Okay. So I will execute this. I will take as count. For example, if I give as 1, what it will give the output? Same. There is no difference. If I give XYZ, I don't know whatever it is. So XYZ will give single quotes. Okay. Okay, same output. So what if you mention with column name, for example, if I give as here genre, like genre, ENRE, genre. If I execute this, output will be different. If any null values depends on. If we give star, entire table will count, but entire table within the particular genre, how many number of dramas. Or else if I give as here, for example, another column released year. So in this one released year. So if I execute released year, if any empty rows in null rows in the released year, the output may be different. Okay. So here I am using currently star. Okay. Next, for example, in case in the particular column, if any uppercase letters is there, so we don't know. Okay. So in that case, we'll write as upper of genre. So like if I execute this one, output is to be same. Okay. Or else count of 1. Just now I explained. Okay. Next to count of series title. So just now, if we mention with column name, if any null values is there, So it will take as the different output. So in this way, count of series title, and the next query I'm executing as count of certificate. So this way, the output may be different if any null values. For example, if you see this one, select count of 1 from IMDb movies where series title is null. How many number of rows? So if I execute this, 0. So 0 null means, so there is no effect in the above two columns. If I execute certificate, 0 nulls. So if any null values, it may be impacting the result. Next, so if you identify the null, so this is the way. Select a count of 1 from IMDb movies where series title is null. So it will display as how many number of rows in the table null values. Similarly, the next query is, so how many movies are directed by these many names? So directed by means the director. For example, if you execute the table, I will execute the table name. Okay. So now my question is here, how many movies are directed by? So means director. So one particular director, how many movies are directed? So where is the director column? Yeah. So in this one, director, he mentioned as Christopher Nolan, how many movies directed? Ridley Scott, how many movies directed? We only count out. So these are all, how many, these all people are directed by how many number of movies, only count. So similarly, above same condition here, but only where condition will change. So where condition, how will write? Above we have written as like %, right? But here I'm not writing as only single column here. So I'm searching for within the particular column multiple values. So then I will give as director in. So select count of 1 or count of star from IMDb movies where director. So I'm searching for the column name as director, right? So where director, why I have written as in operator. So in means, so I'm searching multiple values. Okay. Or else we will write as where director equals to this one, where director equals to this one, where director equals to this one. Or we'll write as where director Christopher and director Ridley Scott and director David Fincher and director this one. This way we'll write, or else within the in operator. So we'll write this condition. Okay. So just I'm copying this entire values into here. So select a count of 1 from IMDb top movies where director in. I'm giving this one. Okay. So if we execute, we'll get the count of 9. So these all people are directed by 9 movies. If I execute, select a star, I'm not writing the count. Then what happened? So whatever the movies they directed, all the details will be displayed. Means in detail, all the details. So here, select a star from IMDb movies. So 9 rows we are getting here. So 9 rows we'll get. So this is the way we will write as the basic SQL queries. Thank you for watching. Please ping in the comment your feedback, or if you like the content, please give the like and subscribe and give one comment. Okay, thank you. Thank you for watching. I will post the script in the description. Just look into it. And this is the part 1. I am executing 6 queries, and some other queries I will explain in part 2. Thank you.
Hello guys. Today we will discuss about with the continuation of the SQL series, basic SQL queries. So part 1 covered. We have covered as IMDb dataset. 6 queries covered in part 1. So we'll continue with the part 2 from other queries. So first of all, in the first query we covered as what is the highest IMDb rating given so far? So if we execute the table as select a star from IMDb top movies, if I execute, let's connect. Okay. So here I have the records as complete 26 records I have available. So within these 26 records, I want the query is highest IMDb rating given so far. So IMDb rating called as so this one, this column ratings is available 8.1 so and so. Okay. So our condition is highest IMDb rating. Highest means the max rating. So max function. So select max of IMDb rating as max rating from table name. So if we give as movies, so that is optional. I have given this some table name is renaming. Okay, that is not impacting anything.
we remove, also remove. Okay, no problem. So if I execute this, so I'm getting the max rating as 9.3. So max has the function. So our question is highest IMDb rating given so far. So we will cover as the function as max. So let's see some functions. What are all the functions are available and so on. So functions are mainly, what is the function? So first of all, basically function is it returns a value. So basically it performs some action or calculation. So inbuilt functions are mainly functions which are available by default in the database are string functions, date functions, aggregate functions, numeric functions, window functions, user-defined functions. So this way the different functions are available. So but mainly we have to use is mainly, so one of the string function has toCat. Frequently we had to use in real-time scenarios. And date functions, toDate. So one of the important aggregate functions. So important function is one of the important functions is aggregate functions. So in aggregate functions, we have cover as so minimum, maximum, sum, average, count. So these frequently we had to use in our real-time scenarios. So in aggregate functions, so for example, we will take it as minimum. So it will consider as the minimum value, maximum value or highest value. So min value is lowest value, sum, total, average. So we know average AVG function, count. So to display the count. And numeric functions, window functions. So some of the window functions are mainly rank, dense rank, lead, lag, row count, row number. So these are all the window functions. And user defined functions. So user has to create which are the functions instantly. So that is the user defined functions. So for example, if you consider as the inbuilt functions are, so inbuilt functions are mainly toDate. So minimum, max, length, concat, sum, substring, count, cast, lpad, rpad, trim, toChar, upper, date diff, avg, average, char index, get date, so lower, right, left, call SE. Call SE is the one of the important function, and list aggregation. So these are all some of the examples functions we have to see in the coming examples. So right now we have seen with the one of the function as the highest IMDb rating. Highest IMDb rating we will use as the max. Simple. So if I use execute this, the max max IMDb rating as 9.3. Then, so we'll see one more question, one more query. So what is the highest and the lowest IMDb rating given so far? So highest means we already seen max of IMDb rating as the highest rating. So lowest means similarly vice versa, opposite. Min of IMDb rating as lowest rating from IMDb movies. So this one we know. Highest rating as 9.3, lowest rating as 7.7. That is fine. But here I have the query is though to display highest rating and lowest rating within the same column. So here these two are the two different columns it's showing. For example, I want to display as first row as the highest rating, second row as lowest rating. How we can see? So that is this one. So question is query, solve the above problem but display the results in different rows. So in different rows called as two rows we had to display lowest rating and highest rating. How we can display? By using union operator. So here you know the operators, union, all, intersect, except, minus. So just look into the overview of this union, all, intersect, except, minus. So later I will do one video to cover all these operators. Okay. So right now we are doing union operator. So to display the results in different rows. So like two rows we have to display as highest rating and lowest rating. So for example, highest rating called as max of IMDb as highest rating, union, min of IMDb rating as lowest rating. So if I execute this, two rows will display, but the column name is by default it will display the first row, highest rating. Okay, but two rows the output is to be showing. Okay, but here first row value is showing as 7.7 and 9.3. So that is also some confusion. So let's do one thing. So first column is will display the values, and second column I want to display as so first row as lowest rating, second row as highest rating. How will display? So this one will do the like hard coding. So by using hard code only, it's possible this one. So if I look into this, solve the above problem, but display the results in different rows and have a column which indicates the value as lowest and highest. So first row value
for example 7.7, so which is lowest, 9.3 which is highest. So that way we can do. So that is same query by using union only, but hard coding the value is this one. So this one called as highest rating. So we'll do here hard coding. For example, select max of IMDb, okay, as movie rating. So movie rating will give display as the title movie rating, and hard coding is highest rating as high low from table name union. Similarly, min of IMDb rating. So here no need to require again movie rating. So if we give also the same thing, okay, otherwise ignore. So lowest rating as high low. So here what we are doing hard coding, highest rating we are doing the hard coding to as high low, lowest rating as high low. So the high low is the column name. If I execute this, see here. So column name as display as high low and movie rating. So movie rating is the first column name is showing as movie rating. So first row 9.3, which is highest rating, 7.7 lowest rating. So this is this question one of the interview they are asking. I think this question is covered by Ford product based company. 2 to 3 times they are asking this question. I seen I mean 2 to 3 different interviews, different persons are facing this question. Okay. Right. Next question for is find out the total business done by movies starring Tim Robbins. So you have to find the total business done. For example, total business means gross. So if I execute this table, let's quickly. So what the question is, find out the total business. So total business where it is showing gross. So gross amount this one done by movies starring Tim Robbins. So starring means like star 1, 2, 3, 4. So the star. So which is star? So the star is the actor is Tim Robbins. So whether the Tim Robbins is in any of the star, like star 1, 2, 3, 4. Okay. So they are not mentioned any specifically star 1 or 2 or 3 or 4. So if Tim Robbins, wherever it is, either in star 1 or star 2 or star 3 or star 4, wherever it is, we need Tim Robbins total sum of the business. For example, Tim Robbins star 1 this one. So in Tim Robbins graph is 35 million. Similarly, if Tim Robbins is available in star 2, let's sum it. If Tim Robbins is available in star 3, sum it. Available in star 4 and sum it. We don't know whether it is star 1 or 2, 3, 4. Just I'm taking as the first row Tim Robbins. Okay. So total means, for example, if we want to display as total business folders, first by default sum of gross. Okay. Select sum of gross from IMDb movies up to till this point. Now the filter condition is where. So our condition is by movies starring Tim Robbins. So Tim Robbins is where Tim Robbins is available as in star 1 or 2 or 3 or 4. Means star 2, star 3, star 4. So star 1 equal to Tim Robbins, or star 2 equals to Tim Robbins, or star 3 Tim Robbins, or star 4 Tim Robbins. So here why I can use with the R condition called as, so we don't know. So whether it is star 1, 2, 3, 4, wherever it is. Okay. If I place as uncondition, all conditions should satisfy. Okay. That is not true. So either star 1 or 2 or 3 or 4. So that's why I have used it as R condition. So if I execute this Tim Robbins, 35 million, this one. The same thing we'll write as another way. Just here I have written as where star 1 so and so, star 2 so and so, like this. But I will write as where reverse way, where Tim Robbins in star 1 or 2 or 3 or 4. So here I am not mentioned R, but by default it will consider as in operator. So star 1, 2, 3, 4. So if I execute this one also, we'll get the same result. Okay. Next, so how I know whether this one is good correct or not? So if I execute separately, like for example, select a star from star 1. First I am executing star 1. So star 1, what is the sum? 35 million. If we execute star 2, there is no record. So similarly, star 3, there is no records. And star 4, there is no record. So This way we have to test the result. This is the very less number of records, then that is fine. But in real-time scenarios, if millions of records, we have to test some test cases. So some sample result we have to consider. Any one product result we have to take. So that product result we have to submit. So that is the way we have to test the result in real time. Okay. Next. So this is the truth table. How we can apply whether it is and or. So why here how I know the and or condition called as or condition is. So if we satisfy two conditions, then if the condition is failed, for example, if I use here and condition, so star1 true and star2 failed, for example, star2 failed means if star2 Tim Robbins not available means failed. So and true and false, what happened? False. So that is the reason. So that is not in this case we have to use as or condition. So that is the truth table we have to follow this one. So truth table is and or truth table. So if true and true, true, true and false, false, false and true, false, false and false, false. Similarly, we have to follow this or condition also, the truth table. So if you check with true and false, false. So that's why in above in this query, I'm not using with the and condition. Okay. So here I have taken as one example where star1 equals to Amir Khan and star2 equals to Amir Khan. So for example, if Amir Khan is available, okay. So if Amir Khan is not available in star1, then failed. If star2 available, okay. If not, failed. So then false and false also false. False and true also false. True and false also false. So that's why we have used it as or condition above. So based on the scenario, we have to apply with the and or or. Next, find out the average. Next query. Find out the average IMDb rating of movies. So here we want IMDb rating average. Better I will consider it as a table. Here I will run the table. Okay. So if I read the query, find out the average IMDb rating. IMDb rating, this column as average. We can apply straight away. AVG of IMDb rating, which are neither directed by. Neither means neither, not in. Okay. So neither question is only not in or neither. Both are same. So neither directed by. So how will I write the condition is here. Select first AVG of IMDb rating as average rating. That is fine. From this table up to this part is fine. Now, which are neither directed by. So these names are given. These are all the director names. So director means director names. So directors are this one. So in this column, where director not in. Okay. So these columns directly will write where director not in and apply the same names. Above same names we have to copy here. Then next and apply. Here only the twist are not acted by. Are not acted by. So not means again we have to apply not in only. So above condition neither directed. So neither directed means the director is not directing. So not in and are not acted by. So here the last condition and are not acted by. So not acting means acting. So the actor is not acting. Okay. Of any of these stars. So these stars are we don't know. So whether it is star 1, 2, 3, 4. So that's why we had to write as 4 conditions, 4 different ways. Star 1 not in, star 2 not in, star 3 not in, and star 4 not in. Here, why we have to apply the and condition called as though. So we don't know. So whether it is not in. So and condition. So that's why select average of IMDb rating where director not in games names and star 1 not in and apply the names. Star 2 similar thing again. So if I apply here, average rating is 8.44. So except these directors and actors, the average rating is IMDb rating 8.44. Next. So here, display the movie name. I'll execute first the query, general query. Now, display the movie name. So movie name is series title. Okay, select series title. And watch time. So watch time called as runtime. Where it is runtime? Yeah, this one. So watch time, so runtime in both minutes and hours. So they are asking both minutes and hours. So here we have only minutes only available here. This one we have to convert to hours, which have over 9 IMDb rating. So IMDb rating is 9. So IMDb rating 9 means where IMDb rating greater than 9, and between, and watch time is only both minutes and hours. Okay, let's see. Select series title, and runtime is synonym is runtime minutes. Okay, that is fine. Next, watch time in both minutes and hours. So first we'll consider as hours first. So hours is, so minutes by default we'll get. Okay, that is no worries. So for hours I'm getting as first so this one will convert to the data type. Okay, so as decimal because of the runtime we'll consider. Okay, so by 60. So generally per hour 60 minutes for less. So divide by 60. Simple thing. So first what we can do, replace runtime minutes. So in place of minutes, we will do empty. So at the time, for example, 142 minutes. So I will get as 142 because of this varchar data, right? So this one I will convert to decimal. So first, what we can do, replace. First, replace what minutes MIN. MIN will replace to number. So this up to this part is as decimal. This replace this renaming is to decimal. So what this meaning is, replace runtime to me converting to minimum is to be deleting. Next, cast, converting this one to divide by 60. So cast. So why I have used the cast for this? So this data type will convert to decimal. So as decimal by 60. So divide by 60, we will get as the runtime hours. So the runtime hours, so for example, 142 divided by 60, some decimals will get, okay, points. So those points we will do as rounding. So by using round function, we will apply as this one, round. We want only 2 decimals we are fixing. Same function, copy, apply the round function. So round off, comma 2 as round runtime hours as rounded. So this complete we will do as in single query only, single line, single query will write. But I have written as again second line I have written. Okay, for clarity purpose I have written as second line. So round off 60 comma 2. So 2 decimals will get. That is the runtime hours from this table name. And final condition is IMDb rating as 9. So IMDb rating 9. So if I execute this, I will get the movie name and watch time. So movie name, so runtime minutes and runtime hours and runtime hours rounded. So if you see here 2.3666, that rounded to 2.37. Okay. So this is the one example query. And we'll see what are different certificates given to movies. Movies, different certificates. First execute this one. Now, what is the question? What are the different certificates given to movies? So different certificates. So this one. So these are all the different certificates only. If I run with by default without distinct, what happened? Select a certificate from IMDb movies. So these are all the certificates. For 26 rows is available. So 26 rows is showing. Okay. But I want only different certificates. So different means only the distinctive. So what is the distinct means different only. So uniqueness. So that's why I have written here distinctive. So distinct. Up to we'll execute this. So this is the 3 certificates distinctive. And here we covered as order by also. So order by 1. So order by 1 means by default it will execute as the whatever the in select statement we are writing the column names order, first order. So first order means the first column, order by 1. So if I execute, by default it will take as the ascending order. If we are not mentioning anything, that is by default it will take as ascending order. So PG, PG13 and R. Okay. Next to order by certificate. So this one also same. In place of order by 1 and I have written as certificate. There is no difference. Okay. So here in this query we covered as distinct and order by 2. Above the functions we covered as cast, replace, round. 3 functions covered. Okay. Next So this is one lengthy query. Okay, we'll do the parts as much as possible. If I execute first this part, okay, we'll get the, okay. Now, first we'll read the query. Segregate all the drama and action movies released in the last 10 years. First, segregate all the data based on drama and action. So, drama and action, which category? Genre. So, select first title name as movie name. Okay, and genre. So, in genre, we need drama and action. Next, released in the last 10 years as per their runtime. Okay, and movies shorter than 1 hour should be termed as short film. Movies longer than 2 hours should be termed as longer movies. All other can be termed as good watch time. I mean, so if within the 60 minutes runtime, then short films. Within the 120 minutes runtime, then longer movies. All other good watch time. So above 2 hours. Okay. So first we'll write as these two conditions we'll write. So 1 hour, 2 hour, and good watch time. Simple. So first we'll write as select series title as movie name. That is a movie name series title by default column. Here the case condition is, so above we written as the already replaced runtime minutes, so we know. Okay. By using the cast, we can converting to decimal, and after then we are writing with the round 60,2. Okay. Now we'll get the minutes right here. In this one, we'll get the minutes. So first condition, movies shorter than 1 hour, so less than 60. So means 1 hour. So when less than 1, so case when this complete function less than 1, then short film. When greater than 2, then longer movies. Else good watch time. So this one will write easy, right? So in this one we covered as case condition. So case first condition is true, then okay. If the second condition is true, then okay. If two are not okay, then L goes to else. For example, if first condition true, then ignore this part. If two conditions are ignored, then else condition will execute. From up to this part, we will get as only this category wise movie name and category. But here our condition is drama and action movies. So drama and action movies are part of genre. So, and one more condition is PG. Last 10 years as per their runtime. Okay. So released year PG also. Where we mentioned as PG. Segregate all the drama and action movies released in the last 10 years as per their runtime. Okay. When released year PG. Okay. So other than the PG is asking their runtime. Okay. So for example, where release year not equal to PG and date part. So here we want only what is that last 10 years. Okay. So last 10 years how we can convert date part. So first we will get the date part of year comma get date. So get date function is, if you execute this part, we will get the year 2024. So that is the get date function is to get date of YYY or else year of get date function. The same thing here I have written here. So date part of year comma get date minus cast of released year as int. So from current year. So this, if you execute this part, you will get the 2024 minus last 10 years. So we are reducing minus 10. That is only right. So last 10 years. So then drama and action part. So if drama is available as in upper, just I am using as upper condition, and lower condition as for action movies. So finally we will execute order by category. So finally, if I execute this, we will get only good watch time. So actually, if we have any less than 60 minutes, then we'll get the short film. If greater than 120 minutes, we'll get the longer movies. Else good watch time. So these are all above 120 minutes runtime. Let's check the runtime how it is. If we check the runtime here, if you see everything is in above 120 only. 130 one condition is there. But this one, this is not PG. So here we have written the condition as released year not equals to PG also. Okay, so anyway, released year not in PG. I think this condition is not required here. Released year. Remove this part. Released year. This is not relating to our query. Remove this. Now, when released year PG. So we now database PG is not available, and in our query also PG is not there. Okay, fine. Let's execute again. Incorrect. Undo. And is this part. We'll remove this. And yeah. So we have good watch time. This part. Okay. So let's try your end. I will share these queries in the description. Okay, let's try and comment it. If anything need, let's comment in the chat. I'll get back. Thank you for watching. So in this part, I covered as most of the functions. Okay, functions are mainly first aggregate functions covered, and seventh one, this one. So aggregate functions covered. Eighth one also aggregate function, and ninth one we covered as aggregate function sum, and next this and or operators covered, and functions covered. So replace, cast, round, and next distinct keyword. So distinct class covered, order by class covered, then case also covered here. Okay, thank you for watching. Please like and subscribe. Please give one like if you like the content. If you like the content, please give one comment in the chat box. Okay, I'm requesting to you. Thank you for watching.
Hello guys, welcome to my channel. So today we will discuss about with the inner join. So basically what is the inner join? So generally join is mainly where we had to use called as if the data is available in multiple tables. For example, I have customer information available, customers table, product information available in products table, orders information available in orders table. So at the time we will get the data from multiple tables. So at the time we will use with the join. So join different types is there that we will discuss later. For current, in this video, I am discussing about with the inner join. So basically inner join, what is the use called as? So we will select the records that have matching values in both the tables. So always it will fetch us with the matching records between the both the tables. So we'll look into this this information. I created with the 3 tables here. I will share the create table code, and inserting code I will share in the description. Let's look into this. How I can create with the these tables are I will show here. I created a simple table as the products table, product code, product line, and price. So product code as the primary key. So this table is created, and customers table, simple table as customer ID as primary key, and some common columns I have considered, and sales order. So sales order also we have given as the references have considered here. References products, product code, references customers, customer ID, and order number as the primary key. So this identity I have given as 1,1. So by default order number it will save as unique number. And now I will select with sales order. So this is the sales order table. If you look into order number, unique number is given, and quantity ordered, how many number of quantities ordered, price each, and sales, order date, status. So status, different type of status is available, shipped, and this one has disputed and in process. So this way the status is available, and quarter ID, month ID, year ID, product, customer, deal size. So this is the information about with the orders table. And let's look into the customer table. Customer table, customer ID, customer name, phone number, address, city, state, postal code, country is there. So this is basic customer requirement details. And product table, product code, product line, and price. So if you look into product line, different product lines is available. Motorcycles, classic cars, trucks, and buses, So these are the some planes, vintage cars, okay, trains, etc. So different products are available in product line. Okay, so basically inner join is always we have to fetch with matching records between the both the tables, two tables called as. I will look into some query based on these three tables. I have written one query. The query is we have to find all the orders which do not belong to customers from USA and are still in process. So here we will consider it as first find all the orders. So orders table, we know orders table. So in this orders table, we will get all the orders, okay, which do not belong to customers from USA. How I know? Customers which do not belong to customers from USA. So in this customer table, uh, sorry, in this orders table, I'm not getting any customer information. So here I have the customer information C1, C2, C3, and order number is there. And other than that, there is no information about with the customer. So only in the orders table, customer ID is there, like C1, C2, C3, C4. So where this information is available, which do not belong to customers from USA. So this information is available in customers table. If I look into this customers, so in this customers table, we'll look into the country. So country as USA. So our query is this one only, right? Yeah, belongs to customers from USA. So country USA is there. So in customer table. Next up to this one, fine. And next one is and are still in process. So still in process, so where it is available, that is status. So if you check into sales order, still in process. So if you look into shipped, status as the in process. So in this sales order table, so we have the status column is there. So in this status column, we'll check with the distinct. So select a distinct status from sales order means, so we will get the unique records of the sales order. So if you check with in process, so in process is there. So based on this, now we will write the query. So this is the three tables I have given this one. So if we check here, we'll write here. Okay. So first what we had to do, we'll write the basic functionality, select from where. Okay. So this is basic. From which table? First we'll consider it as a sales order. Sales. I'll copy this one. Sales order. Sales order, I will consider it as a yes synonym, like alias name as the yes. And we had to join with which table? So we'll join with customers table. If we look into customers table, what is the common, sorry. Okay. So if you look into customers table, so I have customer ID, C1, C2, C3, on. Some customer information is there. And if you look into sales order, I have the common column as the customer, C1, C2, C3, C4. So based on the common key, we will join two tables. So where from sales order, yes. Then we'll write here, inner join. So which table? Customer table. Copy the customer table name. Customers. I'll give as alias name as C. Now, on which basis the condition? So the condition I will give as customer ID. Already we seen the column names, customer ID and customer. So in sales order, we will consider it as a customer, and in customer table, customer ID. So on C dot customer, C dot customer ID, right? Customer ID equal to S dot customer. Okay. So this is the join condition. So join customer C on C dot customer ID equals to S dot customer. Now up to this one, fine. Next, where condition. So where condition, what is the where condition? Which do not belong customers from USA. So USA is, we'll write this column, right? So where it is customer table. So in customer table, country is USA. Where C dot, where country, right? Where country C dot country. We'll write C dot country. Okay. So C dot country not equal to USA. I will put in single quotes. Okay. So not in USA. So then select statement is, in select statement, I want to find all the orders. So orders table. So yes, sales dot star. If I execute this, what I get? USA. So we'll write how we know the USA not available. Okay. So USA is okay, fine, and are still in process. So this status we don't know. So we'll find the this status also. Okay. So here I have find the just written the distinct command, right? So on hold, shipped, disputed, in process. So status as in process. So in this one, I will write as and one more condition as s dot status. Yes means sales order. S dot status equals to single quotes will write. So I will copy this thing and put here. Okay. Now if I execute, okay, 37 rows I'm getting. Okay. So this way we will write with the using the inner join, we will get the information. So basically here we will write as inner join, or we'll write as the join also. If I remove the inner, what I will get the output. Okay, same thing. So we'll write anyway. So we'll write as inner join or join. So both are same only. Okay. So find all the orders which do not belong to customers from USA. Here two conditions. So why I have used it as and only here? Here there is no R condition. So from USA and are still in process. So that is the reason I have used as and. Okay. So if I execute this part, this is there 37 rows, right? Next query, second query, same inner join we'll use. We'll write one more query here. Find all orders. Find sorry. Find all orders for planes, ships, and trains. So which are neither shipped nor in process nor resolved. First, we'll look into this part. Find all orders. Orders are available as from sales order for planes, ships, and trains, where it is available. Planes and ships. So these planes, ships are available in product line. I think products table, right? So you'll get back to products table. So in product table, we'll take as distinct, then we will get easily. Sorry, copy and paste. Here I will write a distinct product line. Product line from products. If I execute, okay. So you look into this. So our query is for planes. So we have planes available, ships available, and trains available. Okay. So orders table we know, and products table we know. Next thing, which are neither shipped nor in process nor resolved. So neither means not in. So not in shipped, not in process, not in resolved. So this one we know orders table. So in orders table status. So again we'll go back and execute the sales order distinct. Okay. So look into this one. Shipped, which are neither shipped is available, in process available, nor resolved available. So now we know two conditions. So first condition is status one condition, status where status not in, shipped, in process, resolved. That is one condition. And product line is planes, ships, and trains. Okay. We'll write here, select from where. So already we written the join condition, right? So same way we'll write the join condition first. So select from which table, sales order, or else copy the same thing. Select from sales order, yes, and we'll write join. So which table I need to join? Products table. Join products P on. So now on which condition? So now we'll check the condition. So products table, product code is there, product line and price. We'll check in the sales order. What is the product is there, code is there. So means column name as the product and relating information is there. So if we check with products also, product code is similar to. Now we'll write the condition as so s dot product, right? So s dot product equals to p dot product code. Okay. Now where condition. So where condition as where product line, where product line in, I'm giving all the names in the single line. I mean single process, like planes. This one copy, or else yeah, here I will copy this one. Planes, say same name we have to copy exactly. Just will give one single quote second, third. So planes and ships and trains. Okay. So now first condition I have given where product line in planes, ships and trains. Now and so why I have used it as uncalled as so this is continuation for planes, ships and trains which are neither shipped or not in process. So that's why I'm using with the and condition here. And next sales order status, right? So sales order status. So in status, so s dot status. So here in product line also we'll mention as p dot product line s dot status, which are neither shipped nor in process. So not in. Then we'll write first one, comma, second one, comma, third one. So now I will copy with which are neither shipped. So shipped copy and write here. Next to in process, copy and write here. And resolved, copy and write here. Okay. Now find all orders. So select a statement as s dot star. Now you look into the query, find all orders s dot star for planes, ships and trains. I have given as where product line as planes, ships and trains, which are neither shipped or means and status not in, shipped in process result. So now we'll finally semicolon and execute. Okay. So total 52 rows I'm getting. Okay. So this is the way we will write as the inner join second query. Now we'll write one more query here. Find orders which sold the product for price higher than its original price. So first to find the orders table we know, find the orders which sold the product for price higher than its original price. So higher than its original price, so where it is available. So original price is available as in the price. So price table called as the products price means. So here original price product information and price each sold as. So price each is product for price higher than its original price. So in sales order we have the price each is there. For example, 95.7 first order number. So this is the one price and products table price has the one. So now we will join here two tables. One is the products table and sales order. Again, it's the same thing. Here join as sales order with products, right? The same thing we had to join. Just we'll copy with the same thing. Okay. Select sales order, yes, join products P. Okay. Now the condition is to be same. Okay. Now where condition is, so where condition we have the product higher price, right? Higher than its original price. So in product table, price is there. Okay. So P dot price as the product table and sales order table. What is the price column? Price each. So price each is yes dot, right? Price each, yes dot price each greater than P dot price. Okay. So this way we will get the higher than its original price. Original price is the product price, P dot price. Product for price higher than its original price. Next, what are all the requirement? Find orders. So orders S dot star I'm giving. If we check this, what is the output? Okay. So this is the way we'll get the output. But exact output, how we'll get? I want only original price and price higher than, and difference we'll see. We'll look into that. So that first we'll look into order number. So for example, S dot order number, comma S dot price each, that I know already in the sales order direct column is there, or else we'll call it as this one, sold price, comma, and product price as P dot price, this one as original price, org price. Okay. Now if I get 3 columns only, right? So order number I know, sold price and original price. So original price is 95, sold price as 95.7. So easily we have to find price higher than its original price. Now, which is sold the product for price. So for example, how I know the difference of this one, these two difference? Here we'll create as one more column as difference called as sold price minus original price. So if I write directly sold price minus org price as price difference. Okay. So if I execute this, is it getting or not? So we'll getting the error. So why? Invalid column on sold price. Sold price is we are getting, yeah, S dot price each, right? So S dot price each we have to write here. Sold price and original price also will write as P dot price. Okay. Now see the difference. So 0.700 something. Now what we'll do? Rounding. We'll apply the round function. Round off this one, comma 2, as I'm taking the rounding off to 2 decimals. Okay. Now easily we'll get as the difference. So 0.75, 1.6635. Okay. So this is the way we will find the price higher than its original price. So this one also we are executing with inner join only. Okay. So this is the inner join, some examples. Thank you for watching. Please like and subscribe if you like the content. Thank you for watching. Hello guys. So today we will discuss about with the group by. So in a continuation of series, so today we will discuss about with group by. So last video I have discussed about with the inner join. So at the time I have created with the 3 tables. So the 3 tables are mainly sales order, customer, and products. So the same 3 tables I'm continuing with this group by. Okay. So first, what is the group by? So group by is mainly it creates a group for every unique value. So every unique value called as, for example, if we execute to select distinct status of sales order. So if I execute distinct means that is also unique, right? Sales status in sales order status is available. Yes, available. Select distinct status from sales order. Sorry. Execute. Okay. So these are all the unique status. So similarly, group by also it creates a group for every unique value like this. So distinct always almost similar to group by. So whatever the distinct or unique elements is there, unique values. So those unique values we have to get. So creates a group for every unique value present in the column or list of columns. So for example, if we keep this side and find the average sales order price based on deal size. So here our question is find the average sales. So average sales called as, so we have to write with first we'll write select from where Okay, so select average sales. So AVG of sales, we'll write this way. Okay, and but here the continuation of this one, the question is order price, average of sales order price based on deal size. So deal size called as, for example, if we check with the table, so this is the sales. So based on the sales, we have to get average sales. Okay, that is fine. And our question is based on deal size. We'll get this part is separate. So based on deal size called as, so this deal size column has distinct deal sizes. If I mention here deal size, so deal size, distinct deal size, three rows, large, medium, and small. So we have to get average sales of large average sales, medium average sales, and small average sales. So that is the sales order table. So how? So this is the deal size. Now how I can write? So from table as the table name, sales order, from sales order. Now where condition in this where condition is required. So where condition not required. Now I will remove this where condition. Okay. So from where condition in place of where condition, I will write as the group by. So on group by what basis? Order based on deal size. So now we'll write as group by So deal size. So deal size column, this one. Deal size. Okay. So now I will get the information about with average sales of this one. So for example, I will give as average sales. Okay. If I execute, so average sales I'm getting, but there is no so this first row is on which basis, which category, we don't know. So that we have to mention in the select part. So group by deal size. So we are dealing group by and deal size, right? So we have to mention the column name as in deal size. So if I execute this, now I will get the deal size large. So this number average, medium, this number average, small, this number average. So this way we have to find the group by. So creates a group by for every unique value. So unique values in this one, large, medium, and small. So if you check with this distinct also, unique values are 3. So our query also showing us the same thing, right? Small, medium, and large. Okay. Now, for example, the same thing, if I write, for example, if I want to count, I will put the comment and I want to write as the count of star. What, how I can get? So count of star is, I will get the count. So if I give as here as count, okay, I'll get the count. In place of average sales, every deal size, I'm getting the count. So large 157, medium 130, 1384, small 1282. If I put the comment this one also, what happened? Only I will get the deal size. Because of aggregation function, we are not mentioned. So that is mandatory. We have to mention as the aggregate function. Okay. So in this, we have to see as the rules. So rules for using the group by, how we can use the group by function, on which basis. So first of all, first point is only the columns mentioned in group by can be present in select clause. So only columns mentioned in group by columns. For example, if I mention group by deal size, so deal size I can mention with in select part, then that is okay. If you are not mentioned deal size in select part also, it's okay. For example, if I remove this part and I will executing count. So now this one works. Okay. So this part is option. In group by we had mentioned as deal size, but in select class I haven't mentioned. So can be present. So that is, if you want the particular deal size, we have to show, right? For example, this count 157. How we can know that? We don't know. So that is the reason we have to mention as deal size as here. Now if I execute, so deal size large 157, medium 134. This one. So this is the first one option, one rule. And select a class cannot mention columns which are not present in group by class. For example, in this part, I am not mentioned in the select class. Okay, so that are not present in group by class. And are columns not present in group by can be mentioned in select only. Yes, if they are enclosed within a aggregate function. So in this case, just now we executed, right? So without mentioning as the aggregate function. So this one is not working. mandatorily will give as any one aggregate function in group by. Okay, right. So this is one example. And for example, we'll check with select, or else I will write this way. For example, if I am writing without mentioning with this part, comma, select deal size, count of star as count average sales from sales order. So this one will work? No, because of the deal size we have mentioned in the column. So select part. So in select class cannot mention columns which are not present in group by class. Okay. So compulsory we have to mention as deal size as in the group by, this one. If I remove this deal size, if we execute this part, then this is okay. So this is complete entire table, not for the any one particular what do we say, any one particular category. So the so group by is, so if we mention in the select class group by, then compulsory we have to mention as in the group by. Okay, so this is this query will execute it as the entire table values. Next, we'll look into some other examples. So how we can deal this one. For example, select deal size. Or else I will copy this part. We'll write separately here. If I write this part, so select deal size, count of star as count. Okay, average sales. So if I remove this part, so this, if I execute, so this one works. So I will write as works. Okay. Now, for example, if I mention with the same thing, I will write as here, comma status. Okay. So this one works or not? So this one does not work because of column sales order. Status is not mentioned in the group by. So if we mention in the select part, then definitely we have to mention as in the group by. So this does not work. This does not work. So if I write same thing, status I will mention as in the group by. So now it will work. So now it will work. So now the status, so now how it is working as group by, deal size and status. So here how many combinations is there? So for example, you check with the deal size, select distinct status from sales order. If I execute, how many combinations? 6 combinations. So 6 and deal size 3 categories. So 6 multiplies 3, 18 categories. So we have to show as the 17 rows I'm getting. Okay. So 17 rows will get the this data. So this way we have to execute as the group by. So these rules we have to must and should we have to follow. So group by is one of the important function in our daily life, and the joins also very daily in our daily life. Regularly we have to use with the joins also. Okay. So this is the one example for group by. Thank you. Thank you for watching. Please like and subscribe.
Hello guys, welcome to my channel. So today we will discuss about with the continuation of our SQL series group by. So last video also I have done with the group by. Last video I had done with group by using this one. This example I had done. Okay. So in this example, we will look into some other scenario. Let's look into the query. Display the total sales. Display the total sales figure for each quarter. Next, represent each quarter with their respective period. First, we'll understand this part. First, half of display the total sales figure for each quarter. So first, I will write as the select from. So in this, where also we'll write. For time being, I'm not writing the where condition. Next, select from. sales order. Okay. Now I want display the total sales. So total sales called as sum of sales as total sales. Okay. Next, for each quarter. So for each quarter called as for time being, I will remove this as each quarter. So I will write as group by quarter ID. So already we know in the sales order table, if you look into this column as the quarter ID. So we will extract from the order date. That is one option. And if the column is available directly, then we will use that column as this one quarter ID. So in this scenario, we have the quarter ID is available for time being. So I will use directly as the quarter ID. So group by quarter ID. So we want for each quarter. So group by quarter ID. The same thing we will mention as in the quarter ID in group in select clause also. Okay. So total sales called as sum of sales. Okay. And next, we'll look into represent each quarter with their respective period. Okay. So with their respective period called as, for example, this quarter ID 1. So quarter ID 1 called as first 3 months. So Jan, Feb, March. Second, April, May, June. Next, July, August, September. Last 3, October, November, December. Okay. First, I will execute this part. We'll look into the output. So if you look at this one, we are getting the total sales for each quarter wise. For example, quarter ID 3, I'm getting this number. Quarter ID 1, I'm getting this number. Okay, that is fine. But the second part represent each quarter with their respective period. So each quarter, we have to mention as their respective period. So respective period called as, so we'll write as, for example, quarter ID 1, Jan to March. So that we will write as by using case statement. So in place of quarter ID, I will write as the case statement. So case, how we'll write the case? Case when quarter ID equals to 1, then Jan to March. When quarter ID equals to 2, then April to June. When quarter ID equals to 3, then July to September. When quarter ID equals to 4, then October to December. Then end and period. So this column as we are calling as the period. So this case statement completely we are calling it to period. From sales order, this one entire thing same. Now what I have replaced in place of quarter ID, I have done as the this part. If you look into this quarter ID, is in place of 3. So 3, what I will get July to September. These quarter ID numbers are I'm replacing. Let's execute this. Okay, I'm getting this way. Okay, right. If I write another way, the same query, look into this one. What is the difference of above query to this one? I write as the else part. So what is the else part? So else part is mainly in place of quarter ID 4, I just taken as the else part. So if, whether this one is correct or not means, so this output is to be same. Okay, we will get the output is to be same. But the major condition is if the data, the backend data we are getting from the is it looks good. Means if the data is in correct format, then we will get the else part. Okay. Otherwise, if the data is something, some problems or some null values or something, some numbers is mismatching, then we will get the wrong result in this else part. But in this case, when quarter ID equals to 4, then only we will get the October to December. Okay, so this is the way. So this one also correct only. I will execute this part. Okay, so this is also correct. Now, in place of we'll write as another case statement. So another case statement called as we'll look into this part where it is the table. Okay, this is the table, right? Okay. So here, for time being, I explained the query based on quarter ID. Okay. For example, in case I have no quarter ID, okay, let's assume, then I have the order date only. So based on order date only, we will extract the month. So that months we will consider as the first 3 months as the quarter 1, next 3 months as quarter 2, like that. Okay. So we'll write that way. Now, so first, as usual, select sum of sales as the total sales. Now, case condition is now I'm writing extract with the order date. So how I can extract with the order date to month? Case when.
month of S dot order date. S means sales order is simply I renaming the name is alias name as S. So S order date, S dot order date between 1 and 3, then Jan to March. So between means, so this part, so this order date part is between 1 and 3, if either first month or second month or third month, then Jan to March. Similarly, we will write as other 3 case statements. Okay. So like between 4 to 6, between 7 to 9, between 10 to 12. That is fine. Same thing we will do as the in group by part. The same thing we'll copy and apply with the group by. If I show the entire query. Yeah. So just I had it taken as this part only. Case when month of order date between 1 and 3, then Jan to March. When month of order date between 4 to 6, April to June. Just same thing copy and paste it in the this part in group by part. But in SQL server, in group by part, this direct this alias name is there, right? Quarter QTR. So QTR will write as usually, but in SQL server it will not allow to write as the this one. If you are executing in PostgreSQL or MySQL, you directly write as the QTR. So how we'll write the QTR called as? So just and paste here. Sorry, in place of this one, we'll write as QTR. So this way we'll write as the simple one. Okay, but in SQL Server it will not allow as the QTR. Okay, so direct alias name it is not allowing. So you simply copy and paste it in place of QTR. Now I will execute this part. Okay, we are getting the same result. Okay, right. Next one. If we add QTR ID also, so same thing. Just we'll add with the QTR ID. If extra one more column we'll add in the. If we add in the select part QTR ID, the same thing you will add in the group by also. Select group QTR ID. QTR ID means direct column is available in. So sum of sales. This is the case statement from sales order group by. So now I mentioned as QTR ID because of in the select statement I have mentioned as QTR ID and copy paste as select statement case order by. So order by means so that quarter ID will display as 1, 2, 3, 4 by default ascending order it will consider. Now we'll execute this part. Okay. So 1, 2, 3, 4. But one more column is added. Same thing QTR ID and QTR. Okay. So this is one example scenario by using group by and case. Next, we'll look into another scenario. So another scenario is identify how many cars, motorcycles, trains, and ships are available in the inventory. Treat all type of cars as just cars. So all type of cars called as, for example, first we'll execute the table. We'll look into this part. Sales order. So in sales order, where is that motorcycles, cars? In sales order, that column is not available. Then go back to products table. Yeah. So if we check with product table, distinct product line. So if I execute this part, you look into this part, product line. So our question is mainly cars. So cars are treat all type of cars as just cars. So all type of cars called as classic cars and vintage cars are considered as the cars. Then motorcycles, then trains, then ships are available in the inventory. Okay. So planes is not considered here and trucks and buses are not considered here. So we have to filter this part. Okay. So except trucks and buses, planes, we will write the where condition. So filter, how we can filter where condition, right? Okay. Now, first we'll write as the select from where. So in where condition, what I can write? Where product line, just same thing we have to copy, paste below. So same first motorcycles, trains, ships. So cars are, for time being, I am writing with classic cars and vintage cars. Okay. Here I will write as this part with product line for time being. Product line. Okay. So where product line in same thing I have written here. Okay. Next, if I write where condition here, okay, fine. Then identify this part, okay, available in the inventory. How many cars? Our question is here. How many means we have to count the cars. Okay. So whether how many number of motorcycles is there, how many number of trains, how many number of ships, how many number of cars. So then we'll apply with the count. So for this count function, we have each and every category wise. So then we have to group. So group by what we have to apply here, group by. Here also we'll apply this part to group by product line. I will write as directly product line. Okay. So in select statement, I have written as same thing, product line. Okay. Select product line. Now we need how many number of cars. So apply with the count function. So count of one as number of vehicles. Okay. Now we'll summarize the query. Select product line. Okay. Same product line will apply as the group by product line. Count of one. So count of one as number of vehicles from products. Where condition above same thing we applied here. That is fine. And group by product line. Up to here only I'm stopping the query. If I execute this part, okay. Okay. Now we'll look into this part. So product line, I'm getting the classic cars and vintage cars. So actually we need to combine these two. Later for next scenario, we'll write the another case statement and we'll combine this one. For time being, I'm applying with where condition. So classic cars, ships, vintage cars. Okay. So we are getting the count. Now next step is we have to combine with classic cars and vintage cars. Let's write with try this scenario. How we'll write as same thing. We'll write as the case statement. In place of product line, we will apply as the cars. So case when product line like cars. So cars called as we have classic cars and vintage cars. Two cars is there. If I search with cars, I'm getting. So how I am searching product line like. So percent cars percent. So in product line, wherever it is the cars is there, whether it is the classic cars or vintage cars or XYZ cars, so and so, it will pick all the cars. Then cars, else the product line. So if cars is get apply with the cars or else product line and as products. So another column is to be creating as the products here. Then same thing we had to apply with the products as in group by actually. So in product line, we had to apply as the products. But in SQL Server, it is not working. So that's why I had to apply with the same case statement up to this part. So I will remove this part, case, and apply with case. So same thing, case up to end part I have applied here. Case when product line cars, else product line. Okay. Now I will execute this part. Okay. If you look into the query, cars 61, motorcycles 13, ships 9, trains 3. So we are getting the output. Okay. I hope this one understand. Next, same query we will write as the by using union. So union, how it is working already. So just we are splitting the cars into another query. Okay. So above I am writing with the case condition with cars only, right? Here in where condition also apply the same thing. Okay. The same where condition here what I'm applying called as, so just like with the where product line in motorcycles, trains and ships. This is one query. And similarly, where product line like cars. So two queries I'm writing here. Same above query only. Select product line, count of this one, from products, where condition, group by, up to this part. So if I execute this part, so only I'm getting the motorcycles, so ships and trains. Okay. Now, if I execute below query, so below query is select cars. Directly I'm hard coding here. Cars is. So cars is there is no value or there is no column. Okay. Just I'm hard coding this value. Cars as PRD, count of one as number of vehicles. But how I know this cars called as, I'm filtering the query here, where product line like percent cars percent. So above also I'm done this same. Okay. The same thing also here also I'm doing the same. So now I'm doing with union. This is another type I'm just will look into. Output is to be same. Okay, motorcycles, ships, trains, cars. Okay. Next, so that is one example. And we look into another example. Find the countries which have done more than 10 motorcycles orders. So find the countries, okay, which have done more than 10 motorcycles orders. So countries information is available in which table? Customer table, right? Yeah. So customer table, find the countries. So each and every country wise, so we have done more than 10 motorcycle orders. For example, USA, greater than 10 or not. France, 10 or not. How many number of? Find the countries. And which have done more than 10 motorcycles orders. So these motorcycles orders are available as in products table, product line. So product line as the motorcycles is available. Okay, motorcycles. Only we filter out with the product line, motorcycles only. That also motorcycles more than 10. So greater than 10 only we have to count. So first we will consider it this one. First of all, we will look into these both tables, customers. So customers, so customer ID, customer name, any unique column is there? Oh, no, only customer ID. So in products table, any relation, direct relation to customer table? No. Product code is there, product line is there. So in customer table, products relation is, there is no direct relation, right? Okay. So now how we'll join this one? So we need customer information and product information both. So in countries are available as customer table, motorcycles are available as in products table. But there is no direct relation between these two tables. Then how we'll connect? Then check with sales order table. So in sales order table, we have the column as the product. Okay. And customer also is available. So sales order to customer, we will connect as the customer. This one, customer code. In customer table, customer code is there. And in sales order table, customer is there. Then in sales order table, product code is there. In product table, product code is there. So that way we have to connect. But there is no relation, direct relation to sales order, because of we will need relation between these two tables, customer and product table. So that's why we need to connect to sales order. So this relation, how we can say called as, so for example, in general scenario, A equals to B and A equals to C, then A equals to C. Sorry, A equals to B, A equals to C, then B equals to C. So that's why, for example, here I will write as A, B, C. Then how we'll write as A equals to B, then A equals to C, then obviously B equals to C. So this way we will connect to this relation. So sales order connect to customer table, sales order connect to product table. So first let's join the table. Select from sales order S to join customer C on key columns. So key columns are customer ID to customer. Next, join sales order to products. So products, join products P. P dot product code equals to S dot product. So S dot product called as sales order product. Now up to this part is fine. Join. Now we need filter condition. So filter condition only we need motorcycles from the product table. So product table as where P dot product line equals to motorcycles. So filter condition is okay. Now on which basis we need to group by? So we need to find the countries. So each and every country wise we need the count, and that count also filter with more than 10. So now we have to group by with country. So group by country. Same thing we will write as in select statement country. Now aggregation function we need count, right? So count of 1 as number of orders. Okay. From table already we written here. Now up to group by we are okay. So now I will execute this part first. Group by. So see, country wise we are getting the number of orders, and that too motorcycles. So for example, motorcycles, Australia country, 26 number of orders. Okay. But our condition is which have done more than 10 countries, 10 motorcycles. So 10 motorcycles called as, we have the count is already available. So count of 1. So this count of 1 greater than 10 we need. So how I can apply? So that is we can apply with by using the having. So having where we can apply first of all. So after group by, after aggregation, so after aggregation only we can apply with the having. So aggregation, what we are doing, count, and group by based on country. So after group by, we will do this filter again, like this where condition only. But after group by, where condition is not working. So that is the reason here we are applying with the having. So having count of 1 greater than 10. So now if I execute this part, we are getting this one. Okay, this result. So greater than 10. So our query is fine. We are getting the result now. But this is not in a order. So order by number of orders, DESC, descending order. So number of orders called as this count. We'll apply as descending order. Apply this one. Okay. So USA 149. List is Finland 13. We get the order, right? So this way we will try to get the result by using group by and having. Okay. And here for continuation, we will see with the order of execution also. DESC semicolon. So we'll look into the order of execution, how the SQL query with the order of execution. So generally we will apply with the scenario, how here we apply select from join where group by having order by, right? And limit also. So we'll look into this part. So first order of execution I will consider as all the scenarios. First, what are all the clauses we are applying? Select from join where group by having order by limit. But first, which part we have to execute? So first SQL internally, it will execute as order from clause. So from class, it will execute. So from class called as this part, sales order. First, it will get the sales order information. Next, join. So if any tables are required, so it will join. So from sales order, after this, join this part. After then third part. So third part is where condition. So then continuation with where condition will execute. Then group by, fourth part, fourth continuation. So after filtering the records, then group by. So here in this example, group by with country. Next, once the group by is done, then having is to be executed. So having is after filtering again. So where condition once here filter done. After grouping, then again filter. Next, after once this having is done, then again go back to select. So in select, what are all the columns are mentioned here? So for example, in this part, country and count. Okay. So why it is after having it is going back to called as. So here filter condition is done. So aggregation, so group by is done, having is done, then again go back to this part, select part. So once the select part is get and apply with the order by. If any limit also required, so in SQL Server limit is not working, so we will apply with the top. So here I will write as the top one. For example, I want top one row. So in this same USA 149, I need only one row. So I will get this way. USA 149. If you need top three, top three will get. Okay. Next. So this is the limit condition finally execute. So this is the order of execution SQL. So first from join where group by having, then go back to select order by and limit. So this way the order of execution will do. Okay. 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 Thank you. Thank you for watching. Please like and subscribe if you like the content.
Hello guys. Today we will discuss about with the normalization in our SQL series. So for this video, I will discuss about with the first introduction about with the normalization and one normal form. In part 2, we'll discuss about the second normal form. Part 3, we'll discuss about with the third normal form. Okay. So let's go with the series wise. So if I continue with the in single video, it will be very lengthy. Okay. So first we'll discuss about with the like theoretical. Later I will move into the SQL Server and see with the queries. Okay. So let's see. So first of all, what is the normalization and why we have to use the normalization? So why we have to use the normalization called as mainly, it is the process of effectively designing a relational database. Like basically to design a database a very good manner. Okay. So
why we had to design a relational database in a good manner called as to avoid the redundancy. So what is redundancy? What is the data redundancy called as? Mainly it's a duplication of data. So what do you mean by duplication of data called as? So let's say, for example, in a one table, 100 records is there. So 90 records are unique. Okay. But 10 records are in duplicated, but not every column. So those 10 records are not in every column. So those 10 records are 5 records are repeated values. 5 records are the unique. Okay. I mean, not in every column. So some those that 10 records. So record means a complete row. Okay. So that is way. We'll see the later example also. This one just I'm giving the one simple example. Okay. So for this, for example, in this scenario, 100 records out of 100 records, 90 records are unique, but 10 records are duplicated, but not every column. So 5 are the repeated values, 5 are the unique values. So do you think redundancy or not? So yes, obviously there is a redundancy, but means 5 are the repeated values. So repeated values, those 5 records are the, redundancy is there. Okay. So we'll look into one example. Okay. So here I had taken as one Excel sheet for to show with the how the redundancy the records. First, I have taken consider with the employee ID. So employee ID is the primary key. So there is no duplication in this column. So based on the employee ID is the primary key. So unique records all done. Unique records and no, there is no null values also. So based on employee ID, we have written as the first name, last name, email ID, okay, gender. So these all employee related information. Then we'll look into the customer information. So customer ID, customer name, customer phone number, customer mail ID, customer address. If you look into this table, some of the rows I have highlighted. Okay. So this row, if you look into this part I have highlighted. So why I have highlighted called as, so if you look into the customer ID 7 has the same customer name. Okay. Same customer name, same phone number, same email ID, same address. Because of for this, this customer is reporting to the employee of this. These are all the different thing. Okay. But employee is relating to these customers. Okay. So this is the duplicated information. So duplicated information means repeated values, redundancy is there. Okay. So this is one simple example of the data redundancy. Okay. Let's. So for example, if your table has a primary key, okay, for example, in the primary key called as, let's say assume for this is the table. In this table, employee ID is the primary key. So we can still have the duplicated data. Okay. So your data is efficiently not normalized. So what is the normalization in our concept called as? Efficiently to design a database to avoid the data redundancy. That is the simple manner of the simple definition of the normalization. Okay. Let's so. Now you have the data design properly normalized way. Okay. So like generally we would avoid data redundancy. So this is where normalization comes in. So for example, where we'll look into the normalization and why we have to look into the normalization called as mainly this in turn will to eliminate some anomalies. So what are the anomalies we have to picture in called as? So some like insertion anomalies, deletion anomalies, update anomalies. So these 3 points I will discuss at the end of normalization concept. Not in this video. The other video I will cover this part. So why these anomalies will occur the problem. So now the question is, what do you think design a database? So normalization called as mainly effectively design a database to avoid the data redundancy. That is fine. Now, what do you think design a database? So design a database means in order to design a database, you need to understand a normalization first. So that normalization, we have some rules is there. So those rules are mainly like you heard the names generally. So first normal form, second normal form, third normal form, Boy Scout normal form, fourth normal form, fifth normal form. Okay. So this way the normal forms are phased. So these are all the rules. So we have to first apply the first normal form. If first normal form satisfied, then apply the second normal form. If second normal form satisfied, then apply the third normal form. If third normal form satisfied, then apply the BCNF, Boy Scout normal form. If BCNF is satisfied, then apply the fourth normal form. If fourth normal form satisfied, then apply the fifth normal form. So this way the normal forms are designed. So each and every normal form has some certain rules is there. But basically in most of the companies or most in different companies or most of the companies, normalization is done only until third normal form. Okay, because of if you expand all the if you apply or if you expand with the data denormalization data is you can apply to the normalization, so it will split into multiple tables. So that is a big problem. If you convert the data into very small parts, that is also one big problem. So most of the companies, the normalization will apply until third normal form. So you can split into the multiple parts or different companies, different requirements there. But so different companies, different requirements called as. For example, you can apply with the this table. For example, this table you can split into 3 or 4 tables. Okay, so that is depends on our requirement. We can split the data. But someone is explain this table. He or she to split the data into 7 or 8 tables also maybe. So that is depends on the requirement, and there is no right or wrong answer. So this is a very it's basically it's a confusion concept of the normalization. So everyone has their own thoughts. Their requirements is to be specific. So you can split into the table into multiple parts in your according to scenario. Okay, so different companies, different requirements. There is no right or wrong. So it just depends on how exactly your company wants to split the data, or depending on their requirements. So mainly, every record is unique. Okay, so that way we can split the data. Okay, so this is the basic concept about with the normalization. So let's look into some definitions of normalization. So first of all, the basic definition of normalization is, so it is the process of effectively designing a relational database such that it avoids the data redundancy. Okay, so first, what is the data redundancy? So data redundancy can be referred to as data duplication. So even if some of the columns of a table are duplicated for multiple rows, then we can treat them as a redundant data, which can be avoided in a normalized database. Okay, so designing database called as, so just a process of creating the set of related tables, which will store the data meaningfully as per the requirement. Okay, so meaningfully as per the requirement, we had to split the data. That is called as the normalization, simple way. Let's move into one sample example. So here I have taken as the one example data, that is a denormalized sales order data set. So in this denormalized sales order data set, I have considered as some of the columns in this particular table: order number, quantity, item price, total cost, order date, and status. So this is all the related to the order table related information. But this entire information, this table is to be stored as in one table only. That is called as the denormalized sales order data set. Just I'm explaining how we can consider this data. So this is order related information. And if you look into product code, product name, product price, these all 3 columns are related to product information, and customer information, and sales information. Okay, so this way the denormalized data is given. Okay, so this is one example I am considering now to apply with the normal forms. Now we'll move into the first normal form, that is called as the 1NF. So for designing the first normal form, we have certain rules. Now we can follow with these rules. We have only 2 rules here in simple form. First rule is every column or attribute. So column or attribute both are same only. So every column or attribute need to have a single value. So for example, we will consider this data set. I will copy this table. Okay, so let's copy this table into first normal form. Okay, so here first rule is every column or attribute to have a single value. So this table is to be satisfied with the first rule or not. Just check with this one. So every column have a single value only. So every column or attribute. So for example, this is one column. So let's consider as 2, 3, 4, 5. So this is one single value only, 2, 3, 4, 5. Like this. So you can see with this order number. So order number, all the records are single values only. Similarly, you can check with the quantity. So in quantity, we have 4, 4 is values there. And item price 780, 850. Next, product code. So 2 product codes is there. So 2 product names is there. Product price. So this is the this row is particularly first rule is not satisfied. So we had to split these 2 records into unique single value. That is the first rule. So now what we can do is just copy the row and I'm pasting in before. let's split the record into single value. So first I'll remove with the one value here, and from the next value I will remove here 4,4. Next here I will remove as the 850, and in this one I will remove as 780. Then this one we can split into accordingly. So quantity multiplies item price as the total cost. So let's multiply this one equal to this one multiplies this 3120. Similarly, this one also 3400. Then order date is fine, status is fine, product code is, we'll remove as the product code here, and this one product code as this one will remove one product code, and buses and product name. So trucks for one product code, buses another product code. Next, okay, here also product price. Next, 800 and 900. Now customer details. So customer details are auto canal paid. So this one fine, this one fine, this one fine, address, and so remaining all columns are fine. Only order related information and product related information is to be not satisfied. So we have removed that double values, single value. Okay. So first now, if you apply the first rule, every column or attribute need to have a single value. Means this entire table is to be have single value. So first rule is to be satisfied. Then that is fine. Then check with the second rule. Each row should be unique. Each row should be unique, either through a single or multiple columns, not mandatory to have a primary key. So in this one, primary key, foreign key, there is no matter right now in this first normal form. Okay. But each row should be unique. Each row should be unique means every record is unique only. So for example, if you consider as this particular column order number, so here some duplicated rows is there. So this is not a the second rule. Okay, so second rule is each row. So for example, if you check with the one particular record, the record is to be unique. So if you check with all the records, so here how many records is there? Total 7 records is there. So 7 records must be unique. So there is no duplicated data in this part. So if you check with this one part also, for example, in Excel also we'll check with the duplicated records. So apply with the duplicate records. So data, remove duplicates. So if you apply with this part also, okay, so there is no duplicate values found. Okay, so first rule is to be satisfied. So first rule satisfied, second rule satisfied, then first normal form is done. So this is called as the first normal form rules, 2 rules. So every column have single value, each row should be unique. Each row should be unique unless every record is unique only. That is simple enough. Okay, so this is the first normal form. Just overview summary what I have discussed here. So I discussed it as first point, normalization. Normalization is mainly effectively to design a relational database to avoid the data redundancy. What is data redundancy called as? So some duplicated values, data redundancy, duplication of data. Okay, then we discussed about with the denormalized sales data set. So then first normal form. So first normal form has 2 rules. So every column should be a single value, each row should be unique. That is the first normal form. So in the next video, we'll look into the second normal form. Thank you. Thank you for watching. Please like and subscribe if you like the content.
Hello guys, welcome to my channel. Today we will discuss about the second normal form. So in our continuation of SQL series, so we'll continue with the second normal form. Last video I have covered with the normalization and first normal form. So let's continue with the second normal form. So first of all, what is the second normal form? So second normal form rules are, first point is must be in 1NF. So it should satisfy the first normal form. Then we can follow the another rules. So here you cannot directly come and transform your data into second normal form. So first you must and should be in first normal form should satisfy. So first normal form already we discussed in the last video. Okay, so what is the first normal form? So in first normal form, 2 rules is there. Every column or attribute need to have a single value. Each row should be unique. So this part we have to satisfy. That is the first point in second normal form. Then comes into the second point. I mean second rule. All non-key attributes must be fully dependent on candidate key. All non-key attributes must be fully dependent on candidate key. So here candidate key is, what is the candidate key first of all? So generally candidate key is not a constraint. As such,
it's like a terminology, so used to identify something. So what are the columns? It can be one column or multiple column which uniquely identify a record. So generally, so the candidate key is a set of columns which uniquely identify a record. That is, a table can have multiple candidate keys because there can be multiple set of columns which uniquely identify a record or row in a table. Okay, so this is the candidate key. So in our case, which is the candidate key? So candidate key, for example, in our scenario, first normal form will get the data. So already we have split the data. This is first normal form satisfied. So we'll copy the data same as usual. Copy and paste it here. Okay. So in this data, first normal form should satisfy this one. Okay. So now in this one, what are all the columns? So candidate key we have to identify. So like in our case, which is the candidate key in this example, in this particular example. So candidate key is mainly, if you observe with the candidate key, order number and product code. So for my analysis in this table, order key, order number and product code as the candidate key. Similarly, so if you observe with the, is that any other candidate key? So for example, if you look into this data, order number, quantity, item price, total cost, order date to status. So this complete information is relating to order table. So in our case, for example, let's consider as the order number. So order number is one of the candidate key. Okay. So non-keys are means, so here you can see the definition of non-key columns. So non-key columns are columns which are not part of the candidate key or primary key is non-key columns. So in our case, candidate key, let's assume for order number and product code. So for example, order number is the candidate key. So quantity, item price, total cost, order date, and status are the non-key columns. So why I can say a non-key columns called as columns which are not part of the candidate key or primary key, which are called as the non-key columns. So in this order related information, order number as the candidate key, quantity is fully dependent on order number. So for example, a quantity 30. So this order number is placed the order quantity 30 quantity ordered, item price, total cost. So if you check with the order number, so this related information we will get. Okay. Similarly, if you check with the product code, so product code is any relation with product quantity, item price, and total cost. There is no way relation. So for example, this product code motorcycles. So in any of the order can replace the replace means, so again someone is to be placed the order. Okay. For example, here order number 101 is placed with the motorcycles for this particular product code. Okay. How many quantity? 30 quantity. But some X person or Y person or some other order number also again to replace that with the order motorcycles. So that is, there is no way relation with the product code to this table. Okay. Next. So product code is non-key columns are product name, product price. So these two non-key columns are fully functionally dependent on product code. Next. Customer name. So customer name also, these here there is no customer ID. For right now, we'll consider as customer name. So phone number, address line to city, state, postal code, country, territory. So this all information is dependent on the customer name. Next, we look into the sales information. So the sales information is dependent on the order. Okay. So right. Next, let's go back to rule number 2. So what is the rule number 2? All non-key attributes must be fully dependent on candidate key. So here we have identified as the non-key attributes are order number and product code. So let's give the some unique. Okay, so this is I'm giving the color code for this one part for time being. So these two are the candidate keys. So what is the candidate key here in this part? That is, if a non-key column is partially dependent on candidate key, subset of columns forming candidate key, then split them into separate tables. So here in our example, order number and product code as the candidate key. So what is non-key column? Already we discussed. So non-key columns are For example, quantity is my non-key column. It has to be fully dependent on candidate key. Okay, so for this part, okay. Next, for example, if you consider as these all columns like quantity, item, price, total cost, order date, status directly dependent on order number. Okay, so now based on this rule number 2, we will split the data. Okay, so for example, now how I can display order number, copy and split this as one table. Okay, and product code. So this product code, product name, product price as split into another table like product table. Next, customer name. For example, here customer name up to territory, copy and split into this part. Okay. Next, sales information. But sales information is relating to depends on the order table only. So let's continue with this part, or else we will remove this part. Let's move this one, and this sales information also will copy into here. Okay, just a little bit zoom. Now if you look into quantity, so I think this information also not needed. We will remove this part. Yeah, now you can see the split into the how many tables. I can split this information into 3 tables total. So first one, order number. So quantity, item price, total cost, order date, status is fully functionally dependent on order number, and sales information also fully functionally dependent on order number. Next, product name, product price dependent on product code. Next, customer details. So this all information will dependent on customer name. Okay, so up to this one is splitting is fine. So after splitting, here one problem here. So what is the problem here? Means basically there is a duplicate data. So how you can apply with the how you can see the duplicate data and to apply with the third rule. Okay, so this is up to second rule I have seen. Now I can apply with the third rule. So every table should have primary key, and relationship between the tables should be formed using foreign key. So now here I can apply with the relationship should have primary key and relationship also. So relationship means we'll use with the foreign key. So based on the foreign key, we will give as the relationship. Okay, so before giving the relationship, let's check with the primary key first. For example, in this table, if I consider this order table, this is the primary key. Let's give the primary key. Okay, and product code also primary key. So primary key, if I give the order number as the primary key is it's not allow the duplicate values, means unique and not null. But in this order number, if you look into this, 2 duplicate values. So 101, 101, 06 as the duplicate row is there. So we have to eliminate this duplicate rows and assign as the primary key. So here one option, relationship first will create one more column, or else this one order number will give as the primary key. So if we give order number as the primary key, we will replace the value to duplicate value. For example, this 106 to 107, and we'll identify as this one. Some color we can give, yellow, or else bold. Okay, so yellow color, bold I have given because of this column is mentioned as a primary key. Next, in product code, similarly, you can check with the duplicate values. So if you check with the in this product code 104, 105, 1004, 1005, so duplicate values is there. So let's remove the duplicate values. So here, for time being, I am removing these values into Excel sheet only. So data, under the data, we will remove the duplicates. Remove duplicates, click on OK. So here 2 duplicate values found and are removed. Okay, fine. So 2 duplicate values are removed. Next, so in this part, there is no unique ID is there. So customer name we can't give as the primary key. So let's create one more column as ID. So for example, this part will move to here, and here I will give as the column name ID, customer ID. So customer ID, let's give as 1, 2, 3, 4, 5, 6, 2, 3, 4, 6. auto cannot fit it, auto cannot fit it. So here also some duplicate rows is there. So let's remove this duplicate rows in this table also for time being. Here we'll go and remove, click OK. So one duplicate row, fine. So that is duplicate rows removed. Okay, so this is normalization done. So up to second step is done. Okay, rule number 2 is done, and duplicate values also removed. Now we have assigned as the primary key also done. So customer ID, this part as will give you all borders. Okay, so now customer ID is 1 2 3 4 5 6 done. So now this has the primary key. Okay, up to this one is fine. Now the data looks fine. Okay, so here third rule is third rule, what he is saying, every table should have a primary key. So order number primary key, product code primary key, okay, already given here, and customer ID primary key is given. Next thing, and relationship between the tables should be formed using foreign key. So how we'll assign the relationship? So relationship also will give us 2 ways. For example, so this sales information is there. We'll remove this part. Okay, territory. Okay, let's do format this part. Okay, now so relationship how will give us, for example, this order table. So order table relation to product code and customer ID. So how will give us a relationship? So here again you can create with product code and customer ID. So this way you can create with 2 columns and assign the relationship, or else you will create with one more table. So that is 4th table we will create and assign the relationship. So for time being, I will use with the new table. So new table called as I'll assign as order number and product code, customer ID. Okay, so order numbers I know. So already order numbers are, so these let's consider as these order numbers, unique numbers, order number. Okay, and product code. So product code in first normal form already we have done with the denormalized text. So this part product code, I'll consider this one, this product code, and customer ID, let's consider these values 1 2 3 4 5 6, and this one also 6 will give. Okay, so here why I am giving the 6 call as there is no customer ID. So for time being, I'm giving a 6. Okay, next, how will, now I have created the table that is order number, product code, customer ID. Now we have to build the relationship to these 3 tables. So here this is the primary key. Now we'll create the foreign key. So foreign key where we have to create either in the parent table or child table. Okay, so for example, in our analysis, for example, if any company is to establish any or to invent or to create any new product. For example, so let's consider as the mobiles. For example, XYZ companies started the business, another products other than this these products, they started with the mobiles also. So again, you have to add this product into a product table and here also. But if you add here, you have to add order number and customer ID also. But there is no orders yet. So just a product is launched. So, but there is no orders. So in that case, here we can't add. So in this case, if you add a product here, there is no choice. So let's consider this as the foreign key. So if you add master tables, let's assume this one as the master table. So in the master table, if you add the product, then that is fine. Directly, if you add with the child table, so it can't allow. So first master table only will allow. So then in that case, we will create the foreign key as this one also foreign key, and this one also foreign key. Okay, and this one primary key also, primary key comma foreign key. Okay, order number. So this is unique number only, right? Order number. So now order number, primary key and foreign key will create foreign key relationship given, product code foreign key relationship, and customer ID also foreign key relationship. Okay, so now here order number is relating to this part. Now if we add any product, directly we'll add here mobiles. If any new order placed, then we'll add orders. After that, we'll add here. So that is fine, master table and child. So now this one has the child table, and these 3 are the master tables: order number, product code, and customer ID. Okay, so this is the way we'll create as the will what we say will partition the tables. Okay, so generally the normal form is splitting the tables into smaller. So the smaller tables is depends on our requirements. There is no hard rules. Okay, so exactly you should do this, or there is a lot of what do you say? There is a lot of permutations and combinations. So you can assume. Okay, so you can do normalization many different ways. So exactly, for example, someone has some company, the same information we have split it as into 3 tables and 1 relationship given. Some X company is split this table into 4 to 5 tables also. If you do with the normal form normalization up to 4th normal form, 5th normal form, the same tables will split into smaller chunks. So if you do smaller chunks, also one of the drawback is when you are joining with the tables, so it's very complexity. Okay, that is the reason. So we have to split the data as much as possible, but good way. So good way called as mainly already we have to given the definition, right? Effectively designing a relation database. So that way only we have to design this one. So there is no hard rules for any normalization form, any specific table. Okay. So just overview how we whatever we have discussed right now. So basically I have discussed it as first, second normal form. So second normal form conditions are 3 rules. First rule as must be in first normal form. Second one, all non-key attributes must be fully dependent on candidate key. So candidate key already given example. So candidate key means set of columns which uniquely identify. Okay. And non-key columns. So non-key columns are columns which are not part of the candidate key or primary key. Next, what is this partial dependency also given here definition? So partially dependency means if your candidate key is combination of 2 columns or multiple columns. So multiple columns means here one thing here in our first normal form we have identified as the candidate key, order number and product code, right? So we have identified only these 2 columns. Okay, another multiple columns also we have to identify. So for example, order number and product name also will consider as candidate key. But in this case, product name, why we are not considering called as, generally we are identifying the keys as any IDs. So names we can't prefer the keys like candidate keys. So that is the reason we have preferred as product code and order number as the candidate key. Next. So once we have how we have split the data. So based on after identifying the candidate keys, so based on the candidate keys, we have split the data. So that how we can split the data based on second rule. All non-key attributes must be fully dependent on candidate key. So must be fully dependent means, so those non-key columns must be fully dependent on key column. Key column is candidate key. So after splitting the data, then we can give the relationship. That is third point. So every table should have primary key and relationship between the tables should be formed using foreign key. So relationship, how we have created either. So relationship also will give us multiple ways, but based on our convenience. So for example, here you can create with one more column as product code and customer ID, and you can give the relationship. That is one choice. Or else you can create with new table freshly and assign as the relationship. So this is some example of second normal form, how it is working the second normal form. Okay. So I will share this complete Excel sheet through Google Drive. You can check this Excel sheet. Okay. So first normal form also the same Excel sheet only. Third normal form also the same Excel sheet. Complete information is available. So complete normalization, first normal form, second normal form, third normal form, and anomalies also covered in this part only. Okay. So anomalies means in this Excel sheet is covered. I will do another video for part 3, third normal form, and insertion anomalies, deletion anomalies, update anomalies I will do. Okay. So let's check in this complete Excel sheet. In the description, I will give the link as the Google Drive link. So in Google Drive, how I can place it with here are not mentioned, open the Google Drive. Okay. So in Google Drive, I have pasted this Excel sheet and supported files. Complete supported files is available in the Google Drive. So please check. Thank you. Thank you for watching. Thank you for watching. Please like and subscribe if you like the content.
Hello guys, welcome to my channel.
So today we will discuss about with the third normal form in our SQL series. So last video I had done with the second normal form. If you are not seeing the second normal form, so let's go back to second normal form and watch and come back to third normal form. So first video in part one, normalization, first normal form covered. Second part, second normal form covered. So this is the third, part three, third normal form. Okay. So in third normal form, what are all the rules to be satisfied? First, in third normal form, first rule is must be in second normal form. So you don't come to directly third normal form and not to transform the data. So first, let's complete with the second normal form. Before doing the second normal form, let's complete the first normal form. So this is the order. So first, let's complete the first normal form, then complete the second normal form, then complete the third normal form. Okay. So right now we are explaining with third normal form. So first of all, first rule is must be in second normal form. So that is already done. So let's copy the data. So whatever the data we have done. So this data I'm copying to third normal form. Okay. Same data, second normal form must be in second normal. That is completed. First is rule number one completed. Rule number two, avoid transitive dependencies. So first, what is the transitive dependency? Let's say you have a table T which has three columns, namely A, B, and C. So for example, if you have in one table, three columns, A, B, and C, if A is functionally dependent on B and B is functionally dependent on C, then we can say that A is functionally dependent on C. That means if A equals to B, then if A equals to B and B equals to C, then A equals to C. Okay, like this. Okay. That means A is functionally dependent on B and B is functionally dependent on C. Then we can say that A is functionally dependent on C. So let's go back to first normal form. So here in this one first normal form, let's mark the like in our scenario transitive dependency A, B, and C. So I am assuming that customer name is just like A. Okay, and order number is B. So for example, if you know the customer name, you know which order is placed. So for example, if you know the customer name, for example, Land of Toys. So if you know the customer name, then you can know with which order is placed. Either vice versa also. So if you know the order number, then you can find the customer name. So that is A is functionally dependent on B, or either way, B is functionally dependent on A. Okay, so that is one thing. And let's take the column for C, sales. So like salesperson name. So in salesperson name, if you know the order, then you can identify the salesperson. So if you know the order called as, so order is this one, order number. So if you know the order number, then you can identify the salesperson. So that is column C. So now based on this rule, we can split the data. So now what we have understand. So if A is functionally dependent on B and B is functionally dependent on C, then A is functionally dependent on CI. So that means customer name is functionally dependent on sales. So in second normal form, what we have done, if you check with the order number and sales, okay. So here these two means order information and sales information is we are kept in the same table. We keep in the same table. So let's split this data. The simple thing. So earlier we have split this data into three tables, right? In second normal form. One is the orders table, and second one as the product table, and third one customer table, and we have given the relationship, these three tables. So total four tables. So three tables we have splitted, one table we have created because of the relationship. Now this to avoid the transitive dependency right here. So for transitive dependency to avoid, so in this orders table we have split the sales information to new table. So sales information is this one, sales contact last name. Okay, so sales contact last name. So just copy these three columns and split into new table. Now here we have to remove this one and remove. where it is delete? Yeah. So we have deleted this one also. Format do same. Okay. Now the tables are small. So order table is to be small. Now, if you look into the sales table, comes to here. Okay, sales information. So sales information is sales contact person name. So that is the last name and first name and deal size. But here, if you look into this sales table, there is no unique identifier. Okay, and that is the first thing. There is no unique identifier. So we have to give the one unique identifier. That is, we'll create one more column. That is the first point. And the second point is we have to give the relationship to above tables. So above tables are already in above first three tables already we given the relationship. Okay. Similarly, we will give the relationship to these tables. Okay. So for this, what we have to do, we'll create as one more column, employee ID. For example, here I'm creating, or else last first row will create. So here I'm creating employee ID. Employee ID is E1, E2, E3, E4, E5, E6, 6 records. But here, one more thing is this is duplicate data. So if you look into this sales information, here one duplicate record is there. Okay, so we'll remove this duplicate record first before creating the employee ID. So data, move to remove duplicates. Click OK. So one duplicate value removed. Now we'll create as the format that this one format. Okay. Now we'll create as the table. So now I have created as the unique employee ID E1, E2, E3, E4, E5, E6. We'll give as a primary key this one. Okay. So primary key created. Now we will assign relationship also. So relationship is, so this table to above tables we have to give the relationship. So employee ID, let's copy this one. Employee ID, make it to here. Okay, so last record, same record employee E6 only. Okay, so this way we have to give the to avoid the transitive dependency. Now if we look into these tables, so order table. So order table, these non-key columns are fully functionally dependent on this number. So small table, order. So order table is order number, quantity, item price, total cost, order date, status. That is clear. Product table. Next to customer table. Okay, customer table clear. Next to order table. Order table means already here. Why here employee ID? This is relationship table, right? Okay. So generally relationship table will give as an end. Okay, so let's move to this one, relationship ending, and this we can remove. Okay, now it's clear. So now we have splitted the complete 4 tables: order table, product table, customer table, employee table, and relationship. So relationship is here, this one as foreign key to this primary key. So employee ID primary key, and here this is the foreign key. There we have built the relationship. Okay. So now third normal form completed. So this is the third normal form. What is the third normal form is 2 rows only. So simply first point is must be in second normal form. Second point is to avoid the transitive dependencies. So you know how we can do the transitive dependency right now. Okay. Next. So why we have to do this? These are all the things: redundancy, data, like first normal form, second normal form, third normal form is to avoid the redundancy. So basically, so what is the how we can handle this redundancy called as first normal form, second normal form, third normal form. So what are all the problems or what are all the anomalies we have to face called as? So that is the insertion anomalies, deletion anomalies, and updation anomalies. So let's look into the anomalies so we will understand easily. So why we have to build normalized, denormalized data to normalized data. So the reason is insertion anomalies, deletion anomalies, and updation anomalies only. So if we split the large table into small tables, smaller tables, so these anomalies we can't face. So insertion anomalies, deletion anomalies, and updation anomalies. So that is called as a efficiently to design a database. Okay, let's look into insertion anomalies. What is the insertion anomalies and what are all the problems we had to face? We'll see here. So if you look into the insertion anomalies, so just look into this data. Let's make 100%. So scenario one is data redundancy. So this is denormalized data set. So this table is not normalized. So if we get the denormalized data set, what are all the insertion anomalies we have to face? That we are seeing here. So if you're looking to the insertion anomalies, denormalized data set, so basically order number is the unique. So there is no problem. And quantity, these are all no problem. But if we look into the customer name, at the starting video normalization, I explained this scenario, duplicate records, redundancy, right? So if you look into this customer information, so one customer is purchasing multiple orders. Okay. For example, in this data, so 20 to 30 records, it is very easy to remove the redundancy. That is fine. But if you are getting day by day records or 20 million records, 30 million records, so day by day the data is to be increasing. Okay. So day by day means, so every day the data is to be adding. For example, if you are working within the banking project, okay, so in banking project, every day you are getting the data. So the data is to be adding. For example, if you consider as the customer name of land of toys, so this incorporation customer is buying some orders. Okay, so every day he is buying with some motorcycles, some vintage cars, some classic cars, some buses, some trucks. So the data is keep on adding. Okay, so if he buys for today 1 million records, or else if tomorrow or day after tomorrow, if he buys with some other orders, okay, so then these records, these duplicate records are keep on adding. Okay, if you split the table like a customer table, just you can add it with one record, right? So this customer information, like whatever the information customer, land of toys ANC, phone number and address, city, state, postal code. So we'll check this customer table in the third normal form. So the third normal form, if you look into customer ID, customer name, so customer ID, one unique ID will give, and remaining customer name, address, phone number, city, state. Just we'll add one particular row. Okay, but here if we add how many orders he placed, those many records we have to keep here in the main table. So that is the denormalized text problem. So that is the one scenario. And scenario two, missing data. So missing data called as, so for example, if any new product is to be launched. So example, if you see this row highlighted, cruise ship is to be launched, but there is no orders, there is no customers, and there is no sales information. Then at that time, what we can do? Only we had to add product information. Okay, in this denormalized text, only we had to add product information. Remaining all the rows, remaining all the columns, we had to update as the null. That is empty values. So that is so empty values we have to place here, and we have to keep on increasing how many number of products are adding. So this is also, if you removing the null values, then you can cross with this particular product information also we can loss. Okay. So this is one type of anomaly. So this is simply insertion anomalies. So if you insert one particular instead of one particular record, you are adding how many number of records. See here, for example, in this scenario only, how many number of records you are adding here? Highlighted records, 12 plus 1, 13 records are you are adding instead of one record. In real time scenario, we had to add millions of records. So that's why we had to do the normalization. We had to split the database into small tables. Like efficiently, we had to design the database. Next comes to deletion anomalies. So in deletion anomalies, so first to see the scenario, how to delete just a specific order information without losing customer and product data. So he's asking the question is, how to delete specific order information. So for example, this order is to be placed as some wrong order, or else by mistakenly entered some record. Okay, order information. So to delete this information, orders information, without losing customer and product data. So product data is to be correct and customer information is to be correct, but we have to delete only orders information. So if you delete this particular row, you can last with the product information, at the same way customer information also. The same information, if you get back into third normal form, if you remove with the one particular row, so one particular row, for example, here he is wrongly placed with the 10103. So come back to third normal form. So this particular row I will remove. but the other information is to be available. Like product information is available, customer information is to be available without losing the data. Only one particular row we have to remove in orders table. So that is the way we have to understand the normalized tables. So normalized database. Okay. So this is called as one example of deletion. Similarly, updation anomalies also. So in updation anomalies, see the scenario first. Update the price of a product, motorcycles. So motorcycles, we have to update the price. So the motorcycle price is to be increasing, some 10 rupees or 100 rupees increasing. Let's say example only. Okay. So in this scenario, how many number of rows we have to update here? So for example, this is the real-time scenario. In the real-time scenario, whatever the number of orders placed, all the number of orders we have to update to the motorcycles information. For example, in this small data, we have to update 1, 2, 3, 4, 5. 5 records we have to update. Instead of updating one record, we have to update here 5 records. So in the real-time scenario, we are getting 20 million records, 30 million records. So at that time, it is very difficulty. So updating is okay, we'll update the data, but it will take time and it will take huge data. So many problems will occur. Okay. So that is the reason we have to split the normalized way, small tables, as early as possible, efficiently to design a database. So instead of one row record, so updating. So updating one row record calls, for example, this is the product table information. So in product table, go back to the third normal form, product table, motorcycles price. So just update one particular row, motorcycles in product price is to be increased. So just I will update here instead of first row. Instead of this, all the information I have to update, I will update to only one particular row. That is called as the updation anomalies. Okay. Now I hope you are understand with the why we are doing with the normalization. Okay. So if you are facing with these type of anomalies, we have to design with a normalized data, normalization. We have to apply the normalization efficiently. We have to design the database. Okay. Insertion anomalies, deletion anomalies, and updation anomalies. But you have to split the data into smaller chunks as early as possible. But that is you can do. But mainly you can apply the up to third normal form. That is transitive dependency and partial dependency and first normal form. Each and every row, single value. Each and every column should be a single value. So first normal form, second normal form, third normal form is enough. And one of the important thing also, most of the companies, 90% of the companies is applying up to third normal form only. Because of the reason is, if they are splitting the data into small chunks, applying with normal forms go on. If you are applying with again BCNF, so this table you have to split into another table. Okay, so that's why if you're splitting multiple tables, multiple smaller tables, while if you're writing the query, so then again you have to join with number of joins. So the complexity is increasing. So if you are writing with this type of data, like small data, so 5 to 10 records or 20 records or 100 records, if you are joining, there is no problem, complexity. So when the heavy data you are using, like millions of records, when you are dealing with millions of records, at that time, if you write with within the query multiple joins, so the query it will it will take us the huge time. So that's why we can't increase the complexity. So the company is also not interesting to increase the complexity. So up to they are doing with the normalization up to third normal form. First normal form, second normal form, third normal form. And why we are doing the normalization called as to avoid the anomalies, insertion anomalies, deletion anomalies, and updation anomalies. Okay. And the definitions also available here. You look into this. I will share this Excel sheet. You have to look into this Excel sheet and see the definitions and first normal form, second normal form, third normal form, insertion anomalies, deletion anomalies, and updation anomalies. Okay. Please like and subscribe. Thank you for watching. I will share the this file into the in the video description. I will give the link, Google Drive link. So you can navigate to the Google Drive link and access to this Excel sheet. All the supporting files is to be available in the Google Drive link. Thank you. Thank you for watching.
Hello guys, welcome to my channel.
So today we will discuss about with the subqueries. So last video I had done with the normalization. So normalization I have covered as 3 videos. So first normal form, second normal form, third normal form. So if anyone is not watched, please watch the normal forms. Okay. Next, for today's video, we are discussing about subqueries. So before moving to the content subqueries, I will create with 4 tables. Those 4 tables are, one is the painting, artist, and collectors, sales. So first, if any tables are available, so I'm dropping the tables. Okay, so tables are dropped. Now freshly we have to create with the tables. So I will share this code in the description, and Google Drive link also I will provide. So let's take that file. Okay. So sometimes in the description, greater than symbol is not allowing, less than and greater than symbol is not allowing. So that is the reason for that, if the code is not copied in the description. So this creating tables I will share in the description, but complete list of code I will copy in the notepad. So the notepad file is to be shared in the Google Drive. Okay. First I will create with the paintings. So paintings, let's create the paint. So painting is ID, name, artist ID, listed price. Next, artist ID, first name and last name. Similarly, collector ID, first name and last name. And sales. So sales are ID, sale date, painting ID, artist ID, collector ID, sale price. Okay. Now I will insert with the same, insert the data. Next to artist, next to collectors, next to sales. Okay. So now I have the example data is paintings data is available. If you check with the data, so painting ID 11, 12, 13, 14, 15, 16, 17, 18. Okay. So 8 rows is there. And artists, 4 rows. Collectors, 4 rows. Sales, 6 rows. Okay. Let's move to our query. We'll start the subquery first. So first of all, what is the subquery? So the definition of the subquery is, simple definition is mainly a query inside another query is called as a subquery. A query inside another query. So inside another query means, so first we'll, for example, if we'll write with any one main query, within that we will write another query. So we'll see the example later. Okay. So this is a simple definition. And types of subqueries. So how many types of subqueries is there? So generally we will call as these 3 types of subqueries. Scalar subquery, multiple row subquery. So in multiple row subquery, multi-row, single column, multi-row, multi-column. And finally, correlated subquery. Let's see the first one, scalar subquery. So scalar means simple with 1 column and 1 row, which returns 1 column and 1 row. That is called as scalar subquery. Multiple row subquery means, so that is considered with 2 ways. One is multi-row single column. That means which returns multiple rows, but just a single column. Second one, multi-row, multi-column subquery. So which returns multiple rows, multiple columns. That is called as multi-row, multi-column subquery. So that is multiple row subquery. Okay. And finally, correlated subquery. Correlated subquery is a subquery which depends on outer query. So if any subquery we return, so that is depends on with the main query. At the time, that is called as the correlated subquery. So generally, the order of execution in the subqueries is, so if you write with subquery like a normal scalar subquery or a multi-row subquery, first inner query. So inner query means subquery is to be executed first. This output will be passed to return to main queries. Then main query will execute and will provide the result. So this is the order of execution. But in correlated subquery, it will execute as the first will execute the main query. Okay, from class. So from class it will check with the condition. After from class, it will check with the condition. So the condition iteration 1. So iteration 1, it will ask to the subquery. So which is depends on the outer query. Okay. So subquery first, the general definition is a subquery which returns depends on outer query. So the subquery is again it will ask to main query. So that is first iteration 1, check the condition and execute the subquery. Then it will pass the result to main query. Then iteration 2, iteration 3, that continuation flow will execute at the same time. Okay. Next, we'll see the one example. First, we'll write the query. So our query is here: fetch paintings that are priced higher than the average painting price. So first one is fetch the paintings. So fetch paintings called as, so or else I will write here. By default, we'll write the query select from where. So from class is, so we'll call it with paintings. I will copy the name here. So select from paintings. So here I will call with select star. Our query is fetch paintings. So select star from paintings. Okay. Then that are priced higher than the average painting price. So in paintings column, paintings table, what is the price column? Listed price. So listed price will take as where listed price greater than. Now we have the average price. Okay, so fetch paintings that are priced. So paintings already we covered, that are priced higher than means price column where listed price greater than average painting price. So how we know the average painting price? Let's check the condition. So how we'll do the average painting price? Called as select AVG of listed price. Select AVG of listed price from paintings. Okay, so we'll check this one 1587. So this is the way. So here we'll write as 1587.5. Okay, so if we check with the listed price, how many rows higher than the average price? So average price is 1587. So first row not eligible, second row not eligible, third row 2800 is eligible, 2300 is eligible, 250 not eligible, 5000 eligible, 50, 1300 is not eligible. So how many records? 1, 2, 3. So we will get the 3 records. So but here this is the static output we have given. So in place of for day by day, if any records are added something, then we had to get the dynamic output, right? So in place of 57, directly we'll replace this file. Copy, and I will remove the 1587 here. And here we'll get this one. Okay. Now we are getting this select average price. Now I will execute this part. Okay, we are getting the 3 records. So this is the fetch paintings that are priced higher than the average painting price. So this way we will do the subquery. So in this point, which is the subquery, which is the outer query. So this part is the select AVG of listed price from paintings is the subquery, and this part is the main query. So first it will execute the inner query, then this result will pass to this one. Then outer query will execute and to send the output. So this is the way we will execute with the subqueries. Then we will continue with the second query. Second query is fetch all collectors who purchased paintings. Second query, fetch all collectors who purchased paintings. So first we have to get the collectors information. So select star from, or else we'll write select first select from where. Okay, so select to star from collectors. Select star from collectors. Execute. So we will get the 4 records. Now we need who purchased paintings. So who purchased paintings called as so based on collectors, we have to get the records who purchased paintings. So purchased paintings is which table? So sales table is available. So we have to get sales table. So in the sales table, who purchased the paintings are available. Okay. So let's write with here. How we'll write? Where in collectors table we have CIDs, IDs, right? CID means collectors will call as collectors as C, where C dot ID in. Now inside we'll write as the sales record. So sales record will get the all collectors. So this one select star from sales. So if I get the select star from sales, what happened? All the collector IDs I'm getting. So we need only collectors, right? So here I will write as collector ID from sales. So now I will get the collector IDs. But here I'm getting the duplicate records. So I need unique records. So select distinct collector ID from sales. Okay, now I'm getting the 10234. So we need who purchased paintings. So these are all the purchased paintings. So we have to execute this complete part. Okay, so now I'm getting all the collectors information of who purchased the paintings 102, 103, and 104. Okay, so this is the one solution. So in this inner query called as, so this part as the inner query, and this one as the outer query. So this is which type of query? In above subqueries we have types, right? So which type of subquery? This one. So this is multi-column and multi-row. So multiple rows is there, multiple columns is there. So that is multi-row, multi-column. And above first two query I have done, right? This one, which type of query? This one. So this one also same. Okay. Okay. Next, the same thing we'll do in another way. For example, this one as using the solution using subquery. Okay, and we'll write the solution in another way. Solution thing joins. Okay, so how we'll write the joins? So first we'll write select from where. Okay, so from here we are using the how many tables in this part? Fetch all collectors who purchased paintings. Already in this query also we have used the two tables, right? So let's join with collectors and sales. How we'll join the collectors and sales? So for example, if you check with the collectors, ID column is there, and sales, we have collector ID is there. So based on collector ID and ID, we'll join the table. So select from collectors I will copy the name. Select from collectors, we'll call as the C, then join to sales table. Sales is yes on C dot collector ID. C dot collector ID equal to C dot collector ID. No, C dot sales table. This is the sales table, right? So if I execute this part sales, so this is the sales table. So sales table collector ID. So this is not C, yes. Sales dot collector ID equal to and collector information. So C dot ID. Okay. So if I execute this part, select a star, I will get all the information. Okay. So all the tables are getting here, but we need only collectors, which all the collectors. So collectors called as C dot star collectors table. So if I execute this part, only collectors information I'm getting. And now I will execute with distinct records. So distinct unique records, right? So distinct C dot star. Okay, this part. Now I'm getting the same result 102, 103, 104. So here where condition is not required, we'll remove this part. So this is solution using the joins. So two ways we had to fetch the this query. So fetch all collectors who purchased paintings. Right. Next, we look into another query. So in this part, fetch this one, fetch the total amount of sales for each artist who has sold at least one painting. So display artist name and total sales amount. So This one also we'll write, will by using joins also we will do, and subquery also we will do. So first let's try with one part. Select from where. Okay. So first we need fetch the total amount of sales. So sales part. So from sales table, from sales, yes, and total sales, right? So select sum of sales as we'll consider as total sales. Total sales amount, also underscore amount. Total sales amount. Sum of sales. So sales. So which table sales is available? Find the total amount of sales for each artist who has sold at least one painting. Okay. Display the artist name and total sales amount. Total sales amount we are getting from the sales table. So let's check with the sales table where it is sales. Yeah. So sales, sorry. Yeah. So sales table execute. Sales table, sales price column. Okay. Sum of sales. So sales underscore price. So these column names are most important. We'll remember. Sum of sales, find the total amount of sales, right? So sum of sales price as total amount. This one fine. Now this sum of sales is for each artist. So we have to get the artist details. So artist details are this one. So ID, first name and last name. So we'll join the artist. So sales, yes. Join artist. Join artists. Artists is A on. So here in artist we have the ID is available. A dot ID equal to sales table yes dot artist ID. Artist ID. Okay. So now join is okay. Artist. So for sales, amount of sales for each artist. So we have to, each artist means here which class we have to use? Group by. So artist wise, each and every artist wise, we have to group the records. So group by on which basis? Artist ID. So or else artist name. So we have to check with which names are available. Artists here. Oh, here first name, last name. Or else we'll consider it. We group by a dot ID, and here we'll give as same thing. So group by here one thing. If we give group by a dot ID, same thing only we have to give as in selected class also a dot ID. Okay, but here we need each artist. So artist names we need here. So names called as here first name and last name. One thing we'll do, we'll concatenate here. Here I will write this part, or else here first write here. Concatenate a dot first name plus single space plus a dot last name as. So this complete thing will do in single braces as artist name. Okay. So now I will do this part. In place of a dot ID, I am giving with the artist name. Okay. Now if I execute this part, I'm getting. Okay. So let's try this part completely. Move to left side. Comma sum of sales. So last comma remove. Here where condition also where condition at least one painting and display artist name and total sales amount. So display artist name, we are getting artist name, and total sales amount we are getting. So this where condition we had to remove here. Now if I execute this part, artist name I am getting Kate Smith, total sales amount 4,800. Atali Win to 4,250. Okay. So this way, this is by using the joins. So this one, solution using joins. Solution using joins. So here, what we have written, select first artist name we have given, and sum of sales we have given from sales table and artist table we joined, group by artist name. So generally in MySQL or PostgreSQL, directly we'll write as this part, artist name will write. For example, here I will show here. Group by artist name. But in SQL Server, it is not allowing invalid column. So whatever the name we have written in the this part, in place of artist name, we created that row, right? We created the column. So that part we had to mention in the group by. Okay. Now we'll try with subquery solution using subquery. First, we'll write select from where. Okay. Directly, I'm writing with artist name. We'll get the same. Copy paste. Select artist name, and we need sum of sales. So sum of sales will write from. I will write this one. Select this name is fine. We'll get the artist name, and from this part is artist or artists. Okay, artists A join. Here I will do one thing. Select first. I will get the sum of sales. Okay, artist ID wise, I will get the first sum of sales. Select sum of sales. Where it is sum of sales. Yeah, sum of this part I will copy here. I'm removing the where condition. Select sum of sales price as total amount, and we need artist ID also. Artist ID wise, here names are not required in subquery. Select artist ID sum of sales price from artists. Sorry, this table as sales, from sales group by artist ID, or else this part only I'm copying here. So here what I'm doing called as, so first I'm getting the sum of sales each and every artist wise. So in artist table we know the artist ID. So select artist ID sum of sales from sales group by artist ID. This part we'll put this one. Okay, and we'll call as this yes. Okay, so let's do just yes is the this complete query will save to yes. Now I am joining to this part. Okay, so artists A join yes. Now we'll write the on condition. On A dot ID equal to yes dot artist ID. Okay, so let's see first of all again. So first, you understand this part, right? So select artist ID sum of sales as total sales from sales group by artist ID. So what we are getting, if you execute this part, we'll get the each and every artist wise sum of sales. Now this part I'm saving to yes. So in the alias name yes. So I'm joining this yes table to A table. So A table called as artist table. So artist A join to yes on A dot ID. So A dot ID called as in artist table ID equal to artist ID we have in the subquery is available artist ID yes dot artist ID. So now if I execute, I'll get the artist name only. Why? We need total sales amount also. So in subquery we have total sales amount copy and mention in the first artist name comma total sales amount. If I execute, yes. So artist name and total sales amount I'm getting. So using subquery. So this part is completely first I'm getting the each and every artist wise total sales. Then I'm attaching to main query. Okay. So this is the using subquery. We will get the this part. Next thing, next query. Find the names of the artists who had 0 sales. Who had 0 sales. First, we will get the names. First, select from where. So names part we know about same thing. I will copy this part. Artist name. Artist name. From table is artist. Artists A, where now we'll get the find the names of artists, okay, who had 0 sales. From sales department, whatever the sales they done. So those sales will get the here in the main query. So let's try to write with first write select one from sales yes on s dot artist id equal to a dot id. So here I have written as select one. So one means it's a like any column or any some temporary column I'm creating. Okay, from sales yes on artist id. So this artist id will get as from the outer query. Okay, and yeah, sorry, s dot artist id will get the from sales table. Yeah, sales yes. And a dot id here I am not mentioned in this subquery. Okay, so a dot id called as from artist table. So it will again go back to outer query and check with the records a dot id. So if both are equal, then we'll display. Okay, that will exist. So by using exist function, we'll get this one. So where not exists, if it is not available, then display. Okay. So if I execute this, keyword on incorrect syntax. First to select a dot id. A dot id. This part I am not mentioned in the select class. Take this one. A dot id. Keyword not on. Now artist A where X not exists from select one from sales yes where s dot artist id a dot id. Okay. Something is missing here. Message incorrect syntax. The keyword on sales yes. Okay. Okay. Here on condition place we'll write as where. We'll write on condition join. So generally on condition we'll write as in the in joins only we'll write on condition. So here I have to use with where class. Okay. So I'm getting the Francesco Benelli. So 4. So what I'm doing called as here. This is the one example of solution using correlated subquery. Okay. So correlated subquery. So what I'm doing. So first I'm getting the names. Fine. And a dot id is artist id. So artist name and artist id I'm getting. So from artist table, fine. So but here in subquery I'm getting select one. So one is the temp column or any column name. So but actually so this temp column will assign. Select one from sales yes where s dot artist id equal to a dot id. So this a dot id again will fetch from the artist table. So that is correlation. So from inner query correlation to outer query. Okay. So this way we will get the output. So not exists is, so if it is not available, then to display the records. So only one record I'm fetching here. Okay. And the same thing we'll write as another way, like select from where. First I will get the names and this name part is to be same. Okay. Select names and select part from artists A where, for example, a dot id not in this subquery is select s dot artist id from sales. Yes. So first I'm getting artist ID sales. If I execute this part, artist ID I'm getting. So in this artist ID, so not in. So in outer query, what I'm getting here, up to here, I'll get the artist table. Okay. So where artist table not in sales, then we'll get the one record. So here in artist table, actually 4 records is there. So in artist table, actually 4 records. So in sales table, how many records? We have different number of artist IDs is available. So we're not in. So who had 0 sales? So whoever not performing the sales of artists, those IDs we are displaying here. That is the same answer. Okay. So this way we will execute with the subqueries. Okay. So we'll see some more queries in the next session. So coming sessions we'll do the left join, right join, joins also, outer joins. Okay. Thank you for watching. Please like and subscribe.
Hello guys. Today we will discuss about with the one of the most common interview question and one of the important concept also. So in our SQL series, so today we will discuss about with how to remove with the duplicate data. Okay. So if any duplicate data is there in the table, that how we can remove with the duplicate data. That is today's concept. Okay. So first of all, I will check with the table. So this entire script I will share in the description, and I will share in the Google Drive also. So let's check in that one. Direct I'm executing this part. So already I have created the artist table, and this artist table how I created with the last video also I have discussed. If you are not seen the last video, just look into that one. That is subqueries I have done the last video. Okay, let's move to, so select a star from artists. So here I have 4 rows is available. Okay, so these 4 rows are unique rows. There is no duplicate data in this part. Now I will add some records into artist table. Okay, that is duplicate records. Okay, so just I'm taking with some sample records, so duplicate records, insert into artists values 5, Kate and Smith. So Kate and Smith already available here, and I'm entering with the duplicate record. And Natalie Wien also available. I'm entering with the duplicate record. Let's insert this part. Okay, 2 records inserted. Now how many records are available here? 6 records, 6 rows is available. Okay, now how I can remove with this duplicate data? So the first way is by using group by and having, will identify the duplicate data first. So this part is first 2 steps we have to follow here first. First identify the duplicate data. So what is the duplicate data is available? So by using group by. So group by is I am group by with first name and last name. So same thing I have mentioned in the select class, and count of 1. So count of 1 called as, so we'll display the count of records each and every group wise. Next, same thing I'm mentioning with the filtering. Filtering means greater than comparison. Okay, so count of 1 having count of 1 greater than 1. Okay, we will get the, if any more than 1 record, that count will display. Okay, so if I execute this part, I am getting the duplicate records, this part. So you see the column count, no column. Okay, so 2 count. So Kate Smith 2, Natalie and Wien 2 records. Now if I remove this part, okay, how I can remove with these duplicated values? So duplicated values means, so I have to remove this Kate and Smith 1 record, Natalie and Wien 1 record. I can't remove with the original records. Okay, so original records, 1 copy records, as usual we have to place. Whatever the 2 records we inserted recently, those records we have to remove. So in this example, this is the sample data only, but in real time scenario, millions of records. Okay, that please remind. And now first thing I will go with one way. So delete, right away I'm deleting with this copy and entire thing and paste it here. Like delete from artist A, join with B. So this entire query with I'm joining to B on A dot first name equals to B dot first name, and A dot last name equals to B dot last name. So if I remove here this part, if I execute this part, this complete 2 records will remove. So 2 records means, so including original data also will remove. Okay, so let's check this part. 4 rows affected.
Now, if I check with the select star from artists, only 2 records is there. So original 2 records also deleted. So this is the wrong way of deleting the duplicate data. Okay. So we can't opt as this part. So this option we can't choose. So wrong way of deleting this duplicate data. Okay. Now I will insert a few records again. So now in our table, select a star from artists, I have 2 records only. Now I will add some records, 4 records I am adding again. So 4 records I have added this part. And again, you have to check with the number of records. How many records is there? 6 records is there. So in these 6 records also again, I have added the duplicate records. So these 4 records are 4 records. Within the 4 records, 2 records are the duplicated. Now, I will prefer one more option, that is by using max. Same query above, but I am using here max ID. So select max of ID from artists group by first name and last name, having count of 1 greater than 1. So if I do this part, I am getting only max columns. So that is max IDs are 5 and 6. Okay. So same thing above whatever I have done by using delete. So let's check with the method. First one, method 1 is I am just copied with this entire thing and copied here. So copied here means delete from artists where ID in. So where ID in, the same query copied here. So if I execute this part, 2 rows affected. So 2 rows are called as while executing this max ID, we are getting two records, that is 2 duplicate records. So those two duplicate records are removed. That is fine. Now we'll check with the artist table. Only we are getting the 4 records. Okay. Now method 2. So method 2 is but this is not preferable method 1. So why this one is not preferable called as? So it works when there is a single duplicate record. For example, if you have one record is duplicated with 3 to 4 times. So at that time, max of ID is not working. Okay. So that is the reason we will prefer another method. Again, I'm inserting with some more records, 4 records. Then again, I had to check with the artist table. Here, how many records available in this one? Total 8 rows is available. Okay. Now the same thing, only I'm replacing 2 in place of max. I'm using the min. Okay. Above same ID, same delete from artist where ID not in. Select min of ID from artists group by first name and last name. So if I done with this part, so here how many records are added? 4 records are added, duplicate records. So if I execute this part, first let's check with this part, how many records we'll get. So 4 records, 1, 2, 3, 4. So not in. So to delete with this, to delete this part. So delete from artists, entire thing, delete. So 4 rows affected. Now if we check with the table, so 4 rows. Okay. So this is the preferable way. So this works even when there are multiple records also. So this is the best option to delete the duplicate records. And one more option is, so again, I'm checking with the artist table 4 records. And again, I'm entering with some more records, duplicate records. Okay. Now, if you check with method 3, if method 3 is when there is a huge data set. So huge data set like millions of records. So at that time, we will prefer with method 3. Method 3, I am using with above query. Okay. If you check with this part, sorry, by default I have executed this part, right? So if I check with artist table, so in artist table we have 8 records is there. I will drop the backup table. Drop table backup. Okay. Okay. Now I will explain the method 3 again. So if we select with artist table, 8 records is there. Now what I'm doing called as, by using this query, I have created with backup table. Okay. So backup table called as same artist table, I will create with backup artist backup. So select min of ID as ID, first name, last name into artist's backup. So these 3 columns we have to backup to artist backup from artist group by first name and last name. So now what happened? Artist backup table will be created without duplicates. So check this part. If you check with the select star from artist backup, there is no data. Now the table will be created artist backup. Okay, 4 rows affected. Now check with select a star from artist backup, 4 rows. Okay, so in select a star from artists, duplicate data is there still. Now what I will do is method 1. So first drop the artist table and rename to artist backup to artists. So method 1 drop, I'm dropping the table of artists. Okay, there is no artist table right now. If you check with the table, no table. In artist backup, 4 rows is there. Now we will do artist backup is renaming to artists. So exec sp rename artist backup to artists. So table will be backed like renaming. So backup means relay. The table name is renamed. So now if you check with backup table, there is no table. Now if you check with artist table, 4 records. So this is a one way you can opt with to remove the duplicate records. But this is not recommended to in prod environment. So if you have the million number of records and your project is in live, so this is not recommended. So prod environment, or if you have to test with dev or UAT, then you can preferable. Okay, so this is not preferable with prod. So why we can't preferable with prod environment? Prod environment called as if your project is in live. If you are dropping the table, it will take some time. Again, we the table is to be dropped, and again we have to create with the this renaming. It will take some time. So that certain period of time, your project is to be failed to run with the live project. Okay, so method two is so. For example, here I'm again with select with artist table, 4 records. Again, I'm creating with some more like multiple duplicate records I'm inserting. If I insert here, how many records is there now? 12 rows is there. So out of 12 rows, now I will create with again backup table. Okay, by using the same command, I will create with backup. So earlier backup table is not available. So backup table is not available. Now I will create with the backup table. Okay, backup table created. So 4 rows. Now I'm executing this part. So backup table, 4 rows is available. Now, if I check with select a star from artists, 12 rows is there. Select a star from backup, 4 rows is there. So again, I will insert with these records into backup. I mean, first I will truncate this. Sorry, I will truncate this table. Okay, so instead of dropping, I am doing with truncate. So above, what happened here? I have in method 3 part 1, I dropped the table. Okay, instead of dropping the table, I am doing with truncate. So again, we check with the records. So in artist table, 12 records is there. In backup table, 4 records. So this is we want only this table, backup table we will get back. Okay. So for artist table, for time being, immediately we had to truncate the table. So truncate is to be as compared to drop, it will pass. So truncate the table. So there is no artist right now. We check with the artist, there is no artist. Now we will insert the same records into backup table. I mean, backup table already 4 records is available, right? So this backup table records will insert into artist table. So insert into artist, select star from artist backup. 4 rows affected. Now we have 2 tables are live. So artist table 4 records and artist backup table 4 records. So let's remove with backup table, drop table, artist backup. So finally we have artist table 4 records. So this will be possible to execute in live also. That is by using truncate. So in submethod 1, this drop table is to be taking time if you have the huge data. As compared to drop table, we will executing with truncate and inserting the records in artist table. Okay. So these are all the options to remove with the duplicate data. Okay. So this is one of the most common interview question. If you attend with any interview, okay, if you are explaining this number of ways, so the interviewer get much appreciated. Okay, but these you are not answering to all these options. So let's answer with any 1 or 2 options. So, but most of the time we will prefer with method 2. This is the method 2 will work, or else method 3 or 4. So method 3 is also fine. So if your data set is huge also, the method 3 is also fine. And in method 3, this sub method 2 is there, right? Method 5. So that is also fine. Okay. Thank you. Thank you for watching. Please like and subscribe if you like the content. So I will share this entire script in the video description. Please check and execute. Try to execute your end also. Okay. Thank you.
Hello guys, welcome to my channel. So today's video is mainly in our part of SQL series. We will discuss about with the joins. So joins I already covered with 2 videos. That is real-time scenario interview question, like self join, and 2 scenarios I have explained by using like in table 1 and table 2, single column records are available, like ones and zeros and some nulls. Okay, if you're not watching the video, please go and watch. So most of the interview common question is the joins, that questions, self join and left join, right join, inner join, cross join. So I have shared the Excel sheet, and the code also I have shared in the video description, and Google Drive link also shared. So today's video mostly we will focus on the, by using joins, we will write some basic SQL queries. Okay, so before jumping into the SQL queries, just look into the definitions. So the definition of inner join is it returns the matching records. So returns the matching records called as from the both tables, table 1 and table 2, both the tables from the matching records. And left join called as inner join plus left table which are not returned from the inner join. Okay, that is left join. Right join called as inner join plus right table which are not returned from inner join. That is right join. Full outer join or full join, inner join plus left table which are not returned from the inner join plus right table which were not returned from the inner join. That is the full join. Next, self join is when you join a table to itself, that is the self join, and cross join called as the Cartesian product. Okay, just creates the Cartesian product. So this is the simple definitions of joins. So if you are not, I will share this the notepad in the Google Drive, and the same content also I will share. I will try to share in the description, video description. Let's look into that. I am jumping into the SQL queries. Now in the SQL queries part, I'm using with the paintings dataset, like a new paintings and sales dataset. So let's look into the paintings table. So painting ID, name, artist ID, and listed price. So in painting dataset, ID is there, unique number, name called as the painting name, artist ID, and listed price. Similarly, artist have ID, first name and last name. Collectors dataset, collector ID, first name and last name. Similarly, sales dataset, ID, sale date, painting ID, artist ID, collector ID, sale price. So this painting ID relating to painting table, artist ID relating to artist table, collector ID relating to collectors table. When we join, based on these IDs only, we will join. Next, I will remove this part. Okay. Now we'll look into the one query. Fetch names of all the artists along with their painting name. If an artist does not have a painting yet, display as NA. So this query I will do as 2 parts. So first part I will mention as first line, fetch name of the all artists and along with their painting name. So let's look into this second line later. First we'll try to write the query, select from where. So where condition also we'll look into later part. For right now, I will try to use the join. Okay. So first table called as, so we need artist. So artist table. So in artist table, artists are available. So from artists, okay, artist rename, table name renaming to alias name A, and along with their painting name. So painting name called as the paintings. Let's copy the paintings P on. So these 2 data sets, on which basis we had to join. So artists, we have the ID is available. In paintings, artist ID is available. Let's consider this one. P dot in paintings dataset, P dot artist ID equal to, in artist table, A dot ID.
Okay. So first I use the join condition. Here I haven't written any join specifically. First basic join I'm writing. Select from artist table A, join paintings P on P dot artist ID equals to A dot ID. So on condition P dot artist ID A dot ID called as in paintings table artist ID is there. Similarly, in artist table I have ID column is there. That is artist called as A dot ID. Okay. Now I have written the join condition, that is fine. Now fetch the names of all artists. Names of all artists. So in artist column we have first name and last name. Two names are available. So these names we will do as concat. So by using concat we will get the name. So A dot first name. Why I have used the A dot A means A is the rename of the table name. Okay. A dot first name, comma, one single space, and A dot last name as artist name, comma, and painting name with their painting name. So painting dataset, I have the name column is there. Painting dataset name is P dot name. P means painting dataset. I have renamed to P. So and column name as name. Okay. If I use this one, I will get by default natural join. Inner join. Okay. By default, inner join will execute. Okay. By just I have written the join. But our condition is if an artist does not have a participating yet, display as NA. And fetch names of all the artists along with their painting name. So all the artists along with their painting name. So if I use with left join here, so why I have used the left join called as? So in artist table, I will get all the information. But paintings table, whoever the along with their painting name on, means whoever the artist is there. So for those artists, I will display as painting name. So there is no inner join, etc. So by default, I will fetch the all the artists. So all the artist called as I will use the left join. So from the left table as usual. Only for corresponding artists only I will use the paintings. Okay. So that's why I have written the left join. Now, so up to this one, fine. If I execute this part, okay, I get the artist name and painting name. P dot name as I will write as painting name underscore painting name. Now, if I execute this part, I'll get the painting name and artist name. But I have the null values there. So if any artist does not have a painting yet, display as null, display as NA. So this artist has no painting, just showing as null. So for this, I will use as one function called as coalesce. COALS COECE. COALESCE. ESCE. Okay, so this is the coalesce function. What is the coalesce function called as? Coalesce function which returns the non-null value. Okay, so to replace with the non-null value. So how I'll write the coalesce function called as? So coalesce p dot name, comma, I will replace the null values to NA. So NA, this one. Same thing I will replace to the p dot name. Okay. Now if I'll try to execute, so I'm replacing to display as NA. So wherever the artist does not have any painting, then display as NA. So this one by using COALESCE by using police. Okay. So this is the one output. Same thing can we do in by using case statement also. We'll try to use the using case. Same thing I will copy the above query. Okay. Now in place of this coalesce function, in place of coalesce function, I will use with the case function. Case when p dot name is null, then NA, else column, original column name as p dot name, right? Else p dot name and as painting name. So I'll use with by using case statement, we'll replace this same thing. This is one method, okay? And the same scenario without using the left join. Here I have used the left join, right? Artists left join paintings. So without using the left join, we'll try same query. So this one without using left join. So how we'll write the without using the left join? Simple thing. I will use the right join and I will replace with the table names vice versa. Okay. So now you will get the idea how it is working the joins. So just I do with the vice versa. So paintings and artists vice versa I had done. If I execute this part, I'll get the same information. So, but you are joining with this part only. This on condition is to be same. So how the join is working based on join condition and you return the table names. So this is most important. For example, if you are mentioned with left join means it is, yeah. So if you mention with the left join means artist table as the left, painting table as right. In this case, vice versa I had done painting as the left table, artist as right table. Okay. So this is one scenario. Next, so in this first scenario, I have covered as both left join and right join. Okay, we'll look into the another part. Find collectors who did not purchase any paintings. First, I will try to write select from join. Okay, and after join, we'll write as where also. Okay, so first I will try to join with find collectors who did not purchase any paintings. Find collectors who did not purchase any paintings. So, but did not purchase any paintings, that is the sales information. So let's write the sales, yes. Okay, and join to collectors because of we need to find the collectors. So collectors C on. Now we'll get the IDs. So in sales information, I have the collector ID is there, and in collectors, I have the ID is available on. So collectors information C dot ID equal to S dot collector ID. Okay, C dot ID equal to S dot collector ID. Now in select class, so select class we get the find collectors names. So find collector names called as, so I will use the same thing, this one, and I will rename to collector's name. So here I will do collector's name, or collector name. Okay, and who did not purchase any paintings. So who did not purchase any paintings called as comma sales table ID also we had to display, and where S dot ID is null. Okay, so now we'll get any did not purchase any paintings. So where sales ID is null, then we'll need those characters we did not purchase any paintings. Okay, now I will try to execute this part. Something error. On C dot ID, S dot collectors. So, okay, where SID dot is null. Okay, fine. Select concat of A dot first name. Oh, I have renamed, mistake done. C dot. Okay, C dot rename. Yeah. So collector's first name and last name I have done the mistake. I copy pasting. Okay. So for right now in our table there is no null records. Okay. If you add the any null records, then we will get the null records. But time being, we have no null records in this part. I will try to include some null records. Sales table is null. Quickly, I will add the one null record in the sales table. Then we'll get the idea. So this is part. Now here I will add null, enter, and sales information. Yeah, I have added one null record. Now I will try to execute this part. Where SID is null. Okay. Now I'm getting Christina Buffett as collectors who did not purchase any paintings. So Christina Buffett is not purchased any paintings. Okay. So that is the one scenario. Now we'll look into another scenario. Find how much each artist made from sales. Each artist means by default we'll go with group by with artist ID. Okay. Group by artist ID. And from sales, and how many paintings did they sell? So first let's try with select from join. So before writing this part, first I will get the each artist wise. I will do group by. Okay, select artist ID. I will do here select from and group by, right? So before joining, I will do this part. So first I want how much each artist made from sales. So group by artist ID, that I know artist ID, and copy select artist ID from artists. Okay, and find how much each artist made from sales. Sales called as sum of sales price as total price. Okay, now I will execute this part. Sales price artist table. Sorry, I had done the mistake. Sales price is available in sales table. Oh, okay. I had done this mistake. Artist table. Sales, we had to write. Okay. Now I will get the artist ID based on each and every artist wise. I have the total price is available. Now I will try to join with this one to select from join and group by. Okay. So now what we have to do, and how many paintings did they sell also? So how many paintings did they sell? How many means count. So here I have to use with artist table, artists A, and join with sales. Yes, on s dot artist ID equal to a dot ID. So this is the on condition I have given, and I will use the left to join by default. Artist table and sales table, I'm using the left to join. And group by, we need group by a dot ID. Artist wise, so sales and how many paintings did they sell. So I will do group by a dot ID. Same thing I will do as a dot ID and count of. So count of s dot ID sales as number of paintings sold. Just execute this part. So here I have the ID number of paintings sold. So ID 1234 1230. So this is I know. And how many paintings did they sell? So first to again I will rephrase the question. Find how much each artist made from sales. So this one, wait. Okay. So this one I know each and every artist wise.
and how many paintings did they sell. This one I know. Okay. Now what we have to do? We'll combine the both queries. Select from join. So first in from class I have to use with each and every artist wise. So this part I will copy and paste it here. Okay. Now I will get the from class. So from up to this part I am getting like I will what is a alias name I will give as A and join another table, right? So join will do as here I will do right join. Why I am using the right join call as all the information is available in artist ID, and this one from the sorry the right join called as so this table as the right table and this table will give as the left table. So copy this part. So now I'm using the right join. Why I'm using the intentionally I'm using the right join here. The entire information is available from this part. So we'll get the directly from this one. Whatever the matching records from this table, we'll take right join as usual. Okay. So this one I will give the alias name as B. Here I will write the condition on A dot ID equal to B dot artist ID. A dot ID equals to some artist table. This one A. In this part A artist ID, right? Artist ID. B dot in B table I have what is the condition A dot ID. So in B table I have available as ID on A dot artist ID equal to B dot ID. Now up to this part is okay. From class and select from this part. Okay. Then aliasing A, right join this part. Okay. Now I will write the select class. In select class we need the this part, right? So B dot ID. So B dot ID, comma, and total price also. Total price means sum of sales. Sum of else directly I will write the total price. So if total price is zero, if total price is null, then we'll return the zero. So we know Coalesce function, COALESCE, Coalesce, total price, comma, 0 as total price and number of paintings sold. Okay. So I have written the in select class, one is ID, one is total price, and one is number of paintings sold. So if I execute this part, I will remove this one. So if I execute, okay, I have written the ID, total price, and number of paintings sold. Okay. So this way we will write as the subqueries. Okay. And with join, using the join. So same thing we will write as a simple way. We'll try to write with the simple way. I will write as select from join and group by. Okay. And order by also will write somewhere. Okay. So first of all, group by. So group by on which basis we need to group by? So we need to group by on three conditions. So we need artist table. So group by. So first I will write as A dot ID, comma A dot first name, comma A dot last name. We need to group by this one. And from class. So from class we need artists, artist A, and left join. Which table left join? Sales. Yes. On S dot artist ID equal to A dot ID. Okay. So in artist table, we have ID is available, first name available, last name available, and I'm joining with sales table on this condition. Now I will write the select clause. So in select clause, we need first ID. So a dot ID, comma, and we need artist name. So that is concat of a dot first name, comma, single space, a dot last name as artist name. Artist name will get. Next thing is sum of sales. So sum of sales price, sum of sales price as total price. If sum of sales price is any nulls, then we'll return as 0. So that will use the colis, COILESCE, colis, comma, 0. So we will return as this total price, comma, and we need count also. Count of s dot id as number of paintings sold. Okay. So here we have written how many columns? First, a dot ID I have taken, and artist name also I have considered in this case, and total price, number of paintings sold, and group by first one ID, first name, last name. First name, last name already mentioned here in this part, and other one total price. So total price and two aggregations. This part. So two aggregations are, one is the sum and one is the count. And first I will execute this group by class. I'm getting this one. If I need order by also, a dot ID. Okay. So, but in this one, I have very less number of records. That is the reason order by is not impacting here. And nulls also I have in my data not added much. So that is the one impacting also. So this one by using one of the best solution. So rewrite using simple solution. So as compared to above step, this is the one simple solution and much better solution also. Okay. So this is the one scenarios I have used with by using joins. 3 scenarios I have used it. Okay. Thank you. Thank you for watching. Please like and subscribe if you like the content.
Hello guys, welcome to my channel. So today's video is we have the continuation of our SQL series. So the previous video is I had done CTE. So part 1 covered. So 2 queries I have covered in 2 scenarios. So one more scenario covered one of the most important interview question also this one. Most of the times I also faced the same this question. So this one also we had to solve by using CTE. So let's see this scenario first of all. The scenario is find the popularity percentage for each user on Meta or Facebook. So simple thing is to find the popularity percentage for each user. For example, each user called as, so for example, mine, so myself Vijay. So so Vijay has some friends. Okay. So we had to get the Vijay popularity percentage. Okay. So like that, we'll see the question continuation. The popularity percentage is defined as the total number of friends the user has divided by the total number of users on the platform, then converted to percentage by multiplying by 100. Output each user along with their popularity percentage. Order records in ascending order by user ID. So first, before looking to the problem, I created one sample database so by using this scenario. So first, let's drop the table. So after dropping the table, I just create with the simple table user1 int and user2 int. So table name as Facebook friends. Okay. And I will insert with some records. Just randomly I have taken with this Facebook friends table. Values are this one. Like, let's look into the values. So here I have taken 2 rows, user1 and user2. So user1, for example, 2.
So user 1, 2 has friend 1. So vice versa also. So if one has user 2 has 1, so one has the friend of user 1, 2 also. Okay. So for example, here user 1 has friend 3, one has friend 5, one has friend 6. So let's look into the, for example, user 1, how many friends? So first user 1, 3, 1, 2, 3, 4, and 5. So user 1 has 5 friends. Like this, we have to find the total number of friends with popularity percentage for each user. Let's identify this one. First, we'll look into this part as how many friends does user ID 1. Let's look into how many friends does user ID 1. So for user ID 1, how many friends? First user ID 1. I'll write the just the numbers here. 1, 3, 1, 5, and 1, 6. Next 1, 2, and next 1, 4. So total here 5 friends. Okay. So this way we have to find the each user how many number of friends. So the same problem, let's break it to the parts. First, we'll calculate the total number of users in FB. Okay. Then we have to find number of friends each user. Okay. So once we get this information, then what we can do? So if we do B by A, so B by A called as number of friends for each user divided by total number of users, we'll get the percentage. So that percentage we'll do as, so B by A multiplies 100, we'll get the percentage. Okay, simple things. So let's look into this part. So first of all, we'll write the query basic one. First, I will get the users. For user 1, how many number of friends? Select. So I will write this part, right? Select direct. I will write this one. Select star from Facebook friends. Okay. Now here I will write as user 1. So user 1 as users. Okay. So here I get the users for user 1. So in this user 1, I know same thing. I will copy paste to user 2. Okay. So in this part, I will get the user 2. Now what I can do, I want only all the combinations, user 1 and user 2. Let's try to write the union all. What happened? I'll remove the semicolon. So here how many I get? 18 rows. So everything is to be mixed. All I get the users. So every, I mean, in entire table, all the users I get. Now what we can do? We need distinct users. Now select. I will try to write as count of users from this one. Okay, and we'll give as X subquery. If I do this one, I get the 18. But this is total users. I want only first distinct users. How many distinct users? So if I write this part, distinct users I will get. Okay. So now distinct users are 9. So we'll try to write the same thing by using CTE. With CTE as, open the brace. Now what we can do? I have the same query. This I will be pasting into CTE. Okay. Now, for example, this one has, so this all users. This is all users. So I will try to write the CTE name as all users. Okay, all users. Next thing, I will try to write another CTE called as number of friends. Number of friends as, open the brace. Now in this part, I will try to write as from all users only. So number of friends called as, so we need total friends, and so from all users only we'll get the number of friends. So select from. So from is, so I'm getting this all users only. I will write the all users. So from all users, I will get the group by. So group by users. Okay. So this users is available. So I will do group by users. So here also we'll try to write the users. Okay. Users, comma, count of 1 as total friends. So this I will get the total friends. So up to this one. Okay. Group by. So this one close. Now I will try to write with the total number of users. Okay. So total number of users as, so this is again third CTE. So total number of users. So here I will take as select from. So total number of users. So we'll get from all users. This part only from all users. So here what we can take total number of users called as, so total number of users called as distinct users. So above we have written this part, right? Count of distinct users, this part. So this will write as here. Select count of distinct users as total users. Okay. So up to this one, fine. Now we'll try to write the select part. So this one I will close here. Main query will write here, select part. So select part is select from. So from which one I have to write here? From first I will get the number of friends. From number of friends. Number of friends as n. So here what I can do is, I know number of friends and I know total number of users. So if you know total, I mean number of friends and total number of users, if we do cross join, okay, so cross join total number of users, this one. So this one will call as T. So let's say here select star. If I execute this one, what I will get the output with, let's try this part first of all. Okay. So if we look into this, so total number of users are 9. So user 1 has how many number of friends? 5. User 2 has how many number of friends? 3. User 3 has 3 friends. User 4 has 1 friend. So we have total friends is available, but we want only percentage. So here I will try to write in select part. In select part, first we will get the users. So write the users, comma, and we need total friends. Total friends. So here we need percentage of each user has, means total friends divided by total users. So total friends divided by total users multiplies 100. So this is only we will get the as percentage. How we'll call this one? Popularity percentage. Let's give as popularity percentage. Okay. So if I try to execute this part, let's see. So popularity percentage, we get the 0. So why we get the 0? Any idea? So popularity percentage. So this one has integer part. So let's convert to this one as decimal. So in SQL, we have the convert to decimal as cast. Cast of total friends as decimal. And this one also will convert to cast. Cast of total users as decimal. Okay. Now we'll try. Okay. So now I got the popularity percentage. So decimals are more number of decimals. Let's restrict to 2 decimals, this one. So again, we had to restrict to 2 decimals, cast of this one up to this part as decimal. So decimal of 5,2. So we'll restricting to 2 decimals. Okay. So if I do, yeah. So I get the popularity percentage. So for user 1, 55.56. Okay. Yes. Okay. So this way we will write the query by using CTE. Okay. So this is one of the most interview question previously also asking the scenarios. Okay. Thank you. Thank you for watching. Please like and subscribe. I'll share the code in the video description. Thank you.
Hello guys, welcome to my channel. So today's in our SQL series video, we will discuss about with the window functions or analytic functions. So window functions are we'll call as the analytic functions. So generally, the window functions are main. We'll focus in real-time scenarios. So frequently we'll use rank and dense rank. This is the one of the most common interview question also. Rank and dense rank with same row number also. So these 3 functions commonly we'll use, and occasionally we'll use with the lead lag also, and remaining other functions rarely we'll use. That is first value, last value, nth value, entile, cum district, percent rank. So these are the some window functions or analytic functions. So first of all, what is the function? So function called as it is a named block of code which will always return a value when it is called. So when the function is to be called, it will return a value that is called as a function. So for window functions or analytic functions, so where we have to use and how we'll use the syntax and this one we'll discuss now. So for this, first I will take the one example here. I'll create the table. Some example table I'm creating, employee table. So first I will drop the table. Then I will create the table first. Create table, employee with I have taken as employee ID, employee name, department name, and salary. For this, I will insert some records. Okay, so inserted, and now we'll check with the this part employee. Select a star from employee. So here I have the how many records I have? 24 records. So for 24 records, so employee ID, employee name, department name, and salary. Now, if you look into this, so employee ID's ascending order is there. Okay, fine. If I want department name ascending order, I will write the order by. So, but exact I am not sure this part how it is working. So how many departments and etc. So we'll check with the how many departments first. So if I execute this part, order by department name and employee ID. So order by department, sorry, sorry. Order by department name is admin. So admin, how many records? 4 records are available. So for 4 records, salary 101, employee ID 101, 108, 113, and 120. So these are the salary details. Okay. Now we'll look into some scenarios. We'll go back to. So our first question is first query. We're looking to fetch the first 2 employees from each department to join the company. Fetch the first 2 employees from each department to join the company. So let's look into our table is this one, right? Already we have executed. So in this table, fetch the first two employees. So first two employees means how we know the employees, first two employees, and the first two employees from each department. So when you look into this query, first in our mind, we'll look into each department. So each department means we have to group by. Okay, generally our thought is we have to group by. Like, so group by, after grouping this part, next we'll see the first two employees. That how we'll see the that part. So for example, if I write with like select from employee group by each department. So department name. So I will write as department name here. So if I do this one, how many departments I get? 1, 2, 3, 4. 4 departments I get. So each department wise, okay. So from each department, I need 2 employees again. Okay. So for this, we will write as this one. So each department, 2 employees we need. So if we look into the data, like for example, each department 2 employees. So if we look into department name admin, so admin, I have 4 records available. But in these 4 records, I need first 2 employees. So if you look into this ascending order, this ascending order also available, employee ID 101 and 108. So first 2 records means 101 and 108. These 2 records I want. And next department 104, 106. Next department 102, 105. So this way I need to get the first 2 employees. So first 2 employees, how we know means based on employee ID. So when the employee joins, the order number is assigned. Like employee ID is the unique number. That is first come first serve number is assigned. Okay. Now, so this one will solve by using window function and or analytic function. So by using row number function, we will assign a unique row number. So based on that, we will get the first 2 employees. Okay. So let's try to write this one. Select from employee. Okay. Now here, star, comma, I will try to write the row number function. Row number. So this is the function. How we'll write the row number function called? This is the row number function we'll write. Next, we'll write the over class. So over. So inside the over class, we'll write the any partition by or order by. So partition by called as, so partition the data each department wise. Means partition, I will explain. Right? So over partition by, for example, partition by I will take as department name. So what happened? Partition by department name called as. So in this department name admin. So this first department name is the admin. So for admin, one window will created. That is called as the window function. So what window function will do? So row number is to create the row number. So after writing the row number function, we have written as over class. So inside the over class, we'll try to write the partition by. So partition means to create the partition by using each department. So in each department, so for example, admin is one department. So for admin, one window created, and finance, one window created internally. So that is the meaning of partition by. So partition by department name. So we'll try to find this one as row number RN. Let's try to see this one. Over class with order by. So we had to use the order by also. So I have partition by this one. So inside this, I will try to write as the order by. So which order? I need ascending order or descending order, and which column? Order by also. So I want order by employee ID. So we have the employee ID unique. So employee ID. So if I execute this part, what happened? So order by employee ID. So try to see the function. Row number, over class, partition by department name, order by employee ID. So we need order by each and every window function will create one window based on employee ID. First come first serve. We need first 2 employees. So row number is to be created. So that is also unique number with each department. So if you look into this admin part, 1, 2, 3, 4. Finance 1, 2, 3, 4. So each department, one unique number is created, row number column. Now, so we have from each department to join the company. So we get the details. Next one, fetch the first 2 employees. So we have to fetch the 2 employees, first 2 employees. How we'll get this one? So this one will write multiple ways. By using subqueries we'll write, by using CTEs also we'll write. Okay, so try to write this part as select star from this one. So this one I will call as subquery up to this one, x, where x dot rn. So we need first 2 rows, first 2 employees. So that means x dot rn in 1, 2. Okay, so if I execute this part, okay, so I get the only 2 employees. Each and every department wise, I get the 2 employees. So fetch the 2 employees from each department to join the company. So 101, 108 admin, finance 2 employees, HR 2 employees, IT 2 employees. So this way we'll try to write the queries. For example, in this row number function, select star comma row number function. If I write as over without writing the partition by, like just I will write the order by employee ID. What happened? As RN from employee. So if I execute this part, what happened? So the window function is not created here. So window means so partition is not created. So entire result set is creating one window set. Entire result set is creating as one result set. That is without mentioning with the partition by. So here we had done over order by employee ID. So this part only executing. So entire result set is to be executing 24 records. Okay, this is the one way. So here we have used as so first function row number with over class. Okay. Next we'll see the another example. So second example, fetch the top 3 employees in each department earning the max salary. So we know select star from employee table. So in this each department earning the max salary. So max salary called as so how we'll get this one. So max salary each department earning the max salary top 3 employees. So for example, where it is order by this one if I execute. So if we look into admin department, so admin department our question is fetch the top 3 employees. So admin department top 3 employees. So max salary. So first to salary wise descending order. If we consider descending order, right? We need because this one has order by DESC. No salary descending order we need. Okay. So for example, if you consider as admin department salary is 4,000, 4,000. Next one 5,000 also. 5,000 first record. Next to 4,000 and 4,000. So this way we'll get to. But if I have the same salary, how we'll get? So that we have to check. So how we'll deal this one? Okay. So for this, first we'll try to write as select star comma. First I will write the row number, how it is looking. Then I will write the other function. First row number over. Here we have to do any partition. Yes, we have to do the partition based on each department. So partition by department name. Okay. Order by. So here order by which one we have to order. So previous query we have order by employee ID. So in this part we need each department earning the max salary. So order by I need salary wise descending order, right? So order by salary DESC. Order by salary DESC as row number. Comma. I will copy this entire thing or else first execute this part. From employee. If I execute this, I will get the row number. So row number is getting based on each department.
partition by department, right? So each department wise, I get the row number, unique number. Now, but we want max salary for top 3 employees. So here, for example, if you look into admin department, 5,000, that is fine, first rank. Second one, 4,000, second, 4,000, same, but which is assigned as 3. So if we get the same salary, then how we can fix this one? So this is the we'll use rank function. So again, I will write this part as in place of row number, I will use just a rank. The remaining is same. Only I will rename the rank. Just now look into this part, rank, what is the difference? So row number is assigned as based on unique number, based on department and salary, unique number. Rank is assigned as, if you look into this part carefully, 1, 2, 3, 2. So here the rank is, if the salary is to be same, the rank is assigned as same. And here there is no third rank. So that one rank is to be skipped here. That is 4. So this is the rank. So what is the rank called as? So if the duplicate value or if the number is to be same, then assign the same rank. And how many number of the values are same? Those values, the numbers will be skipped. For example, here 2 values are same. So 2 values assigned as second rank, but third rank skipped and assigned fourth rank. So this is the one way we'll use. And other way, one more function called as the dense rank. So dense rank, I execute. So dense rank, if you look into this part, the admin part. So now row number is assigned as unique number, that we know already. Rank assigned as one number is to be skipping, and if the number is to be same, it will assign as same number. Then one number is to be skipping. If you look into dense rank, so dense rank same, like if the number is to be same, then assign the same value, but the number is not skipping. It will continue with the series. So 1, 2, 2, 3. So if the salary is 4,000 for admin, Mohan and Mariam, it assigned as second rank only, but the rank is not skipped in dense rank. Okay. So this is the row number, rank, and dense rank. Okay. Let me try to finish this one. So this is the one of the common interview question. So if you attend any data analytics interview or data engineering interview, SQL interview, row number, rank, dense rank is the common interview question. So first question is what is the difference between row number, rank, and dense rank? So row number, it will assign as unique number. Rank, if the value is to be same, it will skip the rank. Dense rank, it will not skip the rank. But rank and dense rank, if the value is to be same, it will assign the same rank. Okay. So that is the for this fetch the top 3 employees. Okay. Next, we'll look into one more example. Okay. Here I consider as one scenario. So this scenario is also one of the interview problem. So here in this scenario, we try to look into this one. Find the date with the highest total energy consumption from the Meta or Facebook data centers. Output the date along with the total energy consumption across all data centers. If there are multiple days with same highest energy consumption, then display both dates. So output is the date along with the total energy consumption axis across all the data centers. So date along with total energy consumption. And if there are any multiple days with the same highest energy consumption, then display both dates. Okay. So for this, first we'll try to create the table. So I'm taking 3 tables. One is FB, EU energy, date, and consumption. Similarly, I'll consider as same thing. But here the scenario I have creating as multiple tables with the table structure is to be same. If you insert these records, next to this part, next to this part. Now we'll try to execute
three tables, how the data. So day to consumption, here 5 records available. Next day to consumption, 6 records. Next day to consumption, 5 records are available here. Now we'll see our scenario is, okay. So we have the date and consumption is available, but the data is available as 3 tables. We need output is the date along with the total energy consumption across all the data centers. So date along with total consumption. So total consumption, so remaining tables, I don't know how it is the dates and so on. Okay. So you have the three tables. For example, in real-time scenarios, multiple files also maybe you will get to. So at the time, how we'll deal? So generally, this type of scenarios, how we had to deal called as, so one common methodology is, so by applying the union all. So if you, what is union all called as? So if you do the union all by using 3 tables, so it will combine as 1 table. So then we will apply as the date part along with total energy consumption. So we'll try to this one. Now here we'll write as, so this one we'll try to first union all. I'll fetch the 3 tables first. First copy these 3 tables. Here I will write as union all. Then again union all. I'll remove this part. So if I execute this part, total how many records I will get? 16 rows. Okay, so now I get the date and consumption. That is fine. Now we will get the date part, I know, and we know sum of consumption also. So sum of consumption, for example, here, if I try to this one order by date. So if you look into this part, date, so for first date 2020, 3 dates are available and consumption. So one single date only, but 3 records is there. Okay. So in this case, what we can do? So we need only each date wise, but here multiple records are for one particular date only multiple records are there, but we need only date wise total consumption. So at that time, what we can think is, by default we'll apply as a group by. So if we apply the group by, one date will get and sum of consumption will get. Okay, so try to this one. So order by not required right now. So this entire part I will store as one CTE with CTE as open brace, and here this one close comma select from CTE. Okay, group by. So group by I need date, group by date, and select part also I had to add date comma sum of consumption. Sum of consumption as total consumption. Sum of consumption as total consumption. Now if I execute this part, how I'll get? Select part is so okay. Okay. So this entire thing we had to store it somewhere, and we'll get this one, right? So incorrect syntax, so select keyword. Select keyword. Let's try to this part execute first. Okay. Select date comma sum of consumption as total consumption from CTE group by date. But okay, one thing we'll do. So we'll store this one as in one another CTE with CTE aggregation as open brace. Close this part. Okay, and now we'll try to write as select star from CTE AGG. Okay, if I execute this part, again incorrect syntax near the keyword with if this statement. Okay, somewhere it is missing.
select date, comma, sum of consumption as total consumption, CTE, group by date. So if I execute this one first, date, okay. So DATE and group by date, sum of consumption, sum of COMPTION, sum of consumption as total consumption from CTE group by date. Okay, select to start from CTE CAGG. This one fine. Anything missing? Incorrect syntax, keyword with okay, so with the class. Okay, got it. Okay, so now we'll get the some result. So what the result we'll get? So date and total consumption we get. But now for this one, we want, what is the condition here? Output the date along with the total energy consumption across all the data centers. That is we get. And if there are multiple days with the same highest energy consumption, then display as both dates. For example, here only we need, if we get the highest to total consumption, right? Highest energy consumption. So highest energy consumption, for example, in this, if multiple days with same highest energy consumption. So for example, if you look into this part, so this is same only. So in this case, we'll display as both dates. Okay. But we want only one record. So for example, for time being, if I give the top one, okay. But later case stage, exactly we don't know. So if multiple records also, so that we had to set. So if multiple records also same value, that we had to set as by using rank function only. So we'll try to write as comma rank of over partition by. So here I think partition by is not required here in this part. So we'll try to over order by with sum of consumption. So this one only we are doing the order by. So sum of consumption with the DESC, descending order only, highest consumption as rank. So now if I execute this part, I will get the rank. So rank will filter later stage. Okay. So now if you look into this part, if multiple dates also will get the total consumption is to be same, we'll get the 2 dates. That is only condition. So for right now, we'll give as where condition, where rank equal to 1, where rank equal to 1. So if I execute this part, we'll get the rank, simple one. So this is the one scenario for by using the rank. So this one covered as, so how many functions? So till now we have covered 3 functions. So next stage we will cover as the lead and lag. Next video I will do the part 2 video, and part 3 will cover as other all options. Okay. Thank you for watching. Please like and subscribe if you like the content. I'll share this code in the video description, and I will share the file also in the Google Drive link. Please look into that. Thank you. Please like and subscribe.
Hello guys, welcome to my channel. So today's video is, so we will discuss about with the 2 important window functions, that is lead and lag. So this is very small video only. The last video I have covered as the rank, row number, and dense rank covered. So this I will cover as lead and lag. So for this example, I will consider as one scenario. From the students table, write a SQL query to interchange the adjacent student names. So in the student table, write a SQL query to interchange the adjacent student names. So note point is, if there are no adjacent student, then the student name should stay the same. So let's create the table first here. I'm creating one sample table here, student table. So student table I have taken as ID and student name, some sample database. Okay, 5 rows created, students. So in this part, I have ID student name. So our
question is here, from the student table, write a SQL query to interchange the adjacent student names. So adjacent means, for example, and one more condition is, so if there are no adjacent student, then the student name should stay the same. So let's see, for example, if 1, 2, 1 adjacent, this one 2, 2 adjacent, 1, 3, 4. So 1, 2, first we'll check this pathway. 1, 2, 3, 4, and 5. So if there are no adjacent student, then student name should stay the same. So for example, 5. So there is no adjacent. So then 5 no adjacent means it will display as student name Robin only. For example, these 2 adjacent. So these 2 adjacent means, so for 2 Michael. So Michael adjacent is James. So we'll replace to swap like James, first row to second row to first row. Similarly, these 2 also, third row to fourth row to third row. So for this, we have to use with lead and lag function. So how we'll use the lead and lag called as, so generally this one how we'll consider as, so if you assume this one ID as the first row, like this one as first row and third row. So these are odd rows. Even rows are 2, 4. So if you find the odd and even, then we will get the scenario. Okay. So, and how it is working the lead and lag called as, so lead means, so it will go with the next row, that is forward. For example, if 1, so for 1 lead, so that is second row, third lead, fourth row, like this. Lag means previous row. So for example, for 2 lag, so 2 lag means that is the James first row. For third one, George lag, Michael, Stewart lag, George. So this is the previous row. So lead is moving to forward, lag is previous row, and we'll give the position number also. So this is some general scenario I'm saying. If you want 2 positions previous or 2 positions next to forwarding, that will assign as the number in the syntax. Okay. So let's try to write this part first. I will try to write as, so this one, select from students. So here I will write as case when, so this one first will get the whether it is odd or even. Okay. So our column is ID. So that is modulo ID percent 2 equal to 0. Then odd, else even. Like this I'm writing. So for example, ID percent 2 equals to 0, then odd. So for example, this one, if I divide 1 divided by 2 equal to 0, then odd. So we'll write as not equal to 0. Then it will consider as, from students case when this one even, and as new student, and include the star also here. We'll get the idea. Execute. So ID, student name, new student. So first row is odd number, right? So odd row. So we'll get the odd. Second row even. Third row odd. Fourth row even. Fifth row odd. Okay, let's see. Will this condition will so what condition called as fifth row? If in the scenario, note if there are no adjacent student, then the student name should stay the same. So then this name will replace to same name only. So because there is no adjacent row. So this one will write later condition. For time being, I will write as this one. So for odd is so here I will write as, so next row. So it will move to odd next row, even previous row. Just I'm writing. So if I execute this part, how I get odd row, next row, even previous row, odd next row, even previous row, odd next row. Now here I will try to write with this same condition here. In place of this part, I will try to write the lead function. So lead. So in this lead, how we'll write the lead function? So we had to mention the column name in the lead. So what is the column name? Column name is the student name. Student name, lead of student name over. So here in this over, we'll write the order by. So order by, we have the other column ID, order by ID. So this is descending order only will follow. Let's try to see how it is working. So next row means, so for example, So this lead is writing as Michael. So Michael is moving to above. Next to Stewart is moving to up. Okay. So this one working. So next to this one is null. So this one will replace to student name only. So this one will replace to student name. Here we'll try to write as so comma 1 comma student name. So one means is a default to position. So that is one position will move up. Else replace the student name. So if I write, so Robin will replace to Robin only. If there is no adjacent row. Similarly, else condition will try to write as lag function. So lag of same thing. So like lead function only. Lag of student name over order by ID. Over order by ID. Now this one end as new student. Okay. If I execute this, so for I get the James is so these two adjacent exchanged, right? So James, Michael, these two adjacent exchanged. If no adjacent, then replace to student name. Okay, so this way we'll write. So here what we have to use in this one, mainly we use the two functions. One is the lead and lag. So lead is next to row, forwarding, lag is previous row. Okay, so these two functions are very most important while using the in real-time scenarios. So it's very useful. Okay, and interview questions also they will ask these two functions, lead and lag. Thank you for watching. Please like and subscribe.
Hello guys, welcome to my channel. So today's video is we have to cover as SQL window functions, first value and last value in our SQL series. So the last video I have covered as window functions rank, dense rank, row number, and lead, lag. So these functions covered. So in this video we will cover as first value and last value. So we'll try to look into the scenario how it will work as first value and last value. First I will create as one table, simple table. I will create as a product table. So for product table, this one as product category, varchar, brand, varchar, product name, price I'm taking. So let's first drop the table. Okay, and I have to create the table again. So table dropped, and I will insert some values in this part. So let's insert the values. So once I inserted how many values, 27 rows affected. Let's check the product table. If you look into product table, how many rows I have? Total 27 rows I have. So in this table, I have covered as mainly product category, brand, product name, price. Product category as different categories: phones, so laptop, earphones, headphones, smartwatch, etc. And similarly, brand and product name. So product name is covered as, for example, phone. So phones, for example, Apple phone is covered as different product names, like iPhone 12, iPhone 12 Pro, etc. Similarly, Samsung, different phones, OnePlus, different phones. Same way, price also, just for the example, the price quoted here, just one simple data purpose only. We will look into the scenario. Let's look the scenario. Write a query to display the most expensive product under each category. So here we want the within the product table display the most expensive product for each category. So that is corresponding to each record. Okay. So each category called as, for example, most expensive product. So expensive product called as, so for example, if you consider as product names, so different product names are available. So within this most expensive product under each category. Okay. So under each category means, so generally we will look into this one as like group by something. Okay. But in this case, we will use the window function, that is first value. So most expensive means so generally highest value, right? So that is the first value. So highest price, so which of the product is the product category wise, we have to partition the data. That is by using first value. So that is the highest price. Let's look into the table first of all.
select star from product. So already I have the product table is there. Now I will try to order by price, DESC. I want descending order only, right? Highest price. If you look this table, product category, highest product category wise, I get the highest price. For example, laptop Dell XPS 70 2500. So this is the most expensive. Similarly, laptop Microsoft Surface laptop for 2100, like this. So we'll do, first of all, how many distinct products are available. Distinct product category from product. So how many products are available, first of all? So earphones, headphones, laptop, phone, and smartwatch. So now we'll try to write this one. For example, if you do group by, how we'll write the group by? Select from, so from table called as the product group by. So group by product category. Okay, so product category we'll mention as select part, and we need highest sales. Most expensive means highest sales. So we'll try to write as so max function. So max of price, comma max of product name. Okay, so if we do this group by, how we'll get the result? So we are getting something earphones 280 price, so max price. But earphones, so we seen earphones 280 max price. We'll check the earphones. What is the max price of earphone? Earphone. Okay, let's check with better laptop. First category laptop. So laptop 2500. Okay, so for 2500. Okay, so this is the first product we are getting. But this product name is XPS 17. So here what we are getting? Product name we are getting, that is something wrong. Okay? So this is not working. Okay, so in this, the same thing we'll try to write as so. So let's assume this one as so some wrong solution. Same thing we'll write as so by using first value. Select from product. Okay, so here select star comma. I will try to write as so first value. First value is the window analytic function, but first value on basis of which column we have to identify. So first value based on product name. So we have to get the highest value based on product name, and over here we need to write the partition are not required. So let's look into the question. Display the most expensive product under each category. So category wise we have to partition. So partition by product category. Okay, next order by price. So we need descending price. So price DESC. So this one will call as most expensive product. Okay, right. So here what I have done, let's look into the part first value. So what is the first value is doing? So this column returns the name of the most expensive product in each product category. Okay, so let's look into this partition by product category. So partition by product category is mainly the data set into partitions or groups based on product category, and order by descending price. Next, first value. What is the function of first value of product name? So first value, this main purpose is so it will return the product name in each partition when ordered by price descending. Okay, so this will get the max price. So based on the product name, we'll get the order price as highest price in descending order.
Right. If we'll try to execute this part. So let's check with the earphones. First of all, this earphones category. So in earphones category, we have the brands Apple, Sony, Samsung. So product name, AirPods, and price also available. So which one is the highest price? 280 rupees, AirPods. So we get the most expensive product as AirPods. Similarly, headphones, AirPods Max. Similarly, laptop, XPS 17. Okay. So this way, we will get the most expensive product. So this is one example for first value. Then we'll check with another scenario, like first value covered, last value also will cover in this scenario. So in this part, write a query to display the most and least expensive product under each category. So I'm considering the same table with the same thing. Okay. So let's try to copy the same thing better. So first value, I'm doing first value of product name over partition by product category by price. Okay. Now I will try to mimic with the last value. So last value, or else copy the entire thing better. So this entire thing, I will change with the only in place of first value, we'll get the last value. Last value of product name, partition by product category, order by price, DESC. Okay. So this one called as least price. If I execute this, we will get the least price or not. So least price or not, whether we'll get the, so least price is mainly, I will explain how it is working. Something is missing. Keyword from comma. Okay. Okay. Let's check with the most expensive price. We are getting fine. Similarly, we'll get the least expensive price. But here, if you look into the earphones, so what is the least price? 170. So what is the 170 product name? Galaxy Buds Live. But here we are getting this last row, Galaxy Buds Live. Okay. But AirPods Pro, WFF, Galaxy Buds Pro, Galaxy Buds Live. So why we have get this this type of information, something wrong information called as so. So generally what happened is the last value function is this does not necessarily to return the least expensive product. So because the default frame might not cover the entire partition. That is, the partition is not covered by the entire partition. So that is the reason last value is not giving the full-fledged what we say, the correct result. Okay. So entire result is not correct. So in place of this, we will try to write as one condition. That is frame clause. So frame clause called as mainly like hierarchy of data. So within the result set, how we are partitioning by using window function, we partition the data. Okay, that is partition by over class. And within that, we'll try to write as the frame. So that frame clause is mainly that is range. So we will try to write as the range the statement. So that is the default frame clause is mainly this one, range between unbounded, preceding, and current row. So this is the by default frame clause. So we'll try to include this. I'll copy first this entire thing. We'll try to include this frame clause here. First of all, last value product name over partition by product category under this one fine. Now I will try to write as here descending range between this one, range between unbounded, preceding, and current row. Now I will add a alias name up to this one close. Partition by this from here starting and up to DESC will close and remove this one. This entire thing will execute. So here this one called as range between is, so the main purpose of this range is
it explicitly defines the window frame, the first row to the current row. So explicitly defines the window frame from the first row to the current row within the partition. But this result set also exactly not clear, but some better. But the default frame class is one only. So the value, whatever the value we get the result. So that is the product. Let's look into the value later. I will explain this one better. So for example, this one least expensive product 1. I'm giving the just name understanding purpose. If I execute, you look into the least expensive product and least expensive product 1. What is the changes? Any changes here? No change, right? Same result we are getting. So this way we'll not get the. It does not necessarily to represent the least expensive product for the entire partition, okay? But rather for the range specified. So only we have mentioned as range specified. So the same thing will change a little bit. In place of current row, I will try to write again this entire thing, copy, comma, paste it, least expensive product 2, and preceding will change as current row 2, unbounded following. Unbounded following. If you execute this part, now you look into this. So actually earphones least price is Galaxy Buds Live, 170 rupees. So I have given the Galaxy Buds Live earphones. Next to headphones, Surface headphones 2. Surface headphones 2 I'm getting. Laptops, laptop least price is so MacBook Air. So MacBook Air getting. So this way we will get the least expensive price. But these two conditions are not working correctly. Okay. So sometimes it happen like the main this unbounded following result is, so it will return the least expensive product within the entire category. So as it considers all the rows within the partition. And remaining this partition by product category, last value function, this all same. Only this range is to be specified and unbounded following. So this is the least expensive product. If we want, we can comment this one, and this one also will comment and execute. Now we will get the between somewhere it is. Yeah, this one also will comment. If I execute, okay, so now I will get the most expensive product and least expensive product. Okay, so this is the one example. Next, I will look into the some aggregate functions like so aggregate function by using window functions. We'll try to write as the like aggregate functions like min value and max value, like minimum price and maximum price. Here I will try to write as select star from product. So if we get this table, now I will try to get the max price. So here in this one, we'll get the max and min value of every product wise. So max price called as, so comma, I will write as max of price over. Here we have to try to the same partition. So partition by product category. Partition by product category. Now order by price. That is also same. Order by price DASC. So this one as we'll call max price. So the same thing will copy. I will try to write as the min function also. Min price. Here you'll get the min of price. If I execute this one, how I will get the result? Let's check the values. So first of all, I will consider as earphones. So for earphones, what is the max value? 280. So I will get the max value is 280. What is the least price? 170, minimum price. So min price, we are getting 280, 250, 220, and 170. So again, we are getting the same thing. So minimum price we are not getting, right? So here we have to add the range unbounded. So I will copy this entire thing, range unbounded. Will add as here price DESC. After then, I will add
range between unbounded preceding and unbounded following. Now I will get the minimum price. So let's check now earphones. So earphones list price as 170 and headphones list price 250. Okay. So this is the way we'll try to get the max price and min price. So this is one example using aggregate functions as window functions. Now we'll try to get the one scenario. That scenario is mainly write a query to segregate all the expensive phones, mid-range phones, and cheaper phones. Like we'll write the one function. So that function only will split the based on the price. It will automatically to split the expensive phones, mid-range phones, and cheaper phones. Now I'm creating the 3 categories. So how it will split this data? So we have the function called as that is NULL function is there. So to create the buckets. So first we'll create the buckets by using this by using case we'll create the buckets. Then we'll write the NULL function. Okay. So first we'll try to write the select from product. Okay. Now here we'll try to write the select part, select star comma sorry, case when buckets equal to 1, then to display expensive phones. Okay. Next to bucket 2. Bucket 2 is when buckets equal to 2, then display mid-range phones. Mid-range phones. Okay. Now else part is cheaper phones. Cheaper phones. Okay. And close. So this one up to and else part is over. And as phone category, I created the one column here. This one as phone category, one column I have created. So by using case, so within the product this table, I created as one bucket. So that bucket is called as so case by using case buckets 1. So if bucket 1, then expensive phones. Bucket 2, then mid-range phones, else cheaper phones. This one fine. Now we'll try to write as the within the from class, or else we'll try to write the this one select a star from product. Okay, fine. This is so up to this one we'll call this is the main query. Inside this we'll try to write the same thing again, select from product. Okay, so if I get this part, select from product. Now we'll try to write as select a star comma. Here I will try to write as the NULL function. So what NULL function is? It is automatically creates number of buckets. So NULL. So I'm giving the 3 NULL number. Number is 3. So number 3 means it will create as the 3 buckets. Now over class is same as usual. So but in over class we can't partition anything. So already we given the buckets. So NULL function is creating the buckets, 3 buckets. Now over class order by price DESC. So this one we'll call as buckets. Okay. So this one we'll call as buckets. Up to this one, fine. From product. Now what we can do? We have the filter also available. So filter called as mainly where product category equal to phones only. We need phones only, right? So we are categorizing within the product table. We are creating the buckets for only phones. So those phones are expensive phones, mid-range phones, and cheaper phones. So let's call this one as X. Okay. So first we'll try to execute this part. So this entire subquery will execute give to from class. So this one will call from X. Now here in this part, let's try to execute first. We need product details, right?
So keyword case. So case we have given here comma. Let's execute now. Product category. So product category we have to give here. So product category place. Actually we need product name and price. So invalid column product category. So that will get the from this part, right? So in this part we'll get the product name and price. So we'll try to include product name, comma price. We will execute case. Something case is and as phone category. Okay, fine. Select. So we'll try to remove this part star. We mentioned already column names. Till case. Select product name, price, case, when bucket equal to 1, then expensive phones. Okay. When bucket 2, then mid-range phones, else cheaper phones. Okay. And as phone category. Okay. From this one. Okay. Somewhere it is missing, right? As buckets from product, where product category. Phone. Let's check with the product category. Select to star from product. If I execute this one, product category, PRODUCT. Yeah, product category spelling mistake. Sorry. Product category. So if I execute this, still something product category and as so phone category. Okay. Product category. Something is missing. Incorrect syntax case. So case correct syntax only. Price comma. Okay. Okay, right. So I think some small mistakes happened. Okay. Now we'll look into the three categories, phone category. So for example, this one, three categories automatically taken, entile function. So what entile function is working called as mainly. So entile function is working with this, what we say, it distributes the rows as evenly as possible into three groups. So that is the entile function will work. So entile is function divides the three rows into three buckets. That means three buckets called as the three groups based on the price in descending order. So that is the entile function will work here. So if you look into expensive phones, mid-range phones, cheaper phones, so exactly it will whatever the price is given, so it will split the data automatically. So what we say, the case condition is, so we have created as one expensive phones, mid-range phones, and cheaper phones. Then entire function will work. Okay, right. So this is called as the completely covered as the SQL window functions and analytic functions. So almost all functions covered in the analytic window functions. If you have not seen the previous video, please look into the previous video. That previous video covered as one is row number, rank, dense rank covered. Then another video lead and lag covered. Okay, thank you. I will share this code in the video description and in the Google Drive link also I will share. So entire code will copy into the file notepad. I'll paste it into the Google Drive link. Thank you. Thank you for watching. Please like and subscribe if you like the content. Hello guys, welcome to my channel. So some of them are asking how to remove the duplicate data using window function. So I had done the video removing duplicate data in different ways I have given. But in that video, I'm not covered with window functions. So in our SQL series, I'm doing the videos step by step, right? So each and every concept wise. So at that time, window functions are not covered. So at the time, without using the window function, I had done the video removing the duplicate data. Now we will see the remove the duplicate data using window function. So which is one of the best method to remove the duplicate data. So this is, it's very simple also. This one, this is. So let's look into this example scenario. So first I will drop the table. So I will create one table, sample table. I'm creating the table called as the create table restaurants. So restaurants I have taken as ID, name, location, and manager. So for this, I have inserted some values. So in this values, I'm inserting some duplicate values. So if you look into this last two lines, two rows, one ping Warsaw M1. Same thing repeated here. And if you check with the 2 Jaitun Bangalore M2, the same thing I have given as some duplicate records of 4 records. So total row for ID number 2 repeated as 5 times. ID number 1 repeated as 3 times. If you look into the table inserted, right? Okay, table is not, values not inserted. Let's insert the values first and check with the restaurant data. So if you look into the data, so this way, so I have added some of the duplicate records, intentionally added some of the duplicate records. We had to remove these duplicate records. So for example, we have this output is mainly, if we check with the output, if we take screenshot this one, so we have the output called as, so this is the one unique record, 1, and other unique record called as this one, 2, and other unique record called as 3. So these duplicate records I have added intentionally, that is 4 records, 2, and 2 records for this ones I have added. But our final, with after duplicating records, after removing, we have only 3 rows. Okay, so these 3 rows how we'll get? By using window function. Let's look into this. So here I have created as one CTE with CTE as select. So first we'll retry the ID. Okay, then I'm writing with the function, window function called as the row number. So row number over partition by ID. So what happened if you partition by ID? So after partitioning by ID, what happened? So first partition, so it will check as 1. So once it will give us the 1, 2, 3, 4, so on. After then second partition, so second one again 1, 2, 3, 4. So like that, the partition will assign as row number. So row number over partition by ID. After then order by ID as RN. So this row number will create from restaurants. If you see this table, how it will created. So first of all, here the partition is created by ID number 1. So if you check with the ID number 1, row number is 1, 2, 3. If you check with the ID number 2, so 5 times. So again 1, 2, 3, 4, 5. So row number is created. Okay. Now what we can do is, so up to this one CTE. This one I have put the CTE. Now delete from CTE where RN not equal to 1. So where RN not equals to 1, those records it will remove. Okay. So let's try this one. 6 rows affected. Okay. Now we'll check with the select star from restaurants. How many records? We have 3 records, 1, 2, 3. So in our table also we need these 3 only. I have shown this one result, right? 1, 2, and third record. So these 3 are the unique records, these 3. So we are getting also the same thing. Okay. So if you have the number of records, millions of records also, this scenario will work. So this is the best scenario we had to use with window function to remove the duplicate data. So this is in SQL Server. If you are using with PostgreSQL, you have to try with the CTID. So that is CTID will work as in PostgreSQL only. Okay. I will share the code PostgreSQL and SQL Server. Both the code I will share in the video description. Let's try. Thank you. Thank you for watching. Please like and subscribe.
Hello guys, welcome to my channel. So today's video is recursive CTEs. So this recursive CTEs, it will impact very much in the SQL. So how it is working and syntax and some examples, we'll look into this. So first of all, we'll look into the syntax. So the syntax is, first we'll write as, we know how to write the CTE.
Similar way, we'll try to write as the recursive CTE also with CTE as. So in normal scenario, CTE also will write as this way only. But in PostgreSQL, recursive CTEs will try to write as with recursive CTE. But in SQL Server, we are not using the recursive keyword with the class. Then after opening the within the CTE, open the braces. Next, select query. So this is the base query. So first we'll execute the base query, the first iteration. So base query is mainly it's starting the point, like the starting point of the recursive CTE. So it is executed only once during the first iteration. So it can't execute repeatedly. So the base query will execute as only once during the first iteration. After then, we'll use the as recursive part. So that recursive part has union or union all. So in SQL Server, we will use as union all. In PostgreSQL, we will use union. So this union or union all recursive part. So this one. So this recursive query is executed repeatedly. So the recursive query is this part. So select query, recursive query. So this executes from the second iteration onwards until the last iteration. So until the last iteration called as until the termination condition is met. Okay. From CTE, where on termination condition. So where termination condition is met, it will stop the execution. So here the execution part is so each iteration uses the results from the previous iteration. Each iteration uses the results from the previous iteration. So that is the rows from the CTE in its last state to generate the new result. So that is like CTE. So when we are joining the like how we can say like the CTE back to the base table are performing a similar operation to extend the results. So that way we will execute the this recursive part. After then termination condition. So how it is working the termination condition called as when this condition fails, the recursive stops. So that is that the recursion continues until the specified termination condition fails. So that way we'll execute. Then finally we'll write as the final select statement. So this final select statement, the query to retrieve the full result set after all the iterations of the recursion complete. So this is the small execution of the basic syntax. So in this scenario, mainly we have to understand three parts. First part as the we'll write as base query. So base query, it is executed only once during the first iteration. Second part is recursive query. So in recursive query, we'll try to write as union or union all. So this recursive query is executed repeatedly starting from the second iteration until the termination condition is met. Then third part is final statement. So this final statement is the final query retrieves the full result set after all iterations of the recursion are complete. So this way, the recursion CTE will execute. We'll try to execute some example. So the example we'll try to write as so print numbers 1 to 10 without using any inbuilt functions. So we'll try to write as with. So if you write in PostgreSQL, try to write use the recursive keyword also. Here I'm not using the recursive keyword with CTE as open brace. Now we'll try to write as the first base query. So the base query we'll write as I'm writing as select 1 as num. So why I have written as a select 1 as num? Here my question is to print the numbers 1 to 10 without using inbuilt functions. So to print the numbers 1 to 10, like 1, 2, 3, 4, 5 up to 10 numbers, then condition fails, then stop the condition. Okay. So this is the base query first. Then we will try to write as union all. So once the union all call is from here onwards, it will start as the recursive part. So recursive part as select 1 plus num as num. So what happened here? 1 plus num. So num already I defined as 1. So each iteration it will add as 1. So 1 plus num from CTE. So this I'm pulling from the table name as CTE. So already I defined the base query as select as 1 num. So this already stored in the temporary result in CTE. From CTE, now we'll try to write as where condition. That is termination condition where num less than 10. So when number less than 10 reaches, so it will stop the condition. So that is the termination condition. Then we'll write the result set. So the final query, select star from CTE. If I try to execute this part, how it will work? So it will display as 1 to 10. Okay. Just look into the result. So 1, 2, 3 up to 10 results. So how it is working the iterations? So we'll see. So first iteration. So first iteration called as that is the base query. So select one as num. So if you look into select one as num, if I execute 1, then second iteration. So union. So every time it is the recursive part is to be unioning. So union called as it is adding the numbers. So second iteration, if I execute this part, select num plus 1 as num. So it is add 1 plus 1, 2 from select one as num CTE, where this one. So if I execute this part, I get the 1 and 2. Similarly, third iteration, select num plus 1 as num from class, again num plus 1, then base query. So if we execute from this part up to third iteration, so 1, 2, 3. Similarly, we'll try to execute as the below fourth iteration also. So this fourth iteration called as, we get the result 1, 2, 3, 4. So this is the one simple example and easy to understand, like recursive CTEs. Okay. Now we'll look into the another scenario. I will explain the scenario. First, I will create the table. So table dropped, and I will create the table called as EMP details. Now we'll try to insert some records. Getting insert records. So how many records I have? EMP details have 10 rows. Now our scenario is find the hierarchy of employees under a given manager Asha. Find the hierarchy of employees under a given manager Asha. So here we have to try to give the details of hierarchy. So within the organization, so for example, myself is reporting to some X person like Reshma. So Reshma is reporting to some Y person. Okay. So like this, so within the organization, we will report to one manager. So the organization structure we have to display here. So this organization structure called as, so mainly how it is working with the organization structure is, so like by using what we say simple example called as, so simple example is, so for example, we'll try to take this snapshot. Okay. So here our question is find the hierarchy of employees under a given manager Asha. So Asha, first we'll check with the Asha record. So Asha ID is 7. Asha reporting to 1. Okay. So 1 is manager ID is 1. So 1 is reporting to null. So this is the main organization structure, CEO. Now, who will report to Asha? 7. Asha ID is 7, right? So if you look into Asha, Asha acting as manager. So who will report to? So this is 7, right? 7. So Michael is reporting to Asha. Arvind is reporting to Asha. Next. Again, we will check with Michael. So who will report to Michael? So Michael ID is 5. So 5 is these 3 guys. So Satya, Jia, David is reporting to Michael. Next scenario, we'll check with Arvind ID also, 6. So Arvind is not acting manager in this scenario. So then stop the condition. Else, if anyone after this, so next recursive part is Satya. So Satya ID is 2. So 2 is not acting any manager. Next 3 is not acting any manager. 4 is not acting any manager. So like this, we'll try to build the organization structure. So let's look into the scenario. So here scenario is simple thing. First Asha. Asha is reporting to Asha is acting manager to 2 people, like that is Michael and Arvind, right? So in this scenario, Asha ID is 7. So seven acting manager is Michael and Arvind. Okay. Now Michael will consider. So Michael will acting as to manager Satya, Jia, and Arvind. Sorry, not Arvind, David. So David. So this is the organization structure we had to show. So first we'll try to write the with class with CTE as, if you're writing in PostgreSQL, you'll try to include the recursive keyword also. Now the base query. So base query called as in this scenario, select star from EMP details where name equal to Asha. Okay. So this is the base query. So base query already we know. So here also we given the manager Asha. So if I execute this part, I will get the Asha details. Okay. Now we'll try to write the recursion part. So first step is you can write with union all. Then we'll try to write the select statement. So in select statement, from I will pull the table as the base query is to be stored as in CTE part. So from CTE, now I will join with CTE to EMP details on. So EMP details table, I have the manager ID. Okay. So now I want to know the employee ID is reporting to manager. Which manager? So I know employee ID. So employee name. I want to find with the manager name like. So if you know the previous videos I have done with the self join. Here also we will try to like the self join. So not in this case self join, but like self join. But in this case it is not the self join. So we are using two tables here. Already we have built with the CTE. CTE is in this CTE part we had to get the details from the Asha CTE base query. But here join with employee details. So this is the original table on e.manager ID equal to CTE.id. So once I done with this recursion part, then I will try to write with the select part. So select to, I will try to get the e.star. So e means employee details. So all the employee details I will get. Now I will write with the main query. So main query is select star from CTE. Okay. So if I execute this part, I'm getting error where it is getting the error. Union all. After then select part. Okay. Select CTE. CTE join EMP details on. Okay. We'll give the alias name E on. Okay. Now I will get the result part. So the result, how I get the result. So now we'll check with the conditions. So first part is Asha. So Asha ID is 7, 1. Now Asha ID is 7, right? Asha ID is 7. So 7 report, 5 and 6 is reporting to 7. Michael and Arvind. Like the same. Michael and Arvind reporting to Asha. Next, Satya, Jia, and David. So these three guys are reporting to Michael. ID is 5. Michael ID is 5. Okay. After then, there is no organization structure. So reporting organization structure. Okay. So this is the way we will try to get the recursion CTEs will execute. That is the to find the hierarchy of employees under a given manager Asha. So now we'll try to understand how it is working the same part. So first iteration, base query, I told, right? So base query, select a star from details where name equals to Asha. So what I will get? First Asha details only I'll get. Then second row, second iteration, second row means second iteration called as select e.star from and base query. Then I'll add the CTE. So if I union all these two statements, if I do union all this complete, I'll get the these two records. So if I execute this one, second iteration, I will get the this one. So if I do union, it will add the 7 and 5. 7 means Asha details, Michael and Arvind details also union. Similarly, third iteration. So if we execute third iteration, 2, 3, 4, and fourth iteration, if any fourth iteration also we will get. So there is no fourth iteration. Okay.
So this way we will try to get the recursion CTE. Now the same scenario I'm using with another way to rewrite the above query to display only employee ID, employee name, and manager name. So only to display employee ID, so employee ID, so employee name, and employee name is reporting to which manager. Okay. So first we'll write the base query with CTE as next. Here we'll write the base query. So base query, first we'll write the CTE, next we'll write the base query, right? So in this first iteration, what we had done, we have get the employee ID, emp.id as employee ID, next employee name, next manager name. So how I written this conditions called as, so here if you look into join condition, so join is like self join. So in this case we are using exactly self join. So if you look into the employee details, so employee details, I will get the first self join is emp one table. Second table I'm giving the renaming to mng, so manager on emp.manager ID equals to mng.id. So if I execute this part, so it will get the each and every employee which reporting to manager. That is the first iteration. Next, we want only where condition. So where Asha details. So then I will get the first iteration. This, so up to this is the base query. Next recursive part, same thing. I will build the with CTE. So this CTE stored as a base query. Now I will try to build with the same recursion part. So join emp details on above already we written, right? So this is the same condition only. Okay. So join and final results at this one. So if I execute this part, okay, we will get all the iterations. Iteration number also we specifically we are getting. Okay, how we are getting, so because I have written as iteration plus one as iteration. How many times it is iterating. Okay, so employee ID Asha is reporting to Tripath, and Michael Arvind is reporting to Asha. Satya GR David is reporting to Michael. Okay. So same thing if you are working with in Oracle like this way. SQL Server already we done, right? Okay. So this is the one scenario to work out with the recursive CTEs. Thank you. Thank you for watching. Please like and subscribe if you like the content.
Hello guys, welcome to my channel. So today's video is mainly pivot 2. So in SQL, we will discuss about with the pivot operator. Today's video. So basically, what is the pivot 2? How it is working? So basically, pivot is one of the operator. So how it is working called as basically, pivot is transforming data from a long format to a wide format. So long format called as, so for example, if we have the data called as, so example, employee name, year, and total pay. So employee names are available, years are available, total pay, 3 columns of data. Now I want the data year column, we have to split into columns. Let's say example 2011, 12, 13, 14. So these 4 columns we have to split into columns. That is the pivot operator basically will do. So what exactly pivot column is mainly, which is reporting purposes. Mainly it will be useful for reporting purposes where you want to display data in a more readable and summarized way. So exactly what pivot is going called as, it will convert from rows to columns. Okay. So let's look into some scenario. Later we'll look into the how it is working. We'll look. So first for this pivot, I'm creating one table called as SF public salaries. So just I have taken the simple database called as ID, employee name, year, total pay, job title. So first I will drop this table. Okay, then we'll create the table here, this one. Once the table is to be created, we'll insert some records. So here, let's take here, I'm taking some 200 number of records, for example. So this data I'm inserting. Okay, 200 rows. So I have inserted. Let's check with the data. Select a star from SF public salaries. So if you look into this data, I have the columns are ID, employee name, year, total pay, job title. So around 200 rows are their data is to be stored in the particular table. Now
First, we'll check with the how many number of years data is available within the table. Like unique records, we had to check with the year. So by using distinct function, distinct keyword, we will check with the unique records. So I have the year column 2011, 2012, 2013, and 14. 4 years data is available. Now we'll try to write the first syntax of pivot. So in SQL Server, how it will write with the pivot, like converting rows into columns. So this rows into columns called as, so here I have the 2011, 12, 13, 14. So if you check with the data, so in this year period is there, year column. So this year column, we have to split as like 2011 one column I want, and 2012 one column, 2013 one column, 2014 one column, like this. Okay. So let's look into the query. Exact query we have to check. So exact query is I will type the query here for better understand purpose. So what is the query here? It is asking. Somewhere I have seen the query. Yeah. So the query is here. Okay. I will type here. Identify the highest salary each employee made for each year, and represent each year salary in separate column. Okay. Okay. So here my question is here, identify the highest salary each employee made for each year, and represent each year salary in separate column. Okay. So if you understand this highest salary means, so we'll apply with the aggregate function called as max. Each employee and each year also. So generally, how if the question is to be seen each employee each year called as, directly we will apply as the group by. So group by employee and year, and apply with the aggregate function called as the max of salary. But the condition is here, represent each year salary in separate column. So if we apply with the group by, all years will be shown as in the same format, like one column only 2011, 12, 13, 14 will display. But our condition is to split the rows into columns. So that is by using pivot in SQL Server, one of the operator called as pivot operator. Pivot operator will split the rows into columns. Okay. Now I will look into the syntax of pivot. So this syntax of pivot is, so first we'll write with the select star from. After then we'll write base query. Okay. So now this base query completely it will store as X. Like up to this part will save as in X. I mean base query will be stored as in X. Now directly we'll write as the pivot keyword, and within the braces we'll try to write with the aggregate function. So in this case, our aggregate function called as the max of, what is the column name? Max of highest salary total pay. So max of total pay. So max of total pay is the aggregate function in our case, and list of columns. So list of columns called as, so for example, if you check with the distinct year, so I have 4 columns are available, distinct year. So sorry, not 4 column. In year column, 4 rows are available. So these 4 rows will convert to 4 columns. That is list of columns. Now, what is the base query? So base query called as, so first we need, what are the details we need base query? So base query, I want the details called as, first thing employee, each employee. So employee name is required, each year column is required, and highest salary. So total pay column is required. Just simply we will try to write with the base query. Base query called as select from, so the table name as SF public salaries. Now here I will try to
write with the column names. So column names are select. So we have the base query we are writing, right? So first base query we need employee name, comma, next year. So directly I will try to write as year. Next to salary column, that is total pay. Total pay. So this is the base query. If I execute this part, I will get the employee name, year, and total pay. So now what I can done in the syntax, I have get the this details. Base query I have get. Next aggregate function called as aggregate function directly will write as max of total pay and list of columns. So this unique distinct columns, distinct year. So we know that distinct years 11, 12, 13, and 14. So directly we'll write as list of columns as 11, 12, 13, 14. Okay. Now we'll apply with the same syntax. I will copy this one to below. Okay. Now I know the base query. So I will copy the base query. Simple base query I will remove as and replace to this part base query. So base query I know this up to this part. Okay. So we are getting these details: employee name, year, and total pay. Up to this part, fine. Now we will apply with the pivot and aggregate function. So aggregate function called as, so here we in this case aggregate function is max, highest salary, max of total pay, comma, total pay, comma is not required. Directly we'll write with the list of columns. So list of columns are for each year. I'm writing with the in operator here. In. So in this one, we'll write as 2011 close, comma, 2012, comma, 2013, comma, 2014, and close. So up to this part is fine. Okay. For each year, so total list of columns we have written. If I execute this part, how it will look. So basically our data is looking as, I will show the data again. So this is our data, actual data. So this actual data we will split into columns, that is year column. So now I will apply with the pivot year. So where is year? Incorrect syntax in year. Like okay, some year column. Okay, here I will try to write as column names, employee name, and year in select part. We'll check with how it is working. Incorrect syntax year. So for each year, okay, for each year, not this one. Okay. So for year, column syntax is I think wrong. Now we'll try to execute this part. Okay. Now I am getting all the columns. Okay, select a star from. Okay, all the columns, but the year column is to be splitted into columns 2011, 2012, 2013, 2014. Okay. And each employee name also, which is, so each, for example, Aaron max highest salary is in 2012, that is 91903.92. Similarly, each and every employee I'll get the details. So total how many number of employees are now 198 rows is there, 198 unique employees. I'll get the data. Now our question is here, we have to replace with nulls to 0. How we'll write with the null to replace with the 0? So in SQL we have the function called as coalesce. So coalesce function we'll try to write implement with this one. So here I will write as in place of star, directly I will write with column names, employee name, comma, year. Now I will execute this part once again. So employee name, again one E missing. Year column, year from. So year is year column. Year column correct only, I hope. So in this year, we'll apply with whole ESC, police. COALESCE, police of. Now I know the column names 2011, 12, 13, and 14. I will apply with the column names as 2011 and will replace to 0 as pay 2011, comma. Same thing will copy to other years also. And 2012, 13, 14, and here 12, 13, 14, and remove this one. Now I will try to execute this part. Okay. So exact result with the same with replacing two null values to 0. So here I have no null values right now by applying with the police function. So Aaron called as 2011 0, 2012 this salary highest pay to 13 and 14 0. Okay. So this is the way we will try to implement with the pivot function. Now we will see the how this query is to be executing first of all. So this query we will try to divide as this complete query we will divide as 3 parts. So first part is the base query. So base query called as this one. This is the base query. Here I will try to mark as base query. So in this base query, the column names are, to retrieve the column names are employee name, year, and total pay from the SF public salaries. This same thing will store into the X. Up to this is the subquery, right? This is the subquery like base query I have written. So this one will store this one. Next we'll apply with the pivot operation. So what we'll do the pivot operator called as pivot operator transforms the data by rotating the year. So year values are 2011, 12, 13, and 14 into columns. So the values, whatever these values are there, these values will convert into columns. Next, in pivot we have apply as one is the aggregate column, aggregate. So this aggregate function and list of columns. So aggregate function called as the max of total pay. So max of total pay function is used to get the maximum salary for each employee for the respective year. Okay. Next, the resulting data set will have one row for employee with, for example, in the result data set, year column is 2011, 12, 13, 14. So here we want the resulting data set, we will have one row per employee with separate columns for the salary in each year. The years are like 2011, 12, 13, and 14. So we'll display this. These are all the list of columns. Next, third part we have apply as police function. So why we have applied this police function called as, this function is used to handle the cases where an employee might not have a salary for a specific year. For example, Aaron has 2011 null. So that specific year, if the salary for a given year is null, it will be replaced with 0. Okay. So this is the complete query explanation of applying with the pivot. Okay. Thank you. Thank you for watching. Please like and subscribe if you like the content. Thank you.